Wendy's. No,
All right,
no, you know, that one.
So clarifying
So one of
questions
the-
are always welcome. If you don't understand something, chances are someone else doesn't understand the same thing. The point of having somebody talk, we don't know what they're talking about. Anticipatory questions are strongly discouraged, so don't ask, will this be this or will that be that? Future tense questions in general. They're much more useful when the actual result comes up on the thing, and then that's the time to dig in. Just on the internet stuff, so the live stream, so people can hear us, we should try to use the mics to the extent possible, but for a quick clarifying question. My view is if the speakers could just repeat like kind of the point, like, oh, you're asking what X is, this is X.
Just repeat.
So we don't have to keep scrambling around for my.
That's a good idea.
But for longer, kind of deeper questions that you want, once we get the stuff up there, you might want to throw out the mic so people can hear it. Want to listen to anything?
Yeah, NBR code of conduct is.
Oh, yeah, you gotta do the NPR, yeah.
Be nice.
Yeah, we've all read it, we gotta do it. Yeah, the point here is to be constructive and make the paper better. So let's try to keep that in mind.
I'll say one thing. So the discussion leaders can both ask questions, but they can also, if you think you can help the presenter explain what they're doing better, if you can be like a, you know, co-helper in that regard. And it's supposed to be more like a regular seminar style. All right.
Okay, so we're gonna, very excited about our first paper, a macroeconomic model of cross-section on currencies. And Alexei is gonna present. I'll give you 15 minutes when we have
Okay, you give me 15 minutes until the end.
Yeah.
Okay, I got the rules, repeat and rephrase the questions of the from the audience, and okay, I'll go. So thanks a lot for including me on the program. This is a joint paper with Diego, who's at NYU. We're asking in this paper what drives the cross-sectional variation in bilateral exchange rates. This is a very old question. There's been a lot of progress on this in the international finance literature that documents that most of the variation in the cross-section of currencies is captured by two dominant factors. There's also in parallel been a lot of advances in international macro literature that comes up with ways to map macro shocks into exchange rate variation. And we're going to build on that. That literature mostly focuses on a single exchange rate, working with two country models. And so it's silent on the cross-section by design. So what we're going to do in this paper is try to connect these two literatures by building a macro model that fulfills two goals. First, we're going to give a macro interpretation of the factor structure of exchange rates. And second, we're going to see what we can learn about the drivers of exchange rates from the new cross-sectional moments. New to the macro literature, of course, not new in general. So it's going to be a...
If you want to walk around, you can pick it, then you can walk around.
Okay, thank you. So it's going to be a model with heterogeneous countries. It's a global economy. Countries are going to be heterogeneous in two dimensions. It's going to be key. One is the dollar asset holdings, and the second is their intensity of commodity exports. Asset markets will be segmented and intermediated. This is the cutting edge techniques in the macro models. The main result is that exchange rates in this model are going to fall into a two-factor structure. There's going to be a dollar factor, which is literally the dollar movement against the average currency. And then there's going to be a commodity factor, which is literally the movement of high commodity currencies versus the rest. Now, we provide a macro interpretation of those factors. This is to say a mapping from macro shocks to this time series. Both of them have a real and a financial source. The dollar factor is going to combine US output shocks and then repricing of the risk that emanates from US output. The commodity factor is going to combine the global business cycle and then repricing of the global business cycle risk, real and financial in both. We then take the model to data where these two factors explain more than half of the variation in exchange rates in the cross-section. And then we find that the factor loadings are very well explained by dollar asset holdings and then commodity exposure of the countries, which is why we put them in the first bullet point there in the model. The results are going to allow us to decompose bilateral exchange rates into drivers. We're going to show you two dichotomies, basically, local versus global shocks for every currency, and then real versus financial shocks for every currency. I'll show you the results, but the main conclusion here is that the drivers of exchange rates, the relative importance, depends a lot on the commodity exposure and the dollar assets. So basically, there's no single answer to what drives exchange rates. You have to look at these two cross-sectional variables at least. They provide a good guidance. I won't dwell too much on the literature, just need to acknowledge that this literature has been written by some people in this room, like Shebnem, for example, with heterogeneous impact of repricing of global risk. We're following very closely Adrian and co-authors, and then some work of Dima and co-authors on the macro side. Okay, everybody okay if I go there?
Thank you. And what's with that?
Yeah, I'll explore the room a bit. The camera is still there, but maybe it's not. Okay, the model. So this is a collection of countries. There's a continuum of countries. They live on the segment from 0 to 1. And then there's the US. The US is a mass point. It's big. Now, each country is very simple. It's a household and then what I'm going to call a central bank. The household is solving a standard problem. Each country has a non-traded good that is specific to this country. There's also one tradable good for the entire world. It's a single tradable good, so its price is normalized to 1. It's also the numeraire. The relative price of the local non-tradable good is PN. And then QN here is going to be the price of the local consumption basket. It has this simple form because of Cobb-Douglas. Now, what the household does is it consumes its endowments, it saves in local currency bonds, where by local currency, I mean local consumption basket. They pay you 1 unit of consumption basket tomorrow. And then the household also receives fiscal rebates from the central bank and the profits from the global financial intermediaries. I'm going to work a lot with these objects. This is the real exchange rate between country I and J, and this is just the ratio of the relative prices of consumption baskets. The model is fully real. There's no nominal layer here. Okay, the agent number 2 in this country, oh, sorry, before we go there, what are the endowments? I have the specific functional form for the endowments. Now, the non-tradable endowment is going to be hit by local shocks. They're idiosyncratic, uncorrelated across countries. In fact, independent across countries. The tradable endowment is slightly different. It's going to be hit by one global shock. This is the global business cycle. Now, countries have heterogeneous exposure to this global shock. It's called EI. It's in red because this captures country heterogeneity that is permanent and exogenous. Everything in blue is exogenous shocks. Now, this country-specific exposure varies, and it's going to be the driver of the commodity cycle, differential exposure to the commodity cycle. In the paper, I have a micro foundation for this. I'm not going to show it now in the interest of time. So what happens in the micro foundation is there are two goods that are traded, primary inputs and final goods. And then countries have different endowments of primary inputs, EI. They map into the commodity incidence of countries. They're going to map in this simple model exactly into EI that is here multiplying the global shock. And then the Z, the global tradable output shock, is the productivity of commodities or primary inputs in your production.
Commodities, do you mean the normal use of word commodities, or did you just mean some more abstract?
I mean primary inputs.
Say commodities. Define what you.
Yes, I mean primary inputs used in production, like oil and energy commodities, sometimes even food. Something that is produced not using labor, but just, we think of this as endowment in the land. The agent number 2 in the country is what I call the central bank. And it has a very simple function here. It accumulates external assets for the country, external dollar assets. We can call them reserves because this is what they look like. But I actually want you to conceive of this as a broader dollar accumulation of the country. The fiscal rebate here is just the profit from accumulating those dollar reserves abroad. I call them dollar because they pay in US consumption baskets. So this is the bonds that pay in US consumption baskets, and they pay the US interest rate here. Every country has its own accumulation process, MI. M is going to be what I use for the dollar assets of country I. Now, we stipulate a super simple reserve policy. This reserve policy is different across countries in the target level of reserves, MI, and then the level of reserves reacts to the dollar exchange rate. Specifically here, when the dollar appreciates, you realize some capital gains. When the dollar depreciates, on the contrary, you buy more dollars. So this is a buffer policy. It stabilizes your exchange rate through realizing those capital gains, paying the capital gains to households, increasing their consumption, and strengthening the local currency this way. Yep.
I found that part a little bit difficult when I read it. So why would the central bank do that? Why would they target the level of dollar assets? And why would there be differences across countries in those targets?
This is a great question. So first of all, disclaimer, to be upfront, this is not something we endogenize in the paper. It is doing a very good job for us empirically, but we do not explicitly endogenize it. There's a very large literature that documents and explains the difference in target level of reserves and reserve stabilization policies across countries. One channel that might generate this in the model where this is endogenous is domestic policy uncertainty or asset dollarization within the domestic financial system, like deposit dollarization. And in some countries, the central bank in that literature finds it optimal to hold more dollar reserves for domestic stabilization purposes. For example, because it fulfills the lender of last resort function, partly. I'm not going to microfound it in this paper, but it is important, and it's the second and last source of heterogeneity across countries. It's green because the dollar is green. So I just wanted to color code the everything. Yeah.
If I were your referee, I would actually push you into microfounding this because there's going to be, it's your key result later, right?
True.
Yes,
that's true.
That's where you want to push, I think.
That's true. Yeah. I actually even see, we might want to add a microfoundation, and then in the end, there's still going to be another source of heterogeneity between countries that is exogenous, but there's going to be one more layer that makes this policy endogenous. And this would make more sense.
Maybe to explain to the room, the reason I push that is because the idea that countries differ in the amount of oil reserves and how much that can explain things like carry trade excess return, this is already in the literature, but this is completely new and it's going to give you a fantastic result in the end. So I think that's what you want to push. So you want to push on why they do that and why there's heterogeneity, but then also on the dynamics. Because in your story here, I think you want to explain this out. The central bank is going to sell the dollars, right? When the dollar appreciates.
Exactly. Yes. So
both.
The MI, political economy frictions can give you a different MI. It takes some patience and some political economy commitment not to spend down your reserves when you have them.
Yes, another channel. Yeah.
So that's one micro foundation that why Chile can hold a huge amount and Argentina, not long, but Argentina can't, right?
Low blowing today.
But I guess, are you gonna argue this is like roughly what they actually do? Is the pretty decent positive description?
I'm going to show you supporting evidence of this from the time series and from the cross-section. And yes, because as Adrian said, this is a key mechanism in the paper. So we must have some supporting evidence from the time series, at least on the tau and MI, and it works.
But is it correlated with some other factors like the commodity bit? A teeny bit more restating, just a little bit in it.
Sorry. So now the question is MI in the data correlated with some other variables of countries? Yes. One of them I know is the share of the US in the country's trade. For example, we're going to find that this MI is very low for small European countries with their own currency, whose main partner is the EU and EMU, and they hold a lot of foreign assets in euros. And then countries that tend to trade a lot with the US, for example, have a lot of dollar assets instead of other currencies.
Because then there may not be two factors, maybe one. If it's the exposure to global shock, and exposure to global shock makes you hold more reserves, then the two factor is actually one.
Right. The question here is maybe the MI is correlated with the exposure to the global business cycle, which is captured by the commodities. Fortunately not. We checked that. Yeah, but thank you. Sorry. Yeah. Can this be negative? This cannot be negative. This is gross assets. Okay, now the second bit, as Mark said, is important, is the Tau part. So now there's this dynamic part to it. This policy actually stabilizes the domestic currency by reacting to the dollar exchange rate. When the dollar is expensive, it sells some reserves, realizes some capital gains, and then the domestic currency moves because there's more consumption. Conversely, when the dollar is cheap, we buy more dollar reserves, accumulate them for the future. I'm going to show you how this works a bit later. Now, one other thing I need to mention here is that Tau, it's going to be a parameter that we estimate, and it governs the strength of the stabilization here. High Tau, more stabilization. Okay, before we go to the intermediary, just wanted to, and before even stating the equilibrium, the relative price of non-tradables, at the risk of stating the obvious, is going to be depending on the marginal utility of non-tradable consumption and tradable consumption here. There is an Euler equation, which is going to help you later realize what is and what's not endogenous in the model for the local currency bonds with this local currency interest rate. And then finally, we can combine the fiscal rebates and reserve management with the budget constraint to get the country's resource constraint. Tradable consumption here is given by the tradable endowment, and then asset accumulation in two currencies, plus the rebates from intermediaries. Okay, the final bit now is the intermediaries. So markets are segmented. As I mentioned, countries only trade in their own local currency bonds and in this dollar reserve. Who intermediates those flows across countries? So this is going to be the global intermediary. It's extraterritorial. It has a zero capital policy, no net worth, and it takes positions in local currency bonds of all countries. Now, these positions, I'm going to call them AI. The zero capital condition reads as the sum of all investments in every day, in every period is zero. Now, because of the zero capital condition, I can actually write the intermediary's profits in terms of excess returns relative to the dollar. So for every return, the return on the dollar cancels out because every bond position has to be offset by US bond positions. So the problem of the intermediary is to maximize this expected discounted excess return on its portfolio. They use the SDF, lambda T, that I'm going to speak more about in a second. And then the second part of the portfolio management problem is this portfolio cost. So this portfolio cost, we needed to give us more stable steady state. Then in the analytical results, we're going to take the limit of a very small portfolio cost, but it helps us a lot with the steady state. Now, this is very simple. It just penalizes deviating from a simple uniform portfolio set at some benchmark level. For this benchmark level, we use the global demand for reserves. And this looks like a Black-Litterman model from late 80s, early 90s. The optimal portfolio here is going to be given by this benchmark plus the fundamental part. The fundamental part of country I's returns, expected returns, plus how these excess returns could vary with the intermediary's SDF, the risk premium part. Question? Yes. Yes, so the intermediaries just choose any sign of exposure to any bond. They have access to local currency bonds in all countries, and they can choose positive or negative exposure. The only constraint for them is this. It has to integrate to zero because there's no net worth. Now, it is endogenous which exposures are going to be positive and which are going to be negative is a choice here. The important part is that there's no net worth, so the assets, gross assets and gross liabilities are going to be equal to each other at the end. Yes, US is one of the countries. It's just a mass point because it's large. That's why it's not inside the integral. Yes, please.
You want to explain now a little bit more about the stochastic discount factor? Or are you going to do it in the next?
That's a slide. That's a separate slide of its own. Okay, so what is the stochastic discount factor here? So the stochastic discount factor comes from the households in this economy. It just combines the stochastic discount factors of households in the simplest possible way, where every household's stochastic discount factor is the marginal utility of tradable consumption tomorrow relative to today. because those returns are quoted in tradable goods. That's the numerator of the economy. This is what the stochastic discount factor of the country I looks like. Now we add just one more bit to the stochastic discount factor. We want to capture the variation in risk aversion of the intermediary to give us time varying risk premium. That's why we take the stochastic discount factors of all households and make it a mean preserving spread of that. The gamma here governs how much weight you put on the state dependent part. This governs your risk aversion, how important the correlation of returns and the SDF is going to be to you.
So the people are the ultimate owners in the two countries. Does this somehow arise, or is this just a simple extra set of assumptions about the equilibrium to make some stuff work? Normally you would think, if I'm the owner of you, you use my preferences. Now, if there's two owners, there's all this tricky stuff in finance. If you have multiple owners who don't agree about what you should do with dividends going back.
Mhm.
You're doing something about that. I'm not quite follow the motivation in this one.
I think the easiest thing to do here is going to be to think we're assuming this, which we are in the paper. Now, I could come up with stories how this arises in the bargaining problem between different owners of the stock of the intermediary. I'm not going to do that. I'm going to save time to go to results. But I think that's the right intuition. They have equal weights in the decision process of the intermediary, which you could think of equal ownership weights.
I know, but the main issue seems to be this aggregate shock associated with weighting the mean and the variance, right? Where does that come from? I can imagine if the gamma were constant, some complicated story you could tell, but then you got to think about why that gamma varies over time. So
Perfect.
what are you thinking about there?
So great question. I prefer to think about gamma as agency frictions. It's coming from agency frictions, or the intermediary being managed against by agents who might not be quite sure about the model of the returns they have to face. Now, why this varies over time, I'm not going to take a stance on this. This is going to be preferences varying over time. It is what it is. But I find this question really interesting to think about it more. So far, I think what we need to know for the results is that it's going to be an aggregate shock, as you said correctly, and it's going to be very important here, the small gamma.
Does this framework give you kind of down slope demand for currency? So the fact that other countries change their reserves will affect the exchange rate.
The fact that other countries change their reserves will affect the exchange rate. It's coming in 2 slides exactly. Now, I know that when you ask that, you usually mean, are the Aero-Debreu prices constant here? And they are.
But just to make sure, so once some segmentation to get this shock matter, right? This gamma shock matter.
Right.
But at the same time, you somehow want to relate this SDF to kind of global consumption to make sure, yes.
Yes. Yes. Yes. Yeah, that's the idea. Correct.
You didn't understand what you said. And about the argument prices, I thought the whole point was to make that move.
They move across time. They don't move with positions that the intermediary takes. So they're constant in that coordinate.
Temporaneous one that's sort of moving around, and so you put more weight in gamma versus 1 minus gamma. Is that what's going on?
That's what's going on. Yes. So this is just literally a constant, no risk premium coming from that. It's all going to come from here. Exactly. Yes, completely true. Yes. It's going to be like just to restate what Mark said, he said, it's a good way to make this a global risk aversion shock. I'm gonna clear the markets. Oh, sorry. I'm gonna state the equilibrium definition. So the prices.
He wanted you to go back.
Just go back one slide.
Oh, sorry, I didn't understand.
Right. I didn't understand why you have the second term, because exactly as was said, what matters for a risk premium is the covariance between the stochastic factor at t+1 and the return at t+1. You said the second term doesn't matter. So why did you put it in the model?
That's to normalize the levels more the levels of returns.
It's going to affect the level of interest rates.
It's going to affect the level of interest rates, exactly.
But you don't have.
It's not key to have it.
Yeah.
Yes. So what's key to have is the first part. And then if I just don't account for the mean is going to pop up somewhere else in another formula.
And one more question on the risk aversion. Why do you need it? Why do you need this gamma to change over time? I have a look ahead bias, right? I know what's coming next, and it looks like you can do it without.
So so what Adrian is asking is, I might not need the gamma shock for my main results. I do need gamma shock for to still do a good job on the more standard macro moments, like the disconnect moments.
Mean constant. That's why you have one gamma and then one minus gamma over d down. Because if you just move around gamma, you're changing sort of the average interest rate, right?
Yes. So that second part would pop up in the interest rates. Now, my exercise is also going to be giving a fair chance to gamma together with all global shocks. We'll just see what comes out. It tells us that something comes out and it's not zero, although it could have been, right? Potentially.
And one more, this is an important slide. You're going to assume power utility. So you're going to have an average of power utilities.
Exactly.
And so we know that the risk aversion has to be relatively limited. So
You know what?
We know that the risk aversion
has to be limited, right? It cannot be a factor.
in the households. Yes.
And so it's going to be difficult to produce large risk premia in a model that starts with power utility.
That's correct. Yes. So I could produce large static risk premia with this large gamma.
That could be another way to justify.
Exactly. Yeah. Okay, perfect. I'm going to define equilibrium now. Just the markets that are going to clear.
Campbell, Cochran, and others have this habit. Most, he's a finance guy more than me, but most of the successful asset pricing models have the power piece, then they have their story piece. Their story piece in Campbell Cochran is this habit. F times N is this other term about these complicated expectations, etc. And that is always doing the action, and the whole action is in that piece, and the power piece never does anything. You're sticking it in another way.
Yes, I'm sticking it another way. So let me restate this. Most of the successful asset pricing models use preferences with either time varying hedging motives or habits. Instead, and the power piece in those preferences is not doing much work. Instead, I found a way to make the movements in the power do a lot of work and make it more tractable. I also have another bit of work on this, unrelated to this paper, but happy to talk about it later. It's actually a combination of tractability and tractability. Okay, good. Non-tradable goods are consumed within the country, clears country by country. Tradable good, there's only one in the world, clears globally. Currency I bonds, again, clear country by country, and then the US bonds, a lot more participants in that market, demand for reserves, the intermediaries position, and the US household position. For the shocks, let me just restate the shocks here. 3 global shocks, the global commodity tradable output. The US local shock ends up being global because it's big and because reserves are in dollars. The gamma shock is obviously global. There are local shocks here. They're all going to be AR1. And then I simplify further and I do some of them unit roots, some of them IID. Okay, let's solve the model. That's quite a big model. We're going to simplify it a lot. So my solution concept is going to be, I'm going to find a steady state. I'm going to do a first order approximation around the steady state, but I'm going to keep the risk premia in the first order. Okay, how do I do that? Well, I use my gamma, large gamma, that I separate conveniently from the household preferences to not mess up the household side. And I'm going to take that gamma to infinity just as the volatilities of shocks go to 0 so that this product stays finite. In principle, all of the shocks can be priced in the first order. Let's think about the covariance and the pricing of those risks. The covariance of the intermediaries SDF and the excess returns of all countries. In the first order, this is what the SDF of the intermediary looks like. It loads on 2 global shocks. Remember, this comes from the average marginal utility of households. In the average marginal utility of households, 2 shocks are present. One of them is this global shock, and it's expected that the SDF should decrease in that global shock. When everybody has a lot more tradable output, everybody consumes more, marginal utility is lower. It also loads because the US is big on this US local shock, and again, negatively, so that when there's more output in the US, this is good times, the intermediaries SDF is low. This, I must disclaim here, depends on the elasticity of intertemporal substitution and the case that we prefer from calibrations gives us the right sign. Okay, so what is the takeaway? My IS is smaller than 1. Yeah, thank God. And this is going to be giving us interpretation of riskiness across countries. So a currency is going to be risky if it gives you bad returns when global tradable output is low. Think about commodity currencies. It's also going to be a bad hedge if it gives you bad returns when US output is low, which is when the dollar is expensive. Okay, so currencies that co-move a lot with the dollar are going to be risky. Currencies that co-move a lot with commodities are going to be risky.
So XU is the non-tradable shock in the US?
XU is the non-tradable shock in the US. I do use the IAD business for the rest of the non-traded shocks to get rid of them. This is where the average really helps. Yeah. Also notice that the gamma is not here. Gamma washes out from that average because it's redistributive. It just reshuffles capital flows across countries, more and less risky. Pat?
And if you did approximation around stochastic steady state, which you often do in things related to this, it's the same. Is that, would you get the same thing? Or does it matter here for some reason? I always see people thinking around stochastic steady state and deterministic. There's all these terms about affine type, all these approximations that if you do stochastic, it works fine. If you do deterministic steady state, it works crap. But I guess that's not coming up here.
That's not, so, okay, the question is, usually the deterministic steady state doesn't make a lot of sense in these models with risk because it kind of kills the risk. Stochastic steady state preserves the risk, and that's why approximating around the stochastic steady state is usually better. This double limit takes care of the risk not going away in the deterministic steady state. At the same time, this model is large. Heterogeneous countries, a wealth distribution is a state variable. That's why I haven't been able to fully characterize the risky steady state here, and this really helps me. Might give me more action. I don't honestly know. This is infinitely more convenient. Adrian?
I did not completely follow the explanation for the second term because you appeal to the US being large, but where's this notion of size in the model?
The notion of size in the model. So if we go back to what the stochastic discount factor is, it enters here as a mass point. There's the integral of all countries, and the US is a mass point in that integral. That's why US consumption matters.
Okay, so it only shows up in the SDF of the intermediaries.
Of the global intermediaries, yes.
When we write down the maximization problem, they are all the same. All the countries are the same.
The maximization problem is exactly the same for all countries, yes. It's only the size difference between them.
But, yeah, this feels a little bit like I'm picking some second order terms to keep in. And, you know, make some judicious picks and that's giving you sort of this same sort of representation. Is that a way to think about it?
So to be more precise, I'm picking all second order terms. I cannot just throw them away. Some of them do end up being zero conveniently. Yes, exactly. That's true. Yeah, there's a lot more algebra behind this. This is the ones that survive, but I'm also not just, you know, randomly throwing away terms. Good. How are the exchange rates determined in this model? So the exchange rate, for the exchange rate, I'm first gonna say something about the price of the local basket because exchange rates are relative prices, right? They steal information from you. We need to know each of the local prices first. The relative price of the local consumption basket is determined by your tradable consumption and your non-tradable consumption through marginal utilities. The tradable consumption is, well, this term, this is the endowment. If you have a high EI, then high Z times, you're going to get a lot of extra consumption. Your exchange rate is going to appreciate. Then there are capital flows. This is the flows in local currency bonds, the intermediary's position in your country. This is your reserve management or dollar asset management. Finally, the last part is just the non-tradable consumption. How do capital inflows work? So what do the intermediaries choose in along the cycle, the business and financial cycle? Their position in your country in the Fostora is the expected excess returns relative to the dollar. That's the expected appreciation and interest rate differential. Then there's this risk premium shock. This is how the shock to gamma transmits to your country. Notice, very importantly, there's the index I here on the limiting risk premium. And then finally, there's the third term that measures the overall expansion of the intermediary's balance sheet. For example, when the dollar is cheap, there's more demand for dollar reserves, according to the policy. So the balance sheet of the intermediaries expands and they invest more everywhere. Kind of consistent with the data as well. Now, what is this limiting risk premium? Well, this is just the limit covariance between the SDF and the currency appreciation of country I. I forgot the gamma should be in front. Sorry.
So, I'm a country, I want to save something.
Right.
All I can do is bring my local currency bond to an intermediary. Right, let's leave aside the reserve management, but basically I take my local currency bond and bring it to an intermediary. Then they're gonna say this bond is super risky because it's covariant a lot with Lambda, or it's super safe because it doesn't covary, and then that's how the risk premium goes.
That's correct. So to restate this covariance measures your ability as a country to get inflows from the intermediary. This covariance is endogenous to the properties of your currency. For example, it matters how your currency loads on the Z and XU, the US shock. So in the limit, it's going to determine how the intermediary, in your case, particularly responds to the risk shocks. And that determines your ability to get inflows and consume. And that also determines then how your currency appreciates or depreciates in response to these shocks. So all of this here is endogenous and the fixed point. Okay, main result here. So what's going to happen is when we go to bilateral exchange rates, they're exposed to 4 shocks. This is now bilateral exchange rate against the US. I'm taking some limits for tractability here. There are 4 parts to the bilateral exchange rate. Your differential versus the US exposure to the commodities. Now the US exposure matters because it's versus the US exchange rate. Your dollar assets, they do matter as well because when the dollar depreciates after a US shock, you realize some capital gains or capital losses. How much you do that and how much your exchange rate changes depends on your stock of assets here. There's this exposure to the risk shocks as well, depends on your country's properties, its currency, on the properties of the currency, of the riskiness, and on your residual idiosyncratic. What's convenient about this is that the risk exposure basically mimics the exposure to the fundamental real factors. Why? Well, because the exposure of your currency to the global commodity shock makes it risky. That's why it shows up in kappa, in the coefficient on gamma, in exactly the same form. Your exposure to the dollar shocks is what makes your country risky. That's why it shows up in the risk loading here, in exactly the same form. We can take advantage of this. How do we take advantage of this? Well, we can reduce the dimensionality of this cross-section very substantially to 2 factors. So I'm going to do this now in 10 seconds. Just rewrite the bilateral exchange rate against the US, group terms. There's something that depends on your commodity exposure, something that depends on your dollar assets. What depends on your commodity exposure combines this commodity risk and the risk shock. This is repricing of the commodity risk. What depends on your dollar exposure is this US shock and the repricing of the US risk. Okay? Now we can integrate out these dimensions one by one to arrive at the factors. Factor number 1 is the dollar factor here. As I promised, this is just the average of the depreciation of all currencies against the dollar. So when we integrate it and we assume the US holds the average commodity exposure, this commodity part disappears and we're just left with this. The dollar factor is a combination of the US shock and the repricing of the US originating risk.
Can I ask one clarify? So here the Z and XUs are uncorrelated, right?
The Z and XU, I haven't assumed that, and I don't have to. What I had to assume so far is that the US holds the average exposure to commodities. Kind of true in the data, or very close.
There could be underlying correlation between these.
There could be, potentially. If you're anticipating, then for identification, I'm going to assume they're uncorrelated, but everything also works if they're correlated. There's just a bit more parameters, like correlation, that I have to estimate. I'm going to do the same with commodities. So this is just the depreciation of high commodity currencies versus low commodity currencies. That integrates out the second part. One assumption here is that commodity exposure is orthogonal to the dollar asset share, and that's also very close in the data, very close to zero. Okay, so now this collection of shocks is a factor. This collection of shocks is a factor, where by factor, I mean a rotation of the panel of exchange rates. So it's just the time series of prices. And what I'm getting in the end is this two-factor structure. Each exchange rate is the commodity factor with the commodity exposure, the dollar factor with the dollar exposure, and then idiosyncratic residual. That's what I mean by the two-factor structure. Yes.
Go back to that, to the earlier slide, that orthogonality finding. No, the orthogonality between E and the MIs.
Yes.
So that's something that is there in the data.
In the data, correlation is very close to zero.
Because all the stories you're going to tell about heterogeneity have got somehow to be connected to that. I'm trying to think what stories you had in mind that would be consistent. Because you'd think that those two would be related in some fashion. If they are in fact orthogonal, something, I don't know. It's an interesting observation.
Yes, and this orthogonality in the data is what's giving me some confidence that the MI is not capturing the same thing that EI is capturing. So it's not a single factor model. So I have to look for other explanations for MI. I think that's a positive for us. Okay.
But just going back, is this relationship only true for reserves? If you looked at dollar assets held privately, are they still correlated?
We actually don't even look at just reserves. We look at dollar assets held overall dollar assets, portfolio plus reserves. That's where it's the strongest. Dollar assets overall, portfolio plus reserves. We also do this by type of reserves and different weighting schemes. It all works, although the strongest is like overall dollar assets. That's why I was pushing for the interpretation of broad dollar asset accumulation of the country.
So it's not critical that that all the action goes through the reserves and the reserve rule, right? It could just be private agents holding treasuries, for example, and that appreciates, and then you still get this pass-through to exchange.
Exactly. It could be just private agents holding treasuries and realizing capital gains in a specific way.
Yeah, that caveat is critical, that they have this mechanical rule.
Yes.
For how they realize capital gains.
Yes. So let me restate this again. It's critical that my capital gains rule works as it does. Okay, let me go to the empirical analysis real quick. So this is the regression that we just ran in the model. When you run this in the data and measure how much explanatory power it has a lot of explanatory power in the cross-section. Here I'm plotting the R-square of this regression. Notice this is time t on time t, right? This is not prediction, forecast, anything. It's just in sample contemporaneous. The R-square is almost as high as the R-square of the two principal components, which is kind of the upper bound you could think. So this is a lot of variation. And then on average, it's going to be about a half of the variation, slightly more than a half of the variation in the cross-section. So this is the commodity factor, and this is the dollar factor. Let me go back here. So the dollar is just the average depreciation of all currencies against the dollar. In the data, it's a sum instead of an integral. The commodity is the average depreciation of high commodity currencies here versus low commodity currencies. Yes, and here, literally, what I'm using is my micro foundation has a mapping from E to the share of primary inputs in your exports. I'm sorting countries by that to get the high minus low portfolio. Loadings on the cross-sectional heterogeneity here. One thing to pay attention to is this dollar beta. There's a lot of variation in this, which means the dollar factor is not a true level factor, in which case the betas would be all one. There's a lot of variation across countries. And as Adrian tells us, we're kind of the first ones to come up with a measure that is as good as this. Okay, so more evidence. I'm going to go over this very quickly. We provide a mapping from macro shocks to factors. Macro shocks obviously are not observable. They're exogenous disturbances, but there should be supporting evidence if you use proxies for those unobservables. Unobservable exogenous shocks. We do find that in the data, the dollar factor goes down when non-tradable employment in the US goes up, consistent with our mechanism, and when risk measures go up. Sorry, it increases in the measures of risk stress, like VIX, EBP, and the inverse of the leverage of the intermediaries. The commodity factor decreases in commodity prices and again increases in the risk measures, consistent with what we find in the data. It also captures very similar variation to factors that you can obtain from trade centrality. Thank you. When you sort countries by their trade centrality or when you sort countries by their interest rate. And in fact, it's very close to the carry factor that Adrien studied. Captures almost exactly the same variation because the sorting of countries is very close. This mechanism that's very important, the heterogeneous exposure. Yes, the overlap between those two sortings is very high. Carry and commodity. Now, what is the relevance of foreign asset accumulation in dollars? So we have data on those foreign assets and their accumulation. We have also data on the share of dollar in foreign assets from CPIS. So we can construct the measure of dollar asset accumulation and decumulation quarter by quarter and compare it to consumption. Right? Compare it to consumption, both in magnitudes and also in time series correlation. We find that the time series correlation is negative as predicted by the model, although not -1 exactly. And the the relative magnitudes are also about 30%. So the capital gains are about 30% of consumption variation. Not negligible. There's more additional results here. I'm going to skip this because nobody asked, but this is like frequently asked questions in finance. So what we do for quantitative analysis, we're going to bring in some moments. There's one thing that I'm not showing in the interest of time. There's a analytical mapping in closed form from the moments of the shocks, the global shocks, to the moments of the factors. It's not linear, but it's invertible with pen and paper. So what we do is we can pick exactly the moments of the factors and match them in the data by picking the moments of the shocks. We also match the volatility of the residual that is country specific, the volatility of the exchange rates almost exactly. Importantly, the average R-square of the factors. That's how much global shocks explain in the average country. And then the standard deviation of the dollar loading by disciplining the parameters on the dollar assets, including we also estimate tau externally from the process of external assets. Now, some untargeted moments. So we only target the standard deviation of these loadings. This is what the loadings look in the data and in the model, the coefficients on the dollar and the commodity. This is what the R-square looks like. The R-square in the model, how much the global factors, global shocks explain in each currency versus in the data when you run the same regression. The rest is the country-specific residual.
Model, or do you get it in the model that's strictly with the dollar? That dollar is a particularly low return asset in the world. Do you get that?
Okay, risk premium. So we do get variation in conditional risk premium. We do get the right cross-sectional sorting of that. And yes, when the global risk aversion is high, everybody returns on average positive against the dollar. So we do get this conditional dollar privilege.
You don't have anything to say about the levels.
Okay, so unconditionally, on average. Our interest rates are the same in all countries in the steady state. Exchange rates don't move in the steady state because countries don't have different betas. Yeah, so unconditionally, it's all zeros. But
I just saw last week and they had this discussion. They made a big point that these arbitrageurs have to be short. You get the same.
oh, that we get. Yes. So in the steady state, even though we don't have much action on the risk premia, we do get a lot of action on positions because the riskiness of the country always outside of the steady state is going to be reflected in a combination of the risk premium that it gets and the position that the intermediary takes in it relative to its natural benchmark. And in the steady state, the risky countries will receive lower positions, but the intermediary will be short dollars. That's going to be one exception. And then the dollar risk is, as you saw from the SDF of the intermediary, also important. Now, we don't use the profits of the intermediary as their SDF. We use the SDF of the households, but it has the same property. They're short the dollar fundamentally from their preferences.
Wait, steady state intermediary will be short on dollars on net %. No. So on the condition on the shock, what will be intermediary? So both of them are important for Mark's question, right? Because
Sorry, let me try to
thing and then where you settlement says. So what do you?
Let me try to restate this because I think I also misspoke. But you said in the steady state, the intermediary will be short the dollars. I want to give two answers to this. In terms of positions, no. In terms of its SDF, yes. Thank you. Variance decomposition of the important time series in the model. One of them is the price of the local basket in the US. How much do global shocks contribute to that? Right. And we find that the local US shocks contribute a lot to the relative price of the US consumption basket. Now, the financial shock contributes much more to the dollar factor than to the US local price, even though, the dollar factor is just the relative of this QU against everyone else. Why is that? Well, because the financial shock has a very particular direction in the model. Everything in the intermediary internalizes dollar risk. Every other currency is more risky fundamentally relative to the dollar. So the financial shock is going to depreciate other currencies and appreciate the dollar against them, or vice versa. But it's moving them in different directions. That's why for the dollar factor, for the bilateral exchange rates, financial shock is much more important than for the local prices themselves.
Sorry, I apologize if you've mentioned it before, but how do you separately identify the gammas from the Z and the X's?
Here I'm using that they're orthogonal.
Oh, that first, okay.
All the covariance goes.
Because then it could be that you don't need the gamma and you could use covariance between Z and X to get exactly the same thing.
That's true. That's true. So we looked at that would have implications for output as well. So outputs would be correlated. I don't remember exactly what we found, but let's talk about this later because this is a good direction in which we're also thinking. I cannot give you the exact numbers right now. I don't have them. Sorry.
It goes back to this fundamental question. What is the role of these? How far do we need to push in terms of finding stories for fluctuations in GAN? That's it's still a little reduced form. You'd like to know how important it is. If you don't have to do it, then we don't have to worry so much about it.
Great question. I have to come back to my mapping from the parameters of the shocks to the parameters of the factors. But it's true that one thing I need to mention and is the right intuition that I think some people have here. Gamma is driving the covariance between the dollar and the commodity factor. And that's how I infer the strength of gamma. It's true that I could potentially make them the X, U, and Z correlated and infer the same covariance. Not sure I would have quite the same identification. It would be maybe more strongly over-identified my set of parameters, but I need to check and do formal tests. Okay, the decomposition of exchange rates now. So this is relative to the dollar of individual countries. There are two ways to slice this cross-section along the M dimension, the dollar assets, and along the commodity exposure dimension, both times holding the other cross-sectional variable at the average. So the green here is the local shock Local shocks are very strong if countries have a lot of dollar assets because it insulates them from global shocks. So they both are not exposed to the US fluctuations. Because of that, they're not risky. And so gamma also doesn't have bite for their currencies. When you trade more commodities, the commodity shock becomes more important to you. And then the risk shock becomes also more important to you because you become more risky. And here I have 3 examples. So in the paper, we start with these 3 examples. These are 3 different countries. They tell slightly different stories on these 2 dimensions. The first one of them is Thailand. So Thailand actually, of all the currencies in the global financial cycle, of all these 3 currencies, depreciated against the US the least. Thailand in the data has low commodity exposure and relatively high dollar assets. And this in our model explains why its exchange rate is less volatile than the average, and also why the global factors have low explanatory power for Thai baht versus the US, because it's insulated from US shocks and from risk shocks by virtue of being insulated from the real shocks in the world. Hungary is a slightly different story. They have low commodity exposure. It's not like they export a lot of oil, but they have very low dollar assets because Hungary is in the middle of Europe. They trade with countries that use the euro. Their external assets are euro denominated mostly, so they're not insulated from US shocks. They carry significant dollar risk, and this makes them exposed to the risk shocks as well through the lens of the model. So their exchange rate is more volatile, and global factors explain much more in Hungarian forint dynamics than in Thai baht dynamics. And then finally, there's this Australia. So Australia has both high commodity exposure and relatively low dollar assets. So it's more exposed to risk shocks from both angles. The risk shocks, according to our decomposition, explain almost half of the global variation in Australian dollar. Okay, just to conclude, this was my last slide. So just to conclude, we build a model that maps real and financial shocks into factors that are known to explain and capture most of the variation in exchange rates. So we give a mapping from fundamental shocks to those factors. We also use the moments of the cross-section to learn about the drivers of the exchange rates. We find that there's no single answer to what drives exchange rates. It really depends on the country's position in its trade linkages and its dollar asset accumulation. One robust conclusion that we can draw is that financial shocks contribute much more to bilateral exchange rates versus the US than to local prices themselves, because the US is the fundamentally non-risky currency. So increases in risk aversion generate flight to safety and appreciate the dollar systematically. Thank you for your attention. Thanks.
My slides, I already sent them to the others anyway. I want to show you maybe, yeah, let me make 2 points. First, why do they go for a model with 2 risk factors? And then I want to come back to your question about the intermediaries and how much FX risk they are taking. So why do they go for 2 factors? Because in finance, we have this evidence, and just based on the data, non-models, where we can build 2 cross-sections of currency portfolios. So there are 2 ways to sort currencies so that you build 2 kinds of portfolios, and those 2 kinds of portfolios have different properties. So the first one is that you sort currencies by their level of interest rates. You borrow where interests are low, you invest where interests are high. This is the carry trade. And you can explain this as a covariance between any return and your carry trade risk factor, the high minus low exchange rates. But there's another way to build currency portfolios is you sort currencies by their dollar betas. And you can think of a dollar beta as just a market beta. The same way you would look at the average return on the US stock market, you can look at the average return on the currency markets and look at how much currencies co-move with this average return. And if you sort currencies by their dollar betas, again, you're going to obtain different excess return. And you're going to be again able to explain different excess returns as covariances between the returns and the risk factor. So that you can actually summarize with two simple 45-degree line, the classic graphs in finance. On the vertical axis, you have the actual excess return over your 6 portfolios. Here, the portfolios are sorted by interest rates, and here the portfolios are sorted by their dollar betas. And on the horizontal axis, you just add a beta times the market price of risk. But here, the market price of risk is something that is just the average return on the factor that you're studying. So this is completely model free, and that basically tells you that there should be 2 risk factors. So why 2 risk factors? Because it turns out that the 2 explanatory factors to account for the cross sections are actually orthogonal. Their unconditional correlation is 0.1. And so, yes, you need 2 sources of risk. So we already have stories in finance for this cross-section of excess returns based on how much commodities matter, but we had no stories for the other one, which is why this paper, I think, is great, because it's giving you a reason for why countries differ. It's not just the amount of exposure to oil, but it's maybe how much dollar assets do you have. And so they work out this intuition, it works perfectly. I'm going to skip that, and instead, I'm going to go back to your question, Mark, about the global arbitrageurs, because in this model, they take on a lot of FX risk. And that I'm not sure it's in the data. Actually, I don't think it's in the data. So let me show you what I did. It's something I did already in March, but I'm looking at JP Morgan. I'm looking at their annual reports. In their annual reports, they need to tell us the value at risk, how much they may lose. And it's defined by the regulator, so in a very precise way. It has to be over a 10-day business window at the 99th percentile. And so the way to think about it is that think about the distribution of exchange rates over the same 10 business day window. And what are the chances that the exchange rate is going to move by like a lot, so that you really lose a lot of money, either in one direction or another. So you can look at the percentiles, the 99th percentile. And here, if you look at the euro versus dollar, okay, the exchange rate would have to move by 2.5% over a 10-day business, 10 business day. But JP Morgan says, look, I have a value at risk of 53 million. So I may lose 53 million. Well, so, but how much exposure do you have? That we don't know, they don't report. But let's think about it. They have an exposure of A. If it moves by 2.5%, they lose 53 million. So we know what A is. It has to be that A is something like $2.12 billion. And that sounds like a big number, but for JP Morgan, it's peanuts. JP Morgan's equity, it's already $300 billion. And of course, they invest even more than equity. So the amount at risk that is implicit in their regulatory data is actually very small. So it has to be that when we write this model, we have in mind someone else, but not JP Morgan. And so I think that's basically the next step is either we write models where somehow they take on much less risk and we have to think about how much they hedge, or we introduce a different kind of intermediary.
Can I the right benchmark now the JP Morgan's equity, but beside the currency market, how much can you absorb with this 2 billion, right? Like what's the typical shock on that market? How much can they absorb for those 2 billion of assets?
But in the model, no, in the model, you have to compare to what they invest, right? So what do we invest? You have the reason you can derive this is because they start from this idea that the intermediary has nothing, and the intermediary is going to borrow in dollar, and everything that's going to be borrowed in dollar is going to be invested in foreign currencies. So I think you have to compare to the balance sheet of the intermediary.
Unless the right thing is the currency desk, right? Currency desk.
It's even worse. Yes, then it's even smaller. That's right. Yeah. Okay, this is just a point to think. Of course.
So your implication is that at the margin, they should basically be pricing an additional unit of currency at risk neutral.
Yeah.
But if there's some regulatory capital thing that they have to meet, at least the bankers always talk about it's super expensive to vary at the margin when you're hitting up against.
Yes.
But your CIP stuff.
That's correct. Yeah.
Story.
But that's the reason why they hedge.
That multiplier is of meeting the regulatory. It's not the relative.
But the implication, one step further, is that they hedge, because you do not want to be exposed to currency risk, because exactly for the reason you said, there's a huge capital charge on the unhedged position. So as JP Morgan, I don't want to have that kind of unhedged position. Okay, but that's food for thought. I think it's a great paper because they, yes.
That same calculation.
The same calculation applies, but it's not the case that all the intermediary models have a huge imbalance in FX risk, that you have to check model by model.
I see. That's a
But-
useful thing for people to do.
That's, yes, they can check that. Yes, but there are also papers that write the maximization problem with the intermediary, knowing that the intermediary can hedge, and then they're not subject to that issue.
Kind of like the average position, isn't it like, how much variation returns do you need to get variation for that exposure? And then like sorry, it's like, it's kind of going back to that earlier question where a country wants to save the dollar, they gotta find the intermediary. Save a peso, you gotta find an intermediary, take it, how much do you have to offer that intermediary?
Yes,
It's the margin.
yes, that's right.
That would be
That I don't get because this is the average exposure. I agree, but that I have to measure transaction by transaction. Yes, I can also do it. But okay, let's not just focus on that. The important thing is that they actually are bringing some actually new moments on exchange rates, and those new moments are very precisely estimated. If you think about the usual UIP coefficient, we are not even sure it's 0, -1, or I mean, we can maybe reject this +1. That's pretty much it. Those dollar betas are very precisely estimated, and if we understand this dollar risk, we're going to understand like 50% of the exchange rate variation. So I think this is the way to go, and so well done. I wish I had written it.
Thank you.
Thank you.
10 minutes. Kalim Oskan. She's gonna have, I think, one slide too, but the discussion leaders don't need slides, so don't worry about it. For the rest. Okay, great. I'll give you 15 minutes,
Change in the rules.
Oleg. I'll give you 15 minutes. What, science?
50.
No.
Tell you when there's 15.
15 minutes left.
Great. Thank you very much for having us and thanks Shebnam for doing it once again. So this is a paper with Pierre Olivier and Mai. They're, Pierre Olivier is back to Berkeley, but it's kind of like a mixed IMF team. Sadly, they're not here today. So we're going to talk about, it's related to what Alexei was presenting, but kind of quite different. And so, it would be interesting to see how the two things fit. So I'm going to talk about currency premia, uncovered and covered interest rates. So those things are constructed out of the data on spot exchange rates, forward exchange rates, and interest rates. And kind of the goal, the objective of the paper would be to have a statistical description of these objects, right, in the panel data, right? So both in the cross-section and the time series. And so different theories have different implications for what should we expect there, right? And so it would be fairly easy to rule out the frictionless theories, which is like a starting point, the stuff that we usually teach. I'm going to use as a shell frictional segmented markets, kind of frictional intermediation model. And partial equilibrium of that model is sort of enough to make sense of the statistical properties of these objects that we get in the data. But my goal is really not the model. My goal is this description of statistical properties that we can kind of basically agree on. So these are like, well, not even stylized facts, but actual facts about these variables. Taking a step back, where this is coming from, well, the big goal here is try to understand what are the drivers of exchange rates. There is limited progress on that. There is lack of kind of robust movement between exchange rates and typical aggregate macrofinance variables. So we're going to take this alternative approach in the literature, going back to Evans and Lyons, is to think about the currency market as a micro market, right? There is demand and supply in the currency market. And if you could observe shifts in demand and supply in the currency market, you'd be able to predict where exchange rate is moving, as exchange rate is the price that equilibrates that market. Well, things are a little tricky because there is a spot exchange rate and the forward exchange rate. There are interest rates that would act to equilibrate those markets. So I'm going to have to deal with all of that. But my approach would be really much more micro level, to think what equilibrates these markets instead of saying what are the macro shocks behind it. And I'm going to try to come back towards the end to talk a little bit about the macro movements behind this micro shifts in demand and supply, right? So this is what we're going to do. So the focus would be on the empirics, and I'm going to briefly show you the theoretical model as a shell of thinking about that empirics, right? So it's useful to start with a frictionless benchmark, the way we're going to kind of teach an undergrad class or an MBA class, potentially. So the frictionless benchmark, there are these two premia in the currency market, or two parities, UAP and CAP. I will think of them as premia or deviations, right? Whenever there's deviations from equality, they create a premia for somebody to pocket. But if you're in a frictionless market, this premia is zero. And that creates conditions that tie together interest rates and different exchange rates, right? And so the way we typically think about it, well, CAP think that this is the thing that determines the forward exchange. If you know the interest rates and the spot exchange rate, thank you. Then you can kind of figure out what should be the forward exchange rate. In particular, if you have an interest rate, a high interest rate currency, what will happen is that that currency needs to have cheap forward. It needs to be cheap forward sense, right? Because like the high R, how about this? Oh, yeah. So the high interest rate for currency I needs to be compensated by the low object here, which means cheap forwards. When F is big, just like with exchange rate, it means it's cheap forwards relative to spot. And that's how we think CAP comes to equilibrium, but there is equality to zero here. Of course, in the data, this equality to zero doesn't necessarily hold. UAP is more dynamic object, right? There is difference in interest rates and dynamics of exchange rates, and you need to take expectations. So it's not kind of like determined at time t. You need to also know something about the expected movement in exchange rates going forward, potentially first and second moments and maybe higher moments of that. But what that tells you, it's kind of like nice. If you know differences in interest rates between currencies, you know which currency is like forward cheap or forward expensive. You also know if this holds, that if you have interest rate differential, it should predict movements in exchange rates. Otherwise, it's not going to hold. And that's the basis for the Fama regression. You look whether the high interest rate currency is the one that's expected to depreciate. Of course, in the data, that's the Fama puzzle, right? And then combining the two, they're not linearly independent, right? This is linearly dependent with the previous two, is if you have a cheap forward currency. So if we take like New Zealand dollar, it's cheap in terms of forwards, right? The forward rate is less expensive than the spot rate. Then it should predict also the movements in the spot exchange rate. So this is the forward premium predicts the movements in the spot exchange rate. This is the frictionless benchmark. Of course, in the data, we know that there are all the puzzles related to this, but the puzzles means that the quality don't hold here. What I want to do is actually describe exactly the statistical properties of this object, like they are in the data, which we can use as sort of stylized facts, basically, right? And so what we'll see in the data is that, well, first of all, there are no predictable changes in exchange rates for developed currencies, right? So if you will have interest rate differentials in the data, and you have that this deviates from one. There are cheap forward currencies and less, and expensive forward currencies, like yen is an expensive forward currency, but it just doesn't predict in which direction the spot exchange rate is moving, right? So it immediately violates these two equalities to zero, but the question is, what's the right statistical model of that? That clearly is not the right statistical model. So then what's interesting is cross-section and time series will look very different. In the cross-section, UAP and CAP will be very much correlated in a particular direction. They will be very much correlated with interest rate differentials. So the high interest rate currencies will have positive UAP premium and positive CAP premium. And the variable that will bring in, it's more like kind of macro variable if you want. What determines the interest rate differential? It will be the funding gap of the country. So if the country sends money away, so think of Japan, it has a lot of savings. It actually tries to push money out. It would be a low interest rate currency relative to the dollar, and it will have negative UAP and CAP in the cross section. You take country that absorbs money, think of New Zealand or Australia, and this would be a country with like a funding gap. We're going to measure it as a positive thing, and it would be a high interest rate currency. And the high interest rate currency will have positive UAP and CAP, and it will be all very correlated. So if you're scarce for money, you're a high interest rate currency, and both risk premium and the cross section deviate in the right direction. What's interesting, there is no time series correlation between UAP and CAP. So they behave like different objects, right? In cross section, very orderly. In the time series, UAP and CAP are completely different animals. So CAP mostly reflects financial stress in the broader financial market. UAP mostly moves with the currency market. So most of variation in UAP is about idiosyncratic movements in the currency market, which are orthogonal to broad financial market, right? And so to do that, we're gonna sort of bring out a new variable. I mean, this variable is actually publicly measured and was available before, but essentially this is the position of intermediaries on the futures market. And there are periods of time when intermediaries need to expand their positions to accommodate excess demand for currency. And so what I'll show you is that movements in that variable don't correlate with CAP. So they don't have any effect on CAP deviations, but they highly predict movements in spot and forward exchange rates and predicted exchange rate movements. And I'll show you the pictures to kind of as teasers. Yes, it's two teaser pictures. If you're not impressed with these pictures, you're probably not going to be impressed with the paper. But if you are, I mean, then I will kind of go on and explain what to do. So basically, we take one variable from the data, which is a futures position of intermediaries on Chicago Mercantile Exchange. And we can do it for any currency for which the data is available. It's about 12 currencies. So this is euro against the dollar. Black lines are raw monthly changes in dollar-euro exchange rate. The blue are the raw changes with very little transformation of the data. I'll show you exactly what we do. Changes in the size of the position of intermediaries on that market to clear that market. Of course, the total sum of positions in that market is zero. It's a zero net supply market. But we take the net positions of intermediaries, which is one of the four groups in that market, and that's the blue line. And that's how correlation in monthly changes of 0.6 looks like. You can then throw in all sorts of typical financial variables on top of it, whatever people use in exchange rate regressions, and you're going to get to that correlation. And so I'm going to show you the specific regression. Well, this is contemporaneous, and you can say, well, contemporaneously, you know, like, who knows what happens within a month? You can get like spurious correlations contemporaneously, but I'm going to do out of sample in the next picture.
If you went back 20 years, what would that, what would those two, those numbers?
This is a
be?
20-year horizon, super stable. I'll show you that picture. It's super stable over 20 years. We cannot go behind 2006. That's when the Chicago Mercantile Exchange data starts. But between 2006 and 2024, which is our data, like it's very stable.
CIP that show graph is 0.
I'm gonna get to that. This is about exchange rate and UAP, has nothing to do with CAP. CAP will move differently, and I'm gonna get to your thing. So out of sample. So this is kind of a cool exercise. So this is a purely out of sample prediction. What we're gonna do is in period 0, exchange rate moved by 1%. What can you predict what's gonna happen with exchange rate going forward? Well, exchange rate is approximately a random walk, hard to predict from the movement at 0 it's gonna happen. But what I'm gonna do, I'm gonna condition on one event or that event not happening. So this is the impulse response if intermediaries stepped in and took the position. So a currency I depreciated, intermediaries might have stepped in to absorb that currency risk. If they do it in the data, this is the predicted impulse response out of sample without using variables from this period. So, 1 month, 2 months, 3 months, 4 months ahead, you predict after 1% depreciation, you predict mean reversion in the exchange rate. If at 0, intermediaries did not step in, this is the path of exchange rate with some momentum in it, right? It will further depreciate going forward. So it's unconditionally random walk type of thing.
Well, like, what does step in mean in one particular?
So in the
direction
data in
or the
period
process?
0, yeah, in period 0, we see whether net position of intermediaries moved relative to the size of the market.
Okay, so whether it moved up or down.
Exactly.
Okay.
And so when there is a currency depreciation, somebody needs to absorb that currency. Did intermediaries absorb that currency and the risk associated with it? If they did, that currency is predicted to appreciate, and these are the returns that they will make. So if somebody was exposed to that currency before intermediaries stepped in, they would be wiped out, well, not wiped out, but they would have minus 500 basis points return annualized on the event at time 0. So this is the event of a depreciation. Everybody who was exposed to that currency would take a big loss. But everybody who would trade together with intermediaries going forward will be making these returns, and this is like 200, 300 basis points annualized returns over the next couple of quarters. Well, this is months, this is a quarter, this is the second quarter, right? So basically it predicts returns in the way Fama regression fails to predict returns, right?
I think you need to explain people, this is not perfectly like matched with data. You are not doing in 2021, 2024 period. This is not data out of sample. You do this with the mind. So when you say intermediate step in, you don't know that. You don't know intermediate absorbing this or not.
So
this is the model. So
the way this exercise is done, it's out of sample prediction using the sample to estimate it. We should have do it purely out of sample.
not out of sample.
So purely out of sample would be a rolling window when you estimate it on a training sample and do going forward. Yeah. But what's important is we are explaining exchange rates after, which are random walk kind of unconditionally, but we're explaining what happens with the variable from before, using as estimation the full sample. We should do rolling windows to check. But these coefficients are remarkably robust. That's what I will show you. So when we do subsamples, the coefficients from which these projections happen are surprisingly robust in a way that's something you would not expect from the theory that they should be so stable. Okay, so this is a teaser. If I'm kind of have your attention, I'm going to tell you what we're doing, what's behind the pictures. And of course, there is a sort of big literature we're building on. What's surprising is that this variable, this blue variable that we're using here, somehow was sort of overlooked by the literature. You can find a couple of reports and papers that use that variable, but somehow, like, I mean, just seeing this correlation seems, surprising enough to, go along with it. And somehow, like, we're not the first ones to use this data, but it's a completely publicly available report from Chicago Mercantile Exchange. Okay. I'm going to show you a model very quickly because the point of it is not the model. Unfortunately, not a lot of things of this are intuitive. So before I worked it out in the model, I was teaching UAP and CAP, and like a lot of surprises come out of the model. I'm going to give you an impressionistic view of what happens in the model, but like the details, you're going to have to look in equations in the paper. So the way I'm going to do it, I'm going to look at it will be an intermediary model with some balance sheet constraints. So this is some bank that has net worth in dollars. So the star means in dollars. It can borrow or save in the interbank market in dollars. Then it can do some risky investments, some investments in foreign currencies. And these are the reserves that it needs to set aside. And the balance sheet constraints would be the more risky stuff you do, the more reserves you need. And it's costly because interest rates that you can make here are better than the interest rate on reserves. And that's why if you're forced to put money in the reserves, that will translate into the premium that you need to charge to do the trades, right? And then off balance sheet, there could be a forward or future contract, and there could be a swap, right? And so if you work out how you solve this model, well, you work out the evolution of net worth, which the bank maximizes, put the balance sheet constraint on top of it, and see what would be the portfolios, right? I'm not going to do that because it's standard and tedious, and so I'm going to lose a lot of time. But what you have to think in the background is like, if you start with $1 of net worth as a bank, you can do a carry trade, exposing yourself to exchange rate risk. You can write a forward contract and hedge that, or you can do a swap and swap interest rates. Those three trades are linearly dependent. So you actually really have two trades, and there would be two state variables for the bank or two variables of optimization to choose. And so those would be the supply schedules of the bank. And so I'm going to show you how those supply schedules look like. Hopefully it's intuitive enough. This is sort of the work that you do, and you get to this picture. So hopefully it's intuitive enough. And so this is how the currency market equilibrium looks like. It's not intuitive in the following sense. There are two exposures, Z and X. Z is very clear. It's who holds the currency risk. So in equilibrium, if there are gross positions, the currency risk needs to be allocated to somebody's balance sheet. These are the exposure that the intermediary sector needs to take on, like in the end of all trades, when equilibrium happens, this is the exposure of those banks, JP Morgan's, Goldman Sachs, and other intermediaries in the currency market. If they have positive exposure, they need to be compensated with a UIP deviation. UIP deviation is payment for holding the currency risk.
So remind me, Oleg, who's on the other side of the market?
We don't know, but it could be hedge funds, the way we're going to think about it.
I'm thinking those guys have the same sort of problem as these guys. I'm not sure why they're different somehow.
If you give me a couple of slides, I'm going to write it with all different agents and how I will think about heterogeneity. But the easiest way to think is pension funds. So think pension funds have a similar problem, but more tight constraints on the amount of risk that they can take. So even if the trade is lucrative for them, they might need to sell off the risk. And these guys need to absorb the risk. But I'm going to bring a little bit heterogeneity to kind of think about that.
I want to explain to people the very important implication of this, vertical demand and this very slow supply. It makes it.
Yes, I'm going to get to that.
Our supply, which you are going to assume a lot of things, which is going to go directly back.
Both of these questions coming in like 3 slides.
Great.
Bear with me. Think of this as an individual guy who doesn't know where this demand comes from.
Before we get to the slopes, I want to understand the axes. So Z star is some position of that bank you just showed us.
That's exactly what Adrian said. If exchange rate moves by 10%, how much money can you lose? That's Z. That's your currency exposure. Huh?
At one bank, and this is their Z, and this is their exposure to the currency.
I did it 2 steps at once. So you first do it for one bank, and then you aggregate all banks. So I aggregated all banks here.
At zero.
The aggregate banks are not net zero. Individual banks are not net zero, so you can think about either. There are some pension funds on the other side. What's important right now, these banks don't know where this red stuff is coming from. They're not strategic in that. They just know that they need to take this position. And the question is, at which price are they willing to take that position? I want to trace a kind of competitive supply slope for them. So the blue line is a competitive supply slope, first for individual bank and then aggregated across all banks. And you get that slope.
No, because this, what we are doing is we're asking the representative intermediary
Yes.
trading with a bunch of other guys. If it is forced to have a position of
Perfect.
$2.5 billion, at what price
Perfect.
will it hold that?
Perfect.
That has got to depend upon its attitudes towards risk and its concerns about various covariances.
Perfect. So all of this would be in the slope function. So mu is a Lagrange multiplier on the balance sheet constraint. Sigma is expected volatility of that exchange rate.
Okay.
Gamma is the balance sheet constraint parameter, like a value at risk parameter.
Okay.
And W is the net worth of the intermediary sector.
Oh.
So this is in a standard model, the stuff that will come in. I'm not committing to a particular model. I'm gonna infer that slope in the data, kinda, right? But does that answer the question? This is the amount of risk that needs to be absorbed, at which price the intermediary sector is willing to absorb it. If the market wants to sell more risk, think about April 2025, all these Japanese investors suddenly want to sell off the dollar risk. Somebody needs to buy it. At which price will they buy it, right? So that's what here. And for UIP, we kind of designed it in such a way that this is a nice, smooth supply curve. The data for CAP was big in, I mean, you can think of the step function. If you zoom out, it's also smooth, right? But if you zoom in, it's locally elastic. So when you look at the CAP market, it doesn't look like it's elastic at zero. It looks locally elastic at a premium. So say Japanese yen is 20 basis points for the CAP deviation, well, negative 20 basis points for Japan. But locally, when demand moves, it stays 20 basis points. So what we wanted to get out of it is the locally elastic, because the data begs for it. Locally elastic supply, but as the demand goes much bigger, you need additional currency desks to enter into intermediation. And when you have a new desk entering into intermediation, you jump on this CAP schedule, right? So if the set of active intermediaries is the same, you're locally elastic. That's how we model it. If the demand shock is big enough, then you need another guy step in, and the CAP premium can jump. Many steps. In the data, in our data,
So you had like 100 days in the step?
in our data, it's 12 banks. So our group of intermediaries, it's a hugely concentrated industry. I don't want you to take the model too literally. That's what gets the data right, locally elastic stuff. So now in the data, what I will do, I'll find shifts in demand, and I'll find shifts that move the supply curve. And I'll be able,
Data, 12 guys. It's gonna be zero, Mr. One's gonna go, 0, 0, 0, Mr. Two's gonna go. Like,
this is the model. I don't want to overinterpret it. Anything that gives you locally elastic stuff will do. This was the easiest one, and we don't have that data to zoom in. Okay, so now the summary of the theory. So check it out. So instead of
Ideal data is you want all of those pieces. You want
Yeah.
all positions of the
Yeah.
one asset class. You want to trade because
Right.
that's the story, right? Who is selling, who is buying, who is absorbing, and of course you want to price, right?
yeah.
Right.
And the paper is like summarizing all that as kind of net position of this intermediary.
Yeah.
Which again, I should agree with Oleg that they have this new blue variable that is they are going to use in a clever way to get you that step.
And so our data is publicly available. You can go download it right away. It only gives you total net position of intermediaries. It doesn't split it further. The proprietary data now splits it further, and you can go, but like I want to show you how much you can do with publicly available data. Okay, so let's talk about, just like I did, what the frictionless model does, what frictional model implies. So first of all, there is something, and I didn't explain what X state variable is, but think about the demand to swap from one market to another, and I'm going to explain it in a second what it is. So imagine you're trying to get rid of your position in Japan and get a position in dollar, because you want to use that position in dollar in the US to buy other assets. In order to do that, you're going to have to pay a premium. That swap of positions doesn't involve any risk. I was thinking you had a dollar in Japan and you want dollar in the US. That's the CAP. So if somebody will provide intermediation for you to do it, they will charge the CAP premium. What CAP premium means is if you're going from Japan to US, this will make the Japanese yen further more expensive forward. Right? Why? Because the person will have to give up his position in the dollar assets in the dollar market temporarily in that swap trade, and he needs to be compensated for that. And how with this trade you can be compensated? Well, it would be absorbed in a little extra forward premium. Right? So if we think about interest rate differentials between Japan and US, right now it's about 400 basis points. On top of that, you will pay another 20 basis points because the equality will not hold. It's small. It's about 5% extra that you pay. But if that service is provided, that's what you pay the banks. And that's how this model works. This is what this, I actually had it here. This is what the steps mean. It's not a big premium compared to interest rate differentials, but it's there. And you kind of live along that line.
And there's pre-financial crisis, back 20 years, it was way smaller, right?
5 basis points, and now it's 20. So somehow
Somehow we believe that 5 basis points is well approximated by zero, but 20 is not well approximated by zero. But it's a bit in the eye of the beholder. I mean, we can debate with that, Jen, I guess, whether my.
Yeah, I mean,
But I'll show you the picture.
like one direction and one direction only, which is why it's not going to fit emerging markets. Because you are not going to allow forward pesos to be more expensive, and we know that is the case in many emerging markets. So this is only going to work exactly as you said, US yen example, US Swiss franc, US Canadian dollar. It is not going to work for Mexican peso, Brazil real, Peru sol, or.
I don't want to. This paper is about the rich countries for which we have the data. The least rich country will be Mexico, and I'll show you what happens to Mexico. We cannot go with this data beyond Mexico. So I don't want to pick up that fight, but I'll show you what the model predicts. Yeah.
Just to be clear, it's a fact in the data, and you just assume away with the assumptions and making.
Yeah, and I'm not going to go in that direction.
Yes.
Very consciously. So I'm going to.
That direction.
That's all right.
All right.
So let me tell you the second thing from what happens. So now if somebody needs to absorb the risk, there would be a UIP premium for that. And here where interesting stuff starts to happen. Of course, to absorb the risk, you need to be compensated for that. But the question is, which component of the IP you will be compensating you for that? And it turns out it's very different in cross-section and in the time series. In the cross-section, this is true for developed countries. Exchange rate is not drifting up or down. So all of your compensation comes from the interest rate differential. So UIP in the cross-section is approximately the interest rate differential. If you want to go systematically from Japan to dollar, because Japan is a low interest rate place and the dollar market is high interest rate price, somebody will have to absorb the currency risk of that, crosswalk, and that currency risk will be compensated by interest rate differential. That's 400 basis points between yen and the dollar in the last year. That's for going from low return place in Japan to high return place everywhere in the world. And that's how the market clears in the cross section. In the time series, interest rates are slow moving. So when this big currency demand shocks happen, interest rates don't adjust. So all of this currency premium, like April 2025, Japanese pension funds really want to hedge their dollar position. Somebody needs to absorb it, interest rates don't move. What has to happen? A predictable movement in exchange rate. That's the only way in the time series you can accommodate that market. And so that's why time series and cross-section for the currency market look very, very different. So this is what the model allows as possibility. This is what the model requires. This is what it allows. And I'm going to show you that the data exactly looks like this. So now what are these two shocks? Well, Z is very simple. It's the desire of the market to get rid of the currency risk. The dollar became unpleasant to hold after April 2025. Some pension funds and long-term investors want to sell dollar. Somebody needs to buy it. That's the Z, like the net excess demand or supply to sell currency risk. So that's very simple. What is X? X is a lot harder to understand, but this is like a demand to swap from one country return to another country return without holding the risk. So imagine you already have a dollar in Japan, but with a dollar in Japan, there is not much that you can buy. If you wanted to buy US equities, you have to take the dollar from Japan and bring it to the US. And that's what the swap contracts allow you to do. It's kind of like funky, but when you work out the balance sheet of the banks, that's the part of the balance sheet that works, right? You essentially move, without changing the currency exposure, you move the location of the dollar, right? You move it towards the US, and there is a little premium for doing that. And where that premium will be reflected, well, it will be reflected in the forward rate. That's the way that market clears, right? And so swaps are by far the biggest part of the currency market. They're about 5 times bigger than futures and forwards are bigger than the spot market, right? And so like the swap is really this action of moving from one place where you can make investment to another place where you can make investment, which involves no risk, but requires some fee to be paid. And that's kind of the nature of CIP.
Oleg, just one quick one. The swaps are off balance sheet, but still, I mean, the story still goes. What I did not understand is why the blue line was flat. Because I would expect that the more swaps,
yeah,
I sell the.
It's a backward engineered because the data screamed for it. The way I'm going to do it, the balance sheet constraint will be convex in currency exposure. Think of the diffusion term, which is kind of quadratic, but it would be only linear in that off-balance sheet swap exposure. So if it's linear, then you have a bank-bank solution until the limit of trade. Okay. So I backward engineered this. There is kind of nothing natural about doing it that way, but the data screamed for it, that you should think of maybe, your exposure to swaps as a drift term and as exposure to currencies as a diffusion term, which makes sense because, swaps don't have the risk, right? Okay, fine. So the last thing is the slope. We kind of had a little bit of this discussion. So I will need to do something to measure these guys in the data. The beauty of it is forwards are in both. So if somebody wants to use the forward contract, this is a funky thing. Like when you buy a forward, you kind of do two things. You absorb exchange rate risk, but you don't get the high return, right? Like if you buy a forward on a high interest rate currency, you don't get that return. The swap would have given you the return, but the forward doesn't give you return. It only gives you the risk. So the forward is kind of worst of both worlds. You get the risk, but you don't get the return of the carry trade associated with this. And so it just turns out when you work the algebra, the forwards are in both. So when you see shifts in the forward contracts, you actually shifts in both of this, whatever, state variables or allocation variables, right? This is one thing that I'll need to measure in the data. The second thing I'll need to measure in the data are proxies for the balance sheet constraints of the banks. So, all sorts of interest rate spreads reflect the balance sheet constraint tightness, net worth of intermediaries, and stuff that's related to either value at risk or balance sheet constraint. So how are we going to do in the data? We're going to infer shifts in demand from the futures market, and we're going to use the standard financial variables that proxy for this well in the literature anyways, right? And then what we will get from it is that standard financial variables are about shifts in the blue curve. Net worth, like a shock to net worth of intermediaries will make this less elastic. Tightening of the balance sheet constraints, when you see all sorts of spread spike, will make it less elastic. Should move the risk premium and exchange rates. We're going to look at the futures market and we'll infer shifts in the red curve. And this brings me to Shebnam's question and Chary's question, how can you do this econometrics, right? Like, isn't it running prices on quantities? Like, it's going to be kind of weird, really, right? Running prices on quantities. But here's the logic behind it. It's a zero net supply market. So the total positions of all agents, and these are heterogeneous agents, need to net out. For each agent, you can write a position as a matter of OLS like this. Doesn't have to be OLS, could be structural theory. But the point is, this is the currency exposure relative to net worth of that agent J. Could be a bank, an intermediary, a hedge fund, a pension fund, whatever you want. And they have two reasons to do the trade. One reason is to make money, and that's their slope to make money. And so like the risk aversion will be in here, or VAR constraints will be in here, and so on. But these are the things that are unrelated to return. So for example, regulation tells you you cannot hold currency risk. Then it's like a Lagrange multiplier on that constraint. So you have two reasons. You either, on the earlier equation, or you constrain. And these are two reasons for the trade. And in any structural model, you can do the decomposition. Now, the beauty is that in equilibrium, the UIP premium is a composition of this demand and supply factors. This is the total demand, or the total amount of demand shifters from all agents in the economy. And this is the total slope of supply. So this is the whole market without splitting it into different agents. These are all agents J in the market. So UIP deviations will be big when there is a big demand shift or when supply is inelastic. And it's the interaction of the two. But this is sort of... Not yet. Next step.
In order for this to be useful, there's got to be some identification assumption that the lambdas and the rows had some particular pattern, right?
Yes.
That's what gives this context.
One click away.
Okay.
So there are this 2 clicks away, sorry. So there is
That's fine.
When people say demand and supply in financial market, it's really weird. Every agent has a little bit of demand and a little bit of supply. So this is the demand shifter. This is the supply slope. And each agent will have a little bit of both. So now to Shebnam's question. What are the demand shifters? Well, demand shifters actually have 3 things. They're those Lagrange multipliers that compel you to be off your earlier equation. But imagine now you have a shock to risk aversion. The shock to risk aversion of the shock of risk aversion to JP Morgan is a demand shock for Morgan Stanley. Right? Of course, you have to sum across everybody to do the market equilibrium. But very importantly, everything that shifts supply for other guys, it's like a demand shock for you in equilibrium. everything that shifts wealth for other guys, it's like a demand shift for you. So this lambda has three things. It's like this earlier equation wedges, shifts in risk aversion for other guys, and shifts in net worth. So now how can we identify anything in this world? I mean, strictly speaking, there is no identification, but here's how it's going to work. Imagine I found a group of agents that have stable role. There is not too much volatility in their role, or I can find good instruments for the volatility in their role. And they don't have a lot of demand shocks. I mean, I don't know if this group exists, but I will postulate that my intermediaries have stable supply of currency most of the time and not too much demand shock. They're mostly in that market to make money, and they have fairly stable risk aversion. That's what I'm going to assume. If that's the case, there is no identification in the structural sense. But in that case, the position of these guys on net will track UIP deviations in that market. And how I'm going to infer this? From the high R squared and the regression. There is no identification of a coefficient. I'm not estimating any elasticity here. The only thing I'm saying that in this structure of the market, if you found guys who have stable supply and not much demand shocks, they will act as if they're tracking they will be tracking the price in that market. Why? Well, it's very easy to understand why, because they will be mostly moving along the stable blue curve. Even if they're tiny in the market, from movement along their blue curve, you can infer the demand shock in that market. It's not a causal statement of any sort. It's just I can use these guys to track the premia that equilibrates the market.
Go back to the other slide. When you said this is not identification in the way we understand, but then you say it is identification in the sense that the net position, which is this blue variable delta F you are going to use, you are going to load all the UIP dynamics onto that variable, side skip the the identification that we are asking because of your marketing assumption. Remember, that assumption buys you. You are disconnecting any risk from the expectations, right?
Let me try to answer in two steps.
So the entire UIP dynamics on this net position variable.
One step is I'm not going to say it's an instrument. I'm going to look in the data and see what is the R squared. If R squared is high, this is a proposition. I found the guys who have stable supply and not too much demand shocks. If they either didn't have stable supply or a lot of demand shocks, R squared goes down with both. So I'm going to look in the data. R squared is high. I kind of found the right group of agents for that. There is no causality from those agents to exchange rate. It's just those agents are dummies for me who help me explain the UIP dynamics. Why they help explain UIP dynamics? Because they got to be tracking with their position the aggregate demand shock in that market. That's the only thing I'm saying. I don't know where the aggregate demand came from. I just know that these guys were compelled to move along the blue curve. It must be a reflection of a demand shock. So now this is UIP over there. At this point, I'm not saying whether it will be the exchange rate or the interest rate driving the UIP. The data will tell me, right? So the only thing I'm using it for is to say, these guys help me to identify red shifts in the market. And then I will have the data tell me through whether the adjustment happens through interest rates or through exchange rates. Which brings me, I have about 20.
Super too low, but I remember when I did the board for a while, and every week the currency desk had to say, why did the exchange rate go up and why did it go down? It was always, oh, more guys demanded it this week, more guys supplied it. And so I'm thinking, if you have Apple market, this is unfair and and you have I'm gonna watch some people want to sell apples. I'm gonna have some other data on people want to buy apples.
Yeah.
When there's more supply than demand, it goes down.
That's what I'm doing, but the goal is.
And then in addition, you say, oh, there's some frictions too. So if the sellers have a little bit more frictions, or the demanders have some more frictions, in addition to the pure primitive thing, there's extra.
Perfect.
But that tells Zippo about anything, anything besides some mechanical thing. It's always gonna be more guys selling demand when it's going down, and more guys gonna demand and supply when it's going up, and it's like a physical description of.
That's exactly what we're doing. Wait. That's exactly what we're doing. One possibility could have been that this market is very elastic. So UIP just never moves, right? Like there is more demand.
So you're trying to see, then it's like you're trying to get some quantities to change. You're trying to do like a equilibrium. Well, I don't know what it is.
I'm trying to summarize statistical properties of interest rates and exchange rates. It could have been that UIP just never moves in response to the shocks. We have R squared of 0. That's exactly what we will find for CAP.
You guys speak up.
Can I ask a question? Go to the next slide.
And last thing, but then I will bring in some macro shocks and show you how this macro shocks move this thing for some countries, but not others. You would need to have a very conditional view of macro shocks when it moves this thing. Mark, sorry.
Let's go to the next. You have the ZJ over WJ. That's just a definition of your demand. And then you find a guy in the data where it turns out that rho is very stable and lambda is close to zero. It could be the case, that these particular people have that property.
It identifies an instance of a shock. So when their position moves, we know something happened in that market and they can start doing conditioning on that. And that conditioning will explain a lot of the time series. It just identified something happened in the data. I don't know exactly what, but if I condition on interest rate movements, you don't explain exchange rate movements. When I'm going to condition on this something happened in the currency market, I will explain a rich pattern of exchange rate movements after that with high R squares, which is consistent with fictional intermediation. So here,
The lag, it's because it can predict.
exactly. What makes it interesting, there is no static price that equilibrates. It's some dynamic property of exchange rates that helps to bring this market into equilibrium.
See,
Which-
demand and supply in apples today, it predicts out 6 months what's gonna happen. That's it. The last step is the interesting
Yeah.
step, not the first step.
But also, you cannot have too high Sharpe ratios in this market. So it also predicts that there should be a lot of volatility on impact and small predicted returns going forward. Because otherwise, there would be free lunch left. I'm going to get to that.
So you're claiming that because on average, these guys have a very stable row and a lambda close to zero. They're proxies basically for excess.
They are proxies. And it identifies me an event in the market,
So
and I
if
can
you
ask,
doing something about excess.
perfect.
It's a little bit more than that. It says that even if there are a bunch of other guys potentially in the market with stable, with small lambdas and stable rows, for some reason, they're not participating in this market. That is, it is important for his results that these guys are there, but there are other guys for whom that's not true.
Oh, yeah, it's important that there's.
Perfect. There is-
In other words, there are a whole
You need
bunch of
some-
people.
Some source of volatility. in
There are a
here.
whole bunch of people like me, and
Yeah.
for some reason, Fidelity is not able to offer me a product that drives these guys out of the market with ETFs and the like. That's.
Well, in order to identify stuff, I need volatility in lambda somewhere else.
Yeah. that's
Without
right.
that volatility, there would be no movements.
Yeah,
But I don't know where that volatility came from. I just know it exists in the background.
yeah, and I'm
So-
trying to think through what the barriers to entry are that.
Perfect. So this is outside this project,
Sure.
but I think the way to think about long run equilibrium in this market, you need to look at Sharpe ratios. If Sharpe ratios are high, there would be more entry into intermediation. When Sharpe ratio, and so that's why it's so important that this exchange rate process gives you a lot of volatility on impact to bring down the Sharpe ratio and little predictable return going forward. And so it's called collecting pennies in front of a steamroller. They have to be really good at collecting those pennies of the UIP deviations, given the huge volatility of exchange rate. Otherwise, it wouldn't have been in equilibrium with entry, right?
Sure.
Okay, I need to show you the data, guys. So we're going to do something very standard on currency premia. It's a 3 monthly contracts because they're most liquid. So I'm going to take 3 monthly interest rates, forward and spot exchange rates. I'm going to do what Shebnam taught us to do and use the professional forecast of the exchange rate, but I'm also going to do what Fama told us to do, just use exchange rate in the future. And so it's going to be remarkably consistent which way. I'm going to put this on the left-hand side, and it turns out for results it doesn't matter whether you use professional forecasts or future exchange rate realization. So kind of do it Fama style or Shebnam style, doesn't matter. I'm going to use this completely standard thing that everybody used in this literature that you put on the right-hand side of an exchange rate regression. So I'm going to collect all those variables. One that I didn't do and we should do is the commodity prices, but the commodity factor should be here as well. So we're going to add that one. So these are the 2 new variables that I'm going to bring in. One will describe the cross-section and one will describe the time series. And these are conditioning variables, right? So one will be IMF construct this variable, which is called local currency funding gap. So you take external dollar debt liabilities of a country minus external dollar debt assets. So if you think about Japan, it tries to push money outside the country it will have a lot of assets. It will have a negative value for that variable. If you think about New Zealand or Mexico, it's the place where money comes in. So they will have a lot of liabilities. This variable will be positive. So this variable is clear. So the tricky one, and I need to step for a second on it. So if I go to Chicago Mercantile Exchange, there are 12 currencies for which we have data. So it's the big 7 currencies. Euro is one currency. So big 7 include like Australia and Canada and what are the other ones?
Japan.
Japan for sure, Great Britain, the pound, and New Zealand. So New Zealand would be my number 8 here. And here I have Mexico, South Africa, Brazil, and Russia, but only for Mexico we can go far enough back. So these markets are building up pretty quickly. These are the futures markets, but only for Mexico you can go like enough years back. For these currencies, it starts 5, 6, 7 years ago. Okay, so what I'm gonna do to Cherry's question, I'm gonna look at that market where the denominator would be the total size of that market. That markets are trending up. So I want to kind of scale it by the moving average going backwards 11 or 12 months, because like in 2020, this is a bigger market than in 2010. So I want to scale it that way. But the key thing that gives me variation are the net dealer positions. So this whole market is split into 4 groups: dealer intermediaries, asset managers. So this is like long-term asset managers, and pension funds are in there, hedge funds or leverage funds, and others. Others are non-financials and small banks. So what I'm going to do, I'm going to take net positions of this group relative to the total size of that market. And that thing will be moving around. And so that would be the like identifier of the movement along the blue line for me, right? A priori, it didn't have to work, right? But like, I mean, in the end of the day, there is no exogenous identification here. It's all about the co-movement that I can explain. What's amazing about it, it's a highly volatile and highly persistent variable. So in a given month, one standard deviation of a change in this is 20% of the market. So in a given month, they can move up by 20% of the total market or down by 20%. That would be one standard deviation. Lots of volatility and nearly random walk. It has some mean reversion in it, but half-life of 8 months, something like this. So this would be my time series variable, and this is my cross-section. So let me show you cross-section. So cross-section is where things are sort of super simple. This is the funding gap. These are balanced countries. So Euro turns out to be balanced. They're not sending money out or sending money in on average over those 20 years. UK is similar. Canada is here. Australia and New Zealand over there. And this is Japan and Switzerland. So these are countries that kind of send money out. These are countries that send money in, and these are roughly balanced. And this translates into differences in interest rates. Right? So it's kind of very intuitive. If a place pushes money out, like Japan, interest rate in Japan is low in yen. If the place absorbs money in, like New Zealand, interest rate is high. So then if I look at cross-sectional UIP, they correlate with interest rate differentials. Right? And so, I mean, we have a table which makes it look actually kind of nicer. So you can look, this is this funding gap in percent of GDP. So you see Japan, Switzerland push out 30, 50% of GDP. New Zealand, Australia push in 20% of GDP in terms of this dollar debt liabilities. And this translates in differences in interest rates and differences in average UIP returns, which are kind of proportional to what you will get from interest rates, and the differences in CAP. But check it out, CAP, 5, 10 basis points. UIP, 130, 200 basis points. So just an order of magnitude difference. But they're very correlated, right? So the cross-section seems to be very clear, right? It's all about whether the country pushes money out or pushes money in. And to do it, you have to pay a premium in the direction of the capital flow.
But pushing dollars out, it's not that assets.
Yes, so it's a little complicated. What matters for UIP is pushing investment out and pushing the associated currency exposure on intermediaries, right? So you buy in American assets, but you don't want the dollar exposure. Somebody needs to take it. And so for that, you pay the UIP premium. For swaps, it's different. You're like, I have the dollar in Japan. I'm willing to take the risk of holding a dollar in Japan, but I really want a treasury bill in the US. Would you lend me a treasury bill? And the CAP premium is for that.
I'm literally just wondering, the funding gap measures only their dollar exposure, nothing to do with the local currency.
Correct. Well, the opposite side of it, if you see this much dollars coming in, you kind of would imagine that this is the scarcity of funding that they have in the country. But yeah, it's in principle, the gross positions this is a net position, the gross positions can be much bigger. Yeah. Okay, so now let me, and so going back to Shabnam's question, the way I'm going to do my time series, so cross section is clear, I think, right? So I'm going to the time series. So what I'm going to do in the time series, I'm going to put UIP and CAP premium here, project them on a bunch of financial variables, but my key new variable is this movement in the futures market. And I'm going to ask, do UIP and CAP respond to that? And so going back to Patrick's description of it, well, it could be if the market is elastic that neither responds. If the market is inelastic, well, you have a shift in quantities, you expect a shift in prices. And so this is where the surprise comes. And this, check it out. I mean, have you seen T statistics of 16 in the currency market? This is kind of crazy, right? Like this is what the correlation of 0.6 does when you have a lot of data. You get T statistics that are like huge. And so on UIP changes, any shift in the futures market predicts movement in the UIP. But now look at CAP. It's like a super precisely estimated zero. So you have this shifts in the currency market that moves, well, not exchange rate yet, moves UIP a lot. Whether you do the realized UIP or you do the forecast expectations based UIP, doesn't matter which way you do it. But it does move the CAP. And it turns out that in the time series, when I include time fixed effects, the UIP and the CAP are just not correlated. This is the zero coefficient. This is this zero coefficient. So in the cross section, UIP and CAP were really correlated with each other. In the time series, they're just not, right? It's just two different animals in the time series. What's interesting is the time fixed effects explain most of CAP. And this is going back to Shabnam's question. We have only rich countries in this sample. All CAP move in the same direction. So time fixed effects explain most of the CAP movement. If I had the developing countries, all developing countries move in the other direction. So you kind of need the time fixed effects interacted, whether the capital, in which direction the capital flows, right? So this is exactly, I think, what you had in mind, that all the developing countries move in the other direction. I'll show you a picture in a second. But check it out here. The time fixed effects don't help me much with the UIP. UIP is really about that movements in the futures market. That's where you get this much of the R squared. So you explain about half of the UIP movement and the total variation from what happens in the futures market. You explain very little for the CAP, and CAP is mostly about the fixed effect. So let me show you the picture for CAP, and I will stop with CAP.
You should be able to use this to get an idea about the slope of that supply curve.
Slope is not identified exactly for the reasons we discussed.
I see. So that's why
I can work out the bias in that market relative to their true slope, but the only thing that's meaningful is the R squared when you work it out.
Okay, fair enough.
So just for you to understand what happens with CAP. So Pat, to your question, this is the zero that people talk before the financial crisis. It's 5 basis points. There was a period of zero. But this is the animal. This is so when like the way I would describe CAP, when financial crisis happens, CAP. And it's not surprising because this blue curve, my supply schedule, does this, right? And so when the supply schedule becomes less elastic, you will have CAP move in an opposite direction, depending on the direction of the capital flow. So these are rich countries, these are developing countries. I use Mexico and South Africa as proxies for developing because we don't really have more data on them. But this is rich countries, these are developing countries. And you kind of see it going up, like in normal times, CAP deviations are 5, 10, 20 basis points. In times of financial stress, they open up. But very little volatility in between. Unlike exchange rates, where volatility is kind of constant all the time.
Yeah, it looks like those sons of bitches are exploiting monopoly power like nobody's business.
Exploiting what?
Monopoly power.
Monopoly power would be one of the models. The other one is they really do have financial stress on their balance sheet.
It's all.
I'm totally fine with monopoly power. Okay, so next thing, do I have like 3, 5?
Yeah.
Oh, okay. Going to Shabnam's question, I can do the decomposition. No, 5. I can do the decomposition where the movements come in the time series. So UIP moves, CAP doesn't move. What does? Well, interest rates don't move in the time series. What does the movement is the spot and the forward exchange rate. And what's kind of interesting, it's not like the forward exchange rate doesn't move. Spot and forward move together in lockstep. So for CAP to open up, you need spot and forward to separate. But with respect to this currency demand shocks that we document, spot and forward move a lot, but together, keeping CAP constant. So that perfectly elastic slope of CAP is not because something doesn't move. It's because two things move in lockstep, the spot and the forward exchange rate. So most of the time, most of the volatility, spot and forward move together. CAP stays stable, but UIP moves like crazy, right? And this is like going back to Patrick's question, this is the type of the description I can get from it. It's like an apples market, but just a little more complex, right? The super interesting thing to which I don't have time, but that relates most closely to what Alexei was doing, is you can start putting factors like VIX and US dollar, and you can see that in the time series, there is a very clear cross-section of the effects. When dollar becomes scarce, all currencies move together. When VIX spikes, currency moves in different direction, depending on whether money goes from Japan to the dollar, from dollar to New Zealand. The VIX factor will have negative coefficients here and positive coefficients here. But this is kind of beyond what I can show you today. There is a very clear factor structure, even in the time series, but I'm going to ignore it. It doesn't explain too much of the variation. So let me show you the currency market. So this is the question that Patrick had. How stable is this relationship? It's crazy stable. So it's 20 years of monthly data with 8 countries here. So each point is a country times period binned into 10 bin scatter plots. But like it's every period here, right? So it's not like things were changing really a lot period by period or country by country. You can kind of map the whole panel on one slope, where this is a change in future positions, whether it happened in 2006 or 2020. Same thing, and this is the change in the exchange rate. So it's kind of, there is some very stable relationship between this futures market and exchange rate. The second thing, if I do the decomposition of R squared, red is my red shift, and blue are all the financial variables. And so this is the R squares that you get, right? So you get about, you explain about 50% of exchange rate movements, where red explains about 80%, and the blue explains the rest. And this is country by country, right? So all these financial variables that you typically put in, they do some lifting, but typically much less than those demand shocks. And so I can show you these pictures. I mean, you've seen it already for other countries, basically. So this is the impulse response. So now, what do we know from the frictional model? That the impulse, so this is our paper with Dima. This was theoretical impulse response with no data. It just tells you that for this market to be in equilibrium, you need huge spike on impact, which is unexpected, followed by predictable expected returns. Now, if I go to the data, that's literally what I get in the data. This huge spike followed by predictable depreciation. Sorry, big depreciation followed by predictable appreciation. So you make these returns as a bank, but you subject yourself to this volatility. That's the low Sharpe ratio in this market. That's what we know should be an equilibrium of the frictional model. Okay, so let me show you the last thing about returns. Ooh. So I already kind of showed you the returns, but this is how we're going to do it. This is the, when the shock happens, 7% depreciation happens, and then you have this predictable appreciation and predictable returns that you will be able to make, which I mean, this is that picture that I already explained to you. The last thing are capital flows, and I don't have time to discuss it, but essentially what you can do, you can look when money flows out of Japan to US, does it move the futures market? The answer is yes. Does it move the exchange rate? Yes. And so you can do those types of things. You can look country by country. When a particular type of capital flow moves the futures market, that capital flow will move the exchange rate. If that capital flow doesn't move the futures market, it does move the exchange rate. And that's sort of the last exercise that we do. Sorry for running out of time. And I'm just going to leave the conclusion here.
Yeah.
Thank you. Thank you.
You want to show more stuff?
Those slides.
But wait, don't think for, yeah, this is over and above what we expect, discussion.
Okay, all right, so again, I mean, just full disclosure, I'm, discussing this paper third time, so I don't have much new stuff to say, and I already said it.
You does.
Okay, yeah, so I guess, hopefully, okay, I just want to be serious about econometrics. I mean, I know, so we raised this, and Oleg is very good at you, and then okay, I have these pieces in my model, so I'm just going to ignore that, but I mean, okay, I'm sorry, but no. Let me just tell you how econometrics work. So this is what they do, and a correlation is not a test of the model, right? So, because again, I mean, they have to take a stand. If it is a model that they want us to take it serious, or if it is a description of the data pattern. So which one? Okay, but then we already described the data in both time series and cross-section in 2 of my papers. So then why do we need to describe again? All right, so, okay, so delta UIP equal on the delta F, right? This is the regression. Both sides are equilibrium objects, right? Both sides are outcomes of the system, their model. OLS is going to cover a projection coefficient, is a combination of supply and demand. Elasticity is not structural object. OLX said yes to that. Okay. No identifying variation. There is no instrument, no experiment, no timing restriction. IRFs are like, this F is being regressed its own innovation. Reverse causality is equally plausible. Maybe dealers are repositioning as a response to premium. We have no idea. So that will be a completely different model, not this model. Omitted common factors are not in the time fixed effect. I'm sorry. That's only the things like VIX in the time fixed effect. Everything about a currency specific demand, about the local stuff is not there. That cannot be observed. High R square is not evidence. If you just cannot say, I'm not going to do structure identity, but high R square is enough. No, it isn't. And I'm going to tell you why. Because under the omitted factor null, you get an equal high R square. It says nothing about this model is the right model and it should pass. High R square cannot discriminate between alternative hypotheses. Since we wrote our 5 facts of the UIP paper that does, documents all this in cross-section and time series, there are many models. There is nothing that all that show that we should take this model over the other models. So of course they can do better. I mean, these are smart guys. They have great data. Why not do better? Instrument that delta F, right? You can instrument it with mandated flows, index rebalancing. There's this Tuesday release of this Chicago marginal exchange. You can do frequency identification around that. You can do a lot of stuff. More so, that value at risk constraint tells them that beta has to be larger than constrained by tighter. Test that. So what is the thing that falsified this model? Before telling you exactly how to do that, let me go to this measurement thing. Yes, but okay. But let me show you this because this goes back exactly the Adrian's. This goes back to the Adrian's question. I'm just going to show you. So the model is about OTC model. That's essentially the model, right? So and then so that's basically what the model is really about. The forward effect model is about. That's the 61% of the model. Okay, great. But the data they use, the CME, Chicago Marginal Exchange, that's 1% of it. 1% of this.
Isn't it amazing that you get an R squared from 1%?
No, I'm going to come to your R squared. With the, again, I made this point. Wait, with the position, it's reverse. 0.3%. Their delta H variable is 7 times smaller than the actual, turnover. And the chief economist of the commission, Authority Procedure Trade Commission, they have said this is not where the risk is transferred. This market is not where risk is transferred. This market is a small market, price discovery market with very small balance sheet on the intermediates. This is that one. The model is about the Otis market. The model is about risk transfer. Okay, so they are using something that has nothing to do with the model. So now let's go back to this whole why the R square not work. They assume this. So you go to this from the Chicago market to OTC market. That's the this eta K coefficient. They assume it has to be bigger than down to 0, and then of course they show it. That is, the point that a higher square, my model is confirmed. No R square will be claimed on this variable, right? Because it is measured with that. It's a proxy. So there is no way to falsify and test the model in time series. And in cross section, they reject their model already, as you see in table 2. The signs are wrong, so it's already rejected in the cross section. How can we, improve in the time series, make the model falsifiable? Exactly with those tests I suggested. So then, it's the model you are testing and not just the description of today. Thank you.
Yeah, that's right. Go.
I mean, I agree with Shabnam
Great.
on a lot of things that she says, but it's just not the game we're playing. I mean, she's describing a different exercise. It's not about the model. I don't care about the model. As I told you, I want to describe the data. Describing the data requires a conditioning on some variable. I don't care whether it's endogenous or exogenous variable. Like if you condition on interest rates, you explain no R squared. If you condition on this movement in the currency market, you explain a lot of R squared. It's true, this is a small sliver of the currency market. It might be the one where price discovery happens, and we truly found the marginal agents will price it. It might be not, but I don't care. I only want the conditional exercise. And the reason why the instrument would not work for this type of exercise is instrument is for well-identified elasticities of something used for counterfactuals. I'm not about that. I'm about describing the statistical properties. In particular, what emerges from that UIP, CAP are different objects, and UIP moves in a particular way that's consistent with the model. But that's pretty much where the only place where I
Good.
Who's,
Oh, we did.
yes, yes.
Okay, thank you so much.
Okay, so we are switching gears a bit for the last paper of the morning. We have Hassan Afrouzi talking about technological change and career ladders, a joint paper with Andres Blanco, Andres Renick, and Eric Hurst. And I think maybe everybody in the team is here, so that's very exciting. And Guido Mencio is the discussion leader.
Okay, thank you so much. Thank you for giving us the opportunity to present this work, and the usual disclaimer applies. All my co-authors are here, but I am the one on the line of fire. So, all right. So this paper is motivated by the question of how artificial intelligence is going to affect human capital accumulation. And the reason that we got interested in this was because there are conflicting narratives out there that both that seem to be on solid assumptions. One, we've chosen like the words that are out there as a starting point to kind of like try to organize our thoughts around. So one quote comes from Dario Amodeo, who's the CEO of Anthropic, that AI could wipe out half of all entry-level white-collar jobs within the next 1 to 5 years. This is a quote from last year. This just reflects the concern that AI, by automating cognitive tasks at the bottom of the career ladder, is going to just deplete the economy from the entry jobs and the entering workforce that would eventually become the seniors and have the human capital to create new things and have high human capital in the economy. It's reflected also in this Boston Group Consulting Group report that when everyone uses AI, companies risk losing their critical skills in the long run. So I'm going to call that the pessimistic view of AI and how it's going to affect human capital. The alternative is that AI is so amazing that we're going to do so many new things with it. And that's reflected by this quote that we now recognize this general purpose technology we call intelligence as an opportunity to create new industries, create brand new jobs, which is from the CEO of NVIDIA, Jensen Huang. So this has the alternative interpretation, or at least alternative view, that who cares if we're going to automate things, we're going to create so many new things to do that we're going to have a new workforce coming in and doing new stuff, and they're going to learn on the job based on that, and their human capital is going to increase. And this effect is going to be so strong that human capital will eventually depreciate in the economy. It's captured by this other narrative that the McKinsey report recently that reimagined learning and development for the age of AI. Okay. So both of these seems kind of plausible. So we're going to ask, how does a technology like this that has automation and frontier expansion possibilities affect the human capital accumulation? And we're going to write a theory of that. We're going to write an equilibrium model of human capital accumulation with endogenous learning, automation, and frontier choice. Learning so that workers can accumulate human capital, automation to capture the pessimistic view, and the frontier choice to capture that optimistic view. What we find in this, just like a preview of what we're going to find, it's going to be a model with unique equilibrium, but multiple steady states, as I'm going to explain, with high and low levels of human capital. As technology becomes more productive, so we're going to introduce this technology and make it more productive. As technology becomes more productive, two countervailing forces are going to emerge. On one hand, more automation is going to hinder the learning on the job, consistent with the pessimistic view. But on the other hand, the endogeneity of the frontier is going to imply that task frontier will expand and facilitate more learning. And what's going to come out of the theory is that for low levels of productivity, when technology is introduced and it's not as productive, the second effect is going to dominate, and human capital is actually going to expand in the long run. And for very high levels of productivity, it is going to be the case that the pessimistic view can actually prevail and lead to diminishing human capital in the long run. But I'm going to argue that that's going to be close to efficient in a sense that I'm going to make precise later. So I'm going to be leaning towards the optimistic view as I go through the end of the paper, not to keep it a mystery. So with that, I want to jump into the model. Okay. So it's going to be a model with continuous time indexed by t. A unit measure of individuals are going to be on the household side, either working or managing in a sense that I'll define. And there's going to be a representative atomistic firm. Workers are going to be heterogeneous in their human capital solely due to life cycle dynamics. Their human capital is going to be X. They're going to die at the rate of chi and are going to be born with a human capital that I'm going to call X, and I'm going to normalize it to 1. So these individuals are going to accumulate human capital through learning by doing in a way that's endogenous to the economy. And the individual decision is going to be when to become a manager or when to work. And again, I'm going to define the notion of a manager, but loosely speaking, workers are going to produce and managers are going to create new tasks for workers to do or to be automated. Firms' decisions are going to be hire workers, hire managers, create new tasks, and potentially automate existing tasks. So let's go through the model in more detail. So technology, there's going to be a production technology for this economy, which is going to be at any given time t, an integral from 0 to ft. Think about ft as the number of tasks in the economy or the measure of tasks in the economy. Y tau t is going to be the output of task tau at time t to the power of 1 minus eta inverse. That's just capturing that there's decreasing returns to scale in production of tasks. And firms are going to have the ability to produce this task either using workers. Workers can come in different varieties in terms of their human capital. So the firm can decide how many workers of different human capital time to allocate to a particular task. Or they can just produce it in a perfectly substitutable way with a technology that has productivity z tau in producing task tau. And the demand for that input is going to be AE tau and T. That's my AI essentially. So as I discussed, eta is going to govern diminishing returns of production. Tau is going to be indexing tasks. F is the task frontier. This is terminology that I'm going to come back to. X is human capital of workers. A tau T is technology input for production. And for Z tau, we're going to assume this functional form, but that's not going to be important for a while. The key assumption here, or the key organization, is that we're going to order tasks such that lower tasks or lower index tasks are more amenable to automation. So AI is more productive in automating low index tasks.
At this stage, I mean, there's E and the AE.
Right. So what I'm going to do is that I'm going to have a production market for this, and I'm going to play with the productivity of A. And then there's a task productivity component. So there's an aggregate productivity component to this that I'm going to play with. And this is like the task-specific productivity of that. It's not coming, but at this stage, yes.
It's just one sort of funny observation. I was reading an interview by Jensen Huang, where he claimed that the most important use of Claude is to make the next generation of Claude. And so that may conflict with your assumption that it's automating low tasks. Maybe it's all the high-end stuff that's gone. That is, it's not the RAs who are going to be driven out, it's us. We're out.
It could be.
Anyway,
from a modeling perspective, we can get to that discussion when I'm interpreting things. From the modeling perspective, this is how tau shows up, and I'm ordering it. Like, so, you know, like then we are the low index taus. That's fine. For now, it's fine. Yeah. So, sorry, can you?
Yes, you know, one, I got up, but if that's be complement, those are something.
So I'm gonna, okay, so eta plays two roles here. One, so you can imagine that my production function was a CES with eta, and then I had a decreasing returns to scale production function for the whole thing. I'm assuming that the decreasing returns to scale parameter is 1 minus eta inverse to get to the simplification. by assuming eta is larger than 1, I am assuming the tasks are substitutes. But in that narrative. But here, what really matters for the results that I'm going to show is the fact that eta larger than 1 here, all I need for now is just a diminishing returns to scale. So we can postpone that discussion to later, what that would do. It interacts with my assumptions for the learning technology. So like all this ordering is going to do is just going to give me a cutoff task that like for tasks below some tau star, they're going to be automated by the firm. And for tasks above some tau star, they're not going to be automated. Note that they could be in the corners. So we can decide not to automate anything or decide to automate everything. So then we talked about this FT object. That itself is going to have a production technology that is going to be a CES between, again, we can use the same technology. I'm going to call that AM tau as input for producing new tasks, or we can use manager labor that I'm going to call ST to produce these new tasks. We're going to get to the distinction of managers and workers later. This is a different labor market. And I'm going to just cap it at some F bar, that there's only so much that you can do with it. Later, we can think of that's for now for technical reasons of keeping the space compact. We can later send this to infinity if you want. But there's like a maximum amount of tasks that we can produce. Keeps things bounded, keeps learning bounded later, as you will see. So what is this ST? ST is going to be an aggregation of, again, different worker inputs. So remember, I have defined X as to be like effective labor supply for production. Now we're talking about the labor supply of, I don't know why, I think this is very sensitive and I'm just like that. All right. I have defined X to be efficient labor supply of worker with human capital X in production. Now, if they if they want to use that human capital in creating new tasks, there's going to be a transformation H of X. That's going to be their labor supply. I'm going to assume that this H is going to be convex. This is the idea that if I work more, my X has increasing returns to scale in terms of like creating new stuff. This is the idea of learning by doing, that when I create new tasks, I can be more informed. And then again, I can use different workers with different X's in constituting this labor supply. That demand function is just going to be this distribution NM. So then some parameters that we can play with later, I don't think I'm going to get to, but tau bar is the exogenous productivity and production of tasks of these two inputs. Psi is the degree of the input share. It captures the input share of each of these inputs that I'm going to play with. And then omega is the complementarity. This one definitely I'm not going to get to talk about today, but I'm going to give you some examples with this psi. So then on the household side,
Go back.
absolutely.
So there's people in the S's, and go back one more. And there's people in that, and that's not the other structure. Anyway, whatever.
So in both cases,
Some of the stuff are those technologies totally exogenous? Now
this?
Wait. So that AE tau thing is exogenous, or?
That's input. That's how much you want to like, you can, it's.
Okay.
I'm gonna get, it's not even an exogenous it's like, think about QM versus the productivity of like some other firm. Like some other firm is gonna produce this on the supply side that has a price, and then you get to demand. You get to decide whether you want to do it with workers as a firm or like with that technology. Z tau is the exogenous component. Okay. So preferences. Households of every cohort cohorts are like, based on this perpetual youth idea. Households of every cohort are going to maximize their lifetime utility. Their utility is going to be linear in consumption. Their occupation choice at any given moment in time is whether to work or to manage. These are two different labor markets. If I work as a worker, if I decide to work as a worker, I get WET multiplied by my human capital. if I become a manager, this is how my human capital counts, and then I'm gonna make a wage of WM tau. Okay. So given that, at any moment in time, my value of my flow value is just going to be the maximum of working as a worker, getting the wage, counting my human capital gains, working as a manager and counting my human capital gains, plus maybe I have some profits coming my way as lump sum transfers from the firm side because there's decreasing returns to scale and firms might make profits, plus how the value changes over time. Yeah. So that labor market is homogeneous. I take all my human capital, I go supply my labor, the firm hires me, and then they assign me to a task. Okay, and then I get paid based on the human capital that I brought, not what task I'm doing.
But there's no really notion of the worker being assigned to a task. It's just there is an efficiency unit of labor that you supply, and it enters the production function. It's immaterial to which.
Correct, yes. So I mentioned that human capital accumulation is going to be endogenous. The way that, so this fee that was showing up here on the capital gains that shows up both for workers and for managers is going to be endogenous to the economy in the following way, that every person's human capital is going to grow at a rate that is specific to the labor market that they're active in. And hold it over here. That learning rate is just going to be an increasing function of tasks done by workers. Okay? So the idea is that it's a learning from coworkers model, going back to Guido's work, for example. And if I take the total amount of tasks, subtract how many of them have been automated, that's the amount of tasks that are being done by workers in these representative firms. You show up, you're in the assembly line, or you're doing these things with your coworkers, and you learn on the job proportionally to that. So if there's nothing for you to do in a firm, there's no learning by doing. If there's more for you to learn, there's more learning by doing. So potentially the coefficient that shows up in front of like this linear object could be different for workers versus managers, that captures that this learning by doing might accelerate human capital accumulation for actually working individuals rather than managing individuals. Again, this for now is immaterial, as we'll come up, we'll talk about it later. And I'm going to take these deltas as exogenous for now. One could potentially imagine that AI would also affect that, but we're not going to talk about that. So with this formulation, so the highest learning rate that I can get in the economy is, I'm going to call that phi max. And that's when we're hitting the boundary of tasks F bar, and we're not automating anything. So that's delta F bar. For today, I'm going to assume that delta F bar is less than chi, so I don't have explosive growth, but one could potentially talk about that. Yes?
So you ordered the tasks, like, you could have alternatively assumed that amount of learning is like the average complexity of the tasks that you're doing, as opposed to the total number of tasks you're doing. Is that a meaningful distinction?
Absolutely. So I call tau. So tau, for me, indexing of tau is just like only matters through this z of tau, that is amenability. So you're interpreting that as complexity. I'm just capturing that as amenability to automation. Okay, and you're right that I can just also come here and say that, well, higher order. So maybe there's some covariance between amenability to automation and complexity and how you learn from that. That would create some, this goes a little bit also to Ariel's question, that are tasks like complements or substitutes, that complementarity or substitutability also can show up here, in the sense that if I learn from a larger mass of tasks, do I learn more or do I learn less? Here, I'm just like assuming very simple linear. So both of those are valid. And yeah.
So what's curious is the way I learn is by learning on the job. But if we look, I'm gonna make up some facts, which is that, you know, workers, when they start, now have much more skills than they used to. And then also we try and sometimes segment off learning so that we don't have to mess up production. And not have, you know what I mean, these are, all I'm saying is these seem like non-innocent assumptions. I mean, they're assumptions that are drive down the line the kind of answer you're gonna get, you know what I mean?
Absolutely. So let me put it in a way that we have thought about it, which is that I'm assuming that all learning happens on the job. And I'm gonna have like some externalities coming in that firms might not endogenize the fact that by assigning workers to work, they're actually providing also like, you know, this human capital accumulation. That's a typical missing market argument that there must be another market that tries to pick up that slack. We would call that education, for example. So I am completely abstracting away from that. I'm gonna show you that I'm gonna give like, you know, this model all the chance that it can have to create externalities relative to what I'm gonna call the efficient allocation. And then I'm gonna say that it's only for very intermediate values of the productivity of this technology that's gonna be a big problem. So in that,
That's it, that's sharp. I like
okay, all right.
Can I ask a question about the externality? I want
Sorry.
to, I'm sorry.
I just wanted to, I guess, put it, this was my main comment about the structure. That in a sense, I feel like you're setting up the labor market in the wrong way. You're putting together as the same object all the jobs for, say, employees. Well, a job should be a set of tasks that you do, and if you're hired to do blank many tasks, you understand there's going to be more learning on the job. You're willing to take a lower wage. So you would think that you have to distinguish, structure the market as there's a labor market indexed by how many jobs how many tasks you do in each one of them, and that fetches a different wage. And I think that once you do that, all of the inefficiencies go away. And I think it's hard to think why that wouldn't happen.
So again, I am going to argue, I'm going to set up some inefficiencies. So like, first, let me.
The inefficiencies that
Why don't you go to your slide that has the externality language? Because I had a different version of Guido's.
No, I think
Skipping. I was here already, like, so it's right here.
He was here already, he skipped to a different slide. I think this is the key slide. That's what Guido's saying, and I.
No, I think my point is on the previous slide, is on what the wage is. You put in time, but the wage should depend on the content of the job, because the content of the job matters for the value of the job to the worker. And of course you can say, well, workers can't tell jobs apart, but if this is a long run paper, you would imagine that if this is a big issue,
Okay.
Yeah, no, it
Yeah,
is.
I
That's
think
where the
two slides-
externality is coming.
The two slides. No, go to the next slide. Go to the
Okay.
next slide.
All right.
It's really the next slide, I think. The question is, when you say that that phi of t is a function of that expression, are you thinking about f of t as the economy-wide frontier or the firm frontier? If I think of it as the firm frontier, which I think is a natural interpretation in this context, then the key is there's not an externality. You have forced firms not to enter into long-term contracts. If a firm entered into a long-term contract.
It's not even that.
I sympathize with all of that. I'm just gonna say, I am trying to bend backwards to give this externality all the chance that it has, and let me come back to it in the end.
Like, in other words,
Ma-
take posting jobs. You post out, you say the characteristics, and then they do what they want. So the externality Charlie's talking about is like, I don't think we count my work yourself, your work, that's outside the firm. But inside the firm, it just sounds like you're screwed up in a weird way.
Yeah.
So
Well-
it's not even
narrower than Charlie.
No, it doesn't even have to do with long-term contracts. It can be just one, firms can be static.
One could just like imagine, like, let me just like put it in a way that I understand it. One could imagine a directed search framework that I post exactly what task you're going to be working at, what FT is going to be there, what tau star is going to be there. And then to the extent that we can write that contract to its full extent, of course, we're not going to have
But it's
any.
not a contract, it's forget about directed search, arrow the brew.
Yeah,
These are different commodities. They fetch different prices.
exactly.
Okay.
And you're collapsing them in one, which one interpretation is that that thing is economy-wide, so a firm can't deviate. But it's not
But once a worker shows, that's an issue of like, once you hire a worker, there's also like some notion of lack of commitment. Let's take this assumption a little bit seriously. There's a notion of lack of commitment that when a worker shows up at my firm, if all that matters is your human capital, I can always I said, oh, I promised that you're going to be an accountant, but it turns out that I need like you to just like go and work on the assembly line.
I agree. If firms can commit, then there is a single price
Absolutely.
and the choice is made exposed. However, you would think that reputation of firms would play a role, let's say.
Don't be firms, it's not for firms to drive them out of the market, because you're doing inefficient credit.
But I think Guido and I are saying the same thing. Whatever assumption you're making, it is an externality that doesn't come from global activities affecting me. It's something about local activities. Therefore, I think there is a payoff to getting into the nitty-gritty details. Lack of commitment on F, whatever it is,
Absolutely.
just spelling that out there's an advantage. Otherwise, it looks like a weird
Yeah,
assumption.
I have it here. So the idea, the justification would be exactly what we discussed. We don't go any deeper than this, but I agree that we should do.
You need some incentives to do. There's no lack of commitment, it's like you can't verbalize what they're gonna do versus.
No.
How are you?
Pat, exposed, once I hire you, I would want to choose that tau star.
The next batch of college graduates, they're not gonna go there. Goldman Sachs.
No, it's like rational
That's an
expectation. But it's rational expectation. Everybody knows that you're going to do this.
No.
So if there's lack of commitment.
No, the reputation stuff says you have an incentive to adopt policies which are temporarily self-defeating, but in the long run profitable.
Absolutely. But that's a different model that I agree. Maybe we should entertain. But let me just let me write the model that I'm writing. Let me show you the planner's problem, and then we can compare the two extremes of this. And I'm happy to come back to it. Yeah. So what that does, so I'm going to show you now two different versions of the problem. In the equilibrium, the firm is not internalizing that any of their automation or frontier choice is going to affect the learning rate. And that's kind of like going towards capturing this pessimistic or optimistic view that whenever these people are talking about, oh, we're going to automate too much or we're going to automate too little, that's the idea that firms are not doing the optimal thing. And the reason that firms are not doing the optimal thing in the minds of these people is that they're not internalizing the long-run consequences. So let's entertain that idea. So the firm is going to take the human capital accumulation rate as given, because that's an industry level object and this firm is atomistic, and they're just going to decide how much of everything they want to produce. Again, there's going to be a automation threshold below which the firm is going to produce with this technology, given the specific productivity of technology in producing that object. There's also going to be tasks that are above that threshold and are going to be produced by workers. So profit per task for automated tasks, profit per tasks for non-automated tasks, and then how much you pay to the factors of production of ideas in these tasks. Okay? Where now we're just going to aggregate experience going to, or human capital going to task tau to these X objects that show up here. So I don't have so the technology good itself, this AM and AE, is produced by a representative firm with constant returns to scale that uses the final good in this economy and converts this to this input with productivity 1 over Q. So that's just going to imply that the price of this technology in units of the final good is just Q. And this is the object that I'm going to be playing with when I think about the technology becoming more or less productive. Okay. So definition of the equilibrium, allocations for firms, households, and prices, plus the new object is this human capital growth rates, fees, such that given prices and these fees, households and firms optimally solve their problems, noting that everybody takes fee as given, labor market's clear, human capital growth follows this rule, and the distribution of human capital evolves according to the inflows and outflows implied by these endogenous learning rates. Okay. Yeah.
So you have this thing that you get this A, you can assign different tasks. And then the relative productivity is always the Z of tau.
Yes.
And so, let's say now my computer solves differential equations twice as well as it solves partial differential equations. That stays constant forever as frontier.
Correct. We're fixing that as a yeah.
Somehow that misses this idea that we're getting more and more like, we're getting away from like just robots that turn a screw to, solve an Erdős problems or something, It's missing that this technology coming.
So I am interpreting the
More substitutable with high skills. I don't know where that would show up here, but it seems like everything's linear, so it wouldn't show up at all.
right. I am interpreting this technology.
Yeah, then in core, they were complements to skills.
I see.
But how are they gonna put us on it?
So they like flip the interpretation.
I am thinking about this technology as one that can be used for generating ideas and for automating some stuff. So I think like the technology that we have in mind is automating cognitive tasks, not the robot that was turning the screw. So I think that's the way to think about it. And I am fixing that. There may be an argument that that's spreading over time. So like just because I'm going to talk about a stationary equilibria is where allocations, prices, and distributions are time invariant. So we're going to contrast that equilibrium with what we're going to call the planner's problem. So the planner is going to maximize household welfare with Pareto weights equal to these discount rates that I had for households across cohorts. And that's going to imply that this planner is going to maximize the net present value of discounted output minus payments to AI. Because they still have to produce the amount of AI that's being used in the economy. And the only difference is going to be that they have all the constraints that the firms and households have, with the addition that they're going to also internalize that their choices of automation and frontier is going to affect the learning rates of these two guys. So this is kind of like this was a complicated model for us to contemplate. So we have a plan of attack that we're going to go through this in different like at increasing rates of complexity. I'm going to start with a very simple example with exogenous learning to just show what endogenous learning does here. The second example is going to be exactly that endogenous learning, excluding the frontier choice and the endogeneity of that. And then I'm going to put both of them together in the context of a final example, and then I'm going to go to the full model. The key aspect of these three examples that I'm going to consider, and the reason that they're useful to think about this problem, is that in all of them, as I'll show, average human capital of workers is going to be the sufficient state variable. So we're just going to be talking about first order ODEs in one variable, which also means that in these first three examples, I'm not going to have managers at all. So that career aspect is going to come in at the very end. And that's an aspect that we're still exploring. So I'm going to have little to talk about that. So example one, exogenous learning. Suppose that we didn't bring any of this endogenous learning stuff. This is going to be just Asamoah Restrepo in our framework. Okay? So we have an exogenous learning rate fee. So here we're just like fixing it exogenously. Again, to keep things non-explosive, that has to be less than the rate of death. And then the frontier is also exogenous. So we're assuming that this thing is binding. And there's no career choice. So everyone is working. So what that means is that human capital evolution, so if I call the average human capital, the aggregate human capital of these guys X, the change in that object, there's an inflow, which is that workers are learning at the rate of phi, proportional to the aggregate amount of human capital, and they're dying at rate chi and going back to 1. Okay? It's a very simple like differential equation. You can solve it. It's self-contained. It just shows that with exogenous learning, there's no interaction between the price of technology or the productivity of technology and human capital. So that's kind of like that's where we would start. Even though the human capital itself is independent of the technology, there is still automation going on in the background, in a sense similar to Lewis repo. At any point in time, the supply of experience or human capital is xt, and that is being demanded by firms given the amount of stuff that they're producing with workers. So thinking about what the total labor demand in this market is going to be, there's F bar stuff to produce, tasks to produce, tau star of them are going to be automated. We don't know what that is yet. Given the automation, this threshold, because the firm completely is myopic and does not internalize the effect on phi, this tau star is going to be determined such that the wage of the worker on the margin is equal to the marginal cost of producing that task with AI, which is Q times this Z function that I have assumed already. So this function in total is just labor demand per task. This is how much I would demand for the marginal task to produce. This is how much stuff I'm producing with workers. The product of these two is my total labor demand. That has to be equal to labor supply. This is a stock variable and fixed at time t. And you can see that now this side is a decreasing function of tau star at any time t. This is given. So tau star is determined by labor demand being equal to labor supply as a function of that. If tau star is interior, there could be also a situation where we don't want to, well, here because the labor, assuming that this is strictly positive, there's always going to be a tau star because you want to hire some workers. Okay. And the key is that tau star instantaneously, given the level of xt, tau star instantaneously jumps to where it needs to be. So there's no persistence in the automation threshold. Okay, so that's just a benchmark to keep in mind.
But there will still be dynamics as xt follows its independent motion.
Absolutely.
There will be dynamics on the automation.
On the tau star,
Yeah.
just but only following it doesn't have any intrinsic persistence. It's just following dynamics of xt. Absolutely.
And that one goes in the natural way. If labor supply is abundant and it's coming down, automation will be decreasing.
Exactly, because the abundance would mean that wages initially are low. No. So let's bring in endogenous learning to the same set. So keep the frontier fixed, still no manager, so xt is just a human capital of workers. Just add endogenous learning to that object. So now I'm going to assume that learning is proportional to f bar minus tau star of t. We are still keeping f bar fixed. We don't have any endogenous frontier yet. Okay. So this one, now again, the same law of motion holds for the human capital. There's an inflow proportional to phi, an outflow of people dying and going back to 1. You can still say that in some steady state, if it exists, the x is going to be death rate over death rate minus phi. But phi is now endogenous. In what way? In a way that's going to come from, again, clearing the labor market. Okay. So let me use this, let me invert the learning rate and say that f bar minus tau star at any moment in time is just v over delta. Okay. So that's the number of tasks that are being done by workers. So if I come back and think about my labor demand, remember my labor demand is how many stuff is being done by workers, which is now v over delta, multiplied by labor demand per task, which is going to depend on the wage to the power of minus eta scaled by 1 over 1 minus eta inverse. Okay, so that's total labor demand at a given time as a function of phi and as a function of q, because WE is being again determined by the marginal task. Okay. Same equation as before, that on the margin I should be indifferent. So wage of the worker is the marginal cost of producing the marginal task with AI. In a stationary equilibrium, that labor demand should be equal to labor supply, chi over chi minus phi. Okay? There's also a no automation corner where phi is equal to delta F bar and demand could be less than supply. Okay? But in the interior, demand should be equal to supply. So let's look at how this is going to work out. I'm going to start plotting this labor demand and labor supply, not as a function of wages, but as a function of the learning rate. So in that space. And then I'm going to talk about what Q does. Something to prelude is that both of these are going to be increasing functions of phi in a way that we're going to see. The thing that I want you to keep in mind is that labor supply in a stationary equilibrium does not directly depend on Q. It only depends on Q through the learning rate. Okay? So if I shift Q in this phi space, it's not going to shift supply. It's only going to shift demand. So let's plot them. So the labor supply was a very simple object. It was just like death rate over death rate minus phi. So that's a very convex object. It asymptotes as phi gets close to the death rate. We already assumed that the maximum learning that can happen in the economy is going to be less than that. So phi max is less than chi here. And we've discussed that in some corners, you might end up with demand being less than supply. So this might be an equilibrium in some occasions. Okay? Then any interior equilibrium is going to be the intersection of demand and supply. So demand, if we just think about holding Q fixed, how it's going to be affected by phi, remember phi is just proportional to the number of tasks done by workers. So if I have more stuff to do with workers, I'm going to have higher demand. That's the upward sloping demand function. And that's going to have two intersections with this supply curve, constituting either two intersections or zero, but let's say two. And then like there's a very specific situation where they're tangent and there's only one. That's a bifurcation point. So in these two interior equilibria, you can sustain. These are stationary equilibria, right? So like if you specifically start from the human capital that emerges in those steady states, you would stay there, okay? So let's think about that for a second. We have a low phi equilibrium and a high phi equilibrium. How can that be? The logic goes this way. Suppose workers live in a low phi economy, and their human capital is exactly what it needs to be to sustain that. Then the argument is that the economy will stay there. Why? Because in a low phi world, there's going to be less learning by doing. The death rate is still the same thing. So the amount of labor supply effective labor supply is going to be low. The effective labor supply is low, then wages are high. If wages are high, firms are motivated to automate a lot of tasks because relative to these high wages, they find the technology more attractive. But if they automate too many things, remember the frontier is fixed. So that's going to imply that F minus tau star is a lower object, which is essentially our phi. So that's going to sustain that low phi. Okay, and that's going to be an equilibrium. You could have alternatively started from a high phi. High phi means that we're going to have a lot of labor supply in that steady state. Start from that steady state. Well, there's a lot of labor supply, wages are low, firms have no incentive to automate, and that's going to sustain the high learning equilibrium. Yes?
There's an alternative way which might be more instructive, but may not be. To do it in terms of the life cycle of the worker. Start with a newborn guy who starts at 1. Why doesn't he want to grow very fast? Because wages are the wage profile is not sufficiently steep.
Exactly.
That might be a different way of explaining this.
Absolutely.
May or may not be, I don't know.
Yeah, we should explore that definitely.
My question is, I was wondering if you could go back one slide. So you have this is a plot of the null line of the two differential equation. You have one for X.
Yeah.
Okay. And the other one, what is the second differential equation that there you're evaluating at steady state is a differential equation for which object?
This one?
No, you see, that's a steady state condition.
Oh,
I'm looking forward. This is the plan that I would have in mind. You give me one differential equation, then there's a second one. One is the x, it's the backward looking. Then you have the forward looking, and then you plot these new lines in their space, x and the other variable. And then you can do the phase diagram and can understand all of the dynamics very easily.
Right. Here, I don't have the forward-looking one yet because that comes in only when I have like the occupational choice. Here, everyone is a worker.
So,
Okay, so this is the only differential equation.
there is no dynamic decision.
There's
Essentially.
no dynamic decision, exactly. In this one, there's only like, I'm just like explaining the nature of like how the choice of phi comes to be in the equilibrium. That's exactly. So I'm gonna transform this to write the same differential equation in the phi space.
So Hassan, can you write the second equation with a generic xt?
This one? I'm
Yes.
gonna write it. I'm gonna write it in a second. So I'm starting with stationary equilibria, and then I'm gonna go to the transition dynamics, and it's coming. Okay, so that's the nature of possibly two interior equilibria and one corner. Beautiful. Okay, great. I was worried that I'm going too fast. Apparently not. Yes.
So the other thing, if you go back to the previous slide, the other thing driving these two equilibria seems to be kind of this uniformity.
Two steady states. No?
It's two steady states, sorry. Is that uniformity in how this externality and the task interact. So for example, here, as you automate more, the externality becomes less of an issue. But suppose I thought about automating kind of mundane tasks for which the externality is less versus now when we automate, people are doing all these thinking activities for which the externality is big, then this channel is no longer operative. No, it may go the other way.
I have to think about that. That goes a little bit towards like Gabe's question, like, in terms of like heterogeneity and amenability for automation and the degree to which it interacts with the externality. I have to say, I don't really have a good answer in mind. Let me think about that.
Based on your earlier discussion, is it clear that there's an externality here? F bar is fixed, so you're not doing anything with the frontier. So
It
what
is. I'm gonna show you the efficiency.
Later on, but I'm talking about in this particular example.
Half star.
Oh, the tau star, I see. Okay.
Yeah, there are two margins, the tau star and the F.
Sure.
Yeah. Okay, so just very quickly, how would a decline in Q? So let's make this technology more productive. How would a decline in Q affect this market? So again, remember that Q doesn't really affect the supply curve here because supply curve is just a function of phi. I'm plotting it. There's no direct effect of Q, so it doesn't do anything to supply. In contrast, it shifts demand because demand is a function of the wage. Wage depends on phi, but also independently depends on Q through the automation threshold. Remember that the wage has to be equal to the to the marginal cost of producing the marginal task. If we make the technology more productive, Q, the price of technology, will fall. That's going to put downward pressure on wages. If wages go down at any level of phi, now I want to produce more per task. So I'm going to shift my demand up. So that's why like this new demand curve is going to be upwards. It's going to push these two interior equilibria away. The phi max, if you're in the corner, you might stay there. Okay. So to steady state, which with like one corner stationary equilibrium, how to think about the transition dynamics of those. So very quickly, this is what Guido was asking. So I wrote this in the steady state. Now, remember that my demand function depends on phi and Q through the wage. Okay, so I've already written the specification of that. It's just going to be the number of tasks, which is phi over delta, multiplied by a function of wage that is a function of phi and Q again. At any moment in time, because X is a stock, this demand should be equal to X. One can invert this given a particular Q and write phi as a function of X. This is a very like well-behaved object. So phi becomes a function of the stock, and Q, which is the parameter that I want to play with. So that's why I'm putting it as an explicit argument. This phi is going to be increasing in the human capital and increasing in Q for the reasons that we discussed in the previous slide. Okay. So now dynamics of the state, let's just remember now x dot is going to be this function of x and q, which is the learning rate, which itself is a function of x and q times x, that's the inflow, minus the outflow, which is people die and go back to 1. So just a reminder to myself that a steady state is just going to be a 0 of this function, and it's going to be stable if and only if the first derivative, meaning that the derivative of this Beck f function with respect to the stock is negative. Okay, so that it's crossing the 0 with a negative slope. If we're above it, we go back. If we're below it, we go up, and we get back to the same steady state. So then we say if a steady state is a 0 of this function, we can totally differentiate that function and see how the steady state human capital is going to change with changes in Q. That's going to be the second derivative of the f function, which is f only depends on Q through the learning rate. So it's going to be the derivative of the learning rate with respect to Q divided by the derivative of the minus derivative of the big F function with respect to the human capital itself. This is a complicated object, but remember that for stability, this has to be negative. So the denominator in a stable steady state is positive, and the sign of how a steady state human capital is going to move with Q is just going to be the direct sign of how Q affects phi, okay, in a stable steady state. Okay. In this particular example, higher Q or lower productive technology is going to increase the learning rate because that automation threshold, automation will be lower with lower productive technology, more stuff will be done by workers, the learning rate will go up. So as a result, cheaper technology is going to reduce human capital at any stable, steady state, including the interior one. So I'm going to just take a very quick intermediate step and say that let's take, because ultimately we're interested in knowing what's happening to the learning rate, let's take our original differential equation in terms of x and convert it to a differential equation in phi. That just happens by, remember, phi is just a function of x and q. Q is not changing over time. There's only MIT shocks to it. So phi dot is just a derivative of phi multiplied by x dot. So I can write it that way. It has the nice feature that the direction in which the phi is going to move in the transition is going to be a function of what level of a steady state human, steady state supply that phi is consistent with in the long run, minus the current level of supply of human capital, which is equal to demand by labor market clearing. So this is a notion of excess labor supply that pushes learning in the direction of either increasing or decreasing as a function of that excess labor supply. If I was too fast on that, it's the same differential equation that we had before. We want to look at a phase diagram of that. If I plot it, remember, I have potentially, yes.
I didn't follow everything, but is that left guy in that first graph that was the stable one, not the right guy?
Yes. So I'm going to show it to you right now. Like so I'm showing it in the phi space, but the ordering is the same. So low phi, low human capital. So the left guy there is still the left guy here. Okay? That's the stable one. There's also the corner that's also stable. And then the middle one is going to be the divider of the basins of attraction. Okay, so if you happen to start from there, you will stay. But then whether you're above or below it is going to determine which one you go to. So very quickly, suppose we're making technology from, like we don't have this technology at all. So the productivity of it is 0, meaning that Q is infinity. And we're going to start making it more productive and potentially go towards Q0. Okay, so what happens is that at very high levels of Q, technology is not productive enough to automate anything. So everything is like done by workers. Learning is at maximum. So that's the only equilibrium that's possible. Very low levels of Q, technology is infinitely productive. So everything is automated. There's no learning. You go towards this. Well, many things are automated. Your learning is very low because there's not much done. There's an intermediate stage where you can have both equilibria. Both steady states. Sorry, I forgot to say this was a first order differential equation with a well-defined boundary condition. It's Lipschitz continuous. It has a unique equilibrium always. Okay, so what determines which steady state you go to depends on which level of human capital you're starting with. So let's start from the left branch. If you start from this steady state and then Q all of a sudden falls to this, you're going to continue going to this branch. Okay? If you started from the high branch and Q falls, you're going to stay on that branch. Okay? So then what would a social planner do? The social planner would have a similar policy, except that they're more tolerant of going to the high one. Okay? So that's only that it's basically looks the same. For high Qs, it's the same. For low Qs, it's basically the same. In the intermediate region, you now want, so for some values of X, when the shock to Q happens, the social planner would want to go to high learning, but the equilibrium would want to go to the low learning. So that is all the extent to which this externality matters.
It would have maybe been easier to see these pictures as, at the end of the day, you have one-dimensional differential. It's just one differential equation. So, you know, it's on the line, there are the three steady states, and then you're moving one way or another.
Yeah.
And then this is the 3 points are determined by some curve. Q shifts the curve. We immediately can see which way you're going after the shock.
Absolutely. I agree with that. We should have a version of that. I just jumped ahead here because I wanted to show the uniqueness of, like, you know, high Q, low Q. I'm really just, like, you know, doing like many shifts as a function of many values of Q.
But also, if you do it that way, it becomes immediately clear that the equilibrium is unique, even though steady states.
Agreed. I agree. Yeah.
Good.
Yeah. We should have that. Yes, absolutely. Okay. So I'm going to go through this very fast. Now imagine, so third example, we're going to kind of do the opposite. Suppose you don't have endogenous frontier choice. And in fact, the only input that you use to come up with new ideas, this is extreme, but is this technology. So the price, the marginal cost of coming up with an idea is Q. Okay. Everything else stays the same. Still, there are no managers in this model. Okay, but only endogenous frontier. Now with an endogenous frontier, if you're at F equals F bar, you're hitting the boundary, then it's exogenous learning as before. So now, or like the second example, suppose you are not at the boundary and there's an interior solution. Well, what determines the decision of how many tasks you want to create? Well, there's a marginal revenue to creating a new task and there's a marginal cost. The marginal cost is Q divided by the productivity of, like, your input in producing that. So we call that tau bar. So Q over tau bar is the marginal cost of frontier. The marginal benefit of the frontier is the profit that you get by producing that task with workers, okay, in the interior when you have interior automation. So again, what is that profit with this particular technology that we had for production of tasks? Just write it in terms of the price of that task. It's going to be proportional to 1 over eta times a decreasing function of the wage. Okay? The key observation here is that in this example, the wage is fully determined by Q through the frontier and has nothing to do with automation. Automation is going to be completely passive. So in particular, when Q falls, wages are actually going to go up because lower Q, more productivity of this technology is going to imply that you come up with so many new ideas that you need workers to come in and produce those new tasks, and that's going to put upward pressure on wages. So that's key. All right. So then same plot as before. Now a decline in Q shifts the demand curve down because wages go in the opposite direction. So the two equilibria get closer together. The picture completely flips. When Q is really high, you have coming up with new ideas is really expensive. So you're just like struggling with that. As Q starts falling, you create more and more ideas and you go to higher learning. So the prediction is completely opposite. And eventually, even the equilibrium, when Q falls enough, that's just going to facilitate so much new human capital growth. Again, what would the planner do? Essentially a similar policy, but the planner has, again, like is more eager to transition to the high learning equilibrium as Q falls. So full model, put two pictures together. For very high levels of Q, the second model dominates. For very low levels of Q, the third model, automation margin dominates. And the key that, so like you're kind of like putting these together. And again, remember that like the social planner's solution around here is basically very close to the equilibrium. The social planner's solution around here is very close to the equilibrium. So all the things that I did and all my sins in terms of externality just coming over here in this intermediate region of Q with a very similar policy, albeit the social planner would want a little bit more learning. So this whole pessimistic view that even if firms are not experiencing or internalizing their effect on the learning is only a problem when Q is in these intermediate values that we can automate but not much, and we can learn but not much. With that, I'm just going to put my conclusion slide up. So this is the social planner. You see it's similar policy, but a little bit less compressed. And I'm going to put my conclusion slide over here. I'm done, right? Okay, great. Thank you so much.
Okay, so we go for lunch and we'll be back in 1 hour.
So
Okay, so we're gonna move to our first paper of the afternoon. And Darren Fitzgerald is going to talk about tariff wars and net foreign assets. And Ina Simanovska is the discussant leader. So you go for 1 hour. Yeah, of course.
Okay, thank you. So this paper is joint with Mark and with Manuel, who is not here, and the usual disclaimer applies. So the question that sort of motivates our paper, I guess, there was a lot of tariff action last year, is, and people talked about tariffs in relation to trade balances and so on. Our question is, how can a country's net foreign debt be settled in the event of a tariff war? Can this happen without default? And if so, what is the role of international relative prices in the adjustment process? And what are the welfare implications of a tariff war that eliminates a country's net foreign debt? So we're going to do two things. Most of the time will be devoted to the first thing. We're going to show that the answer to this question depends on what is the gross portfolio that underlies a country's initial net foreign asset position. So it's not just about the net, it's about what is the portfolio of assets on both sides of the balance sheet, assets and liabilities, that gives rise to a net foreign debt under free trade. And in particular, we identified 3 cases. So the first case is something which I'm going to refer to as strictly positive claims. I will define what that is later. Yes, this is very sensitive. Strictly positive claims, where we show that for high enough tariffs, valuation effects may wipe out a country's net foreign debt. So a country that starts off as a net debtor, in the event of high enough tariffs on both debtor and creditor country, may wipe out that net debt in the event of a tariff war. In the second case, where the net debtor has only, there's net only positive claims, again, a case I'll get into what that is, we find that a country's net debt is insensitive to tariffs. And then in the third case, which we call negative claims, there's potential for immiserizing tariffs. So the creditor may potentially immiserize the debtor by levying tariffs. And there's also the potential for multiple equilibria. So that's the first thing that we do. The second thing that we do is we quantify the effects of a tariff war that falls short of autarky. So, the first set of results, we're going to have some pretty stark results in terms of tariff wars that lead, what is the case where the tariff wars lead to autarky. But the quantitative part of the paper is to look at what happens in a tariff war that falls short of autarky, where we're going to fix ex-ante net debt at free trade prices and look at what happens when that ex-ante net debt is the outcome of different gross portfolios. Okay, so to sort of provide a little motivation for why the different cases that we're going to be thinking about in terms of portfolios, I have 2 sets of facts to show. So first of all, this is the US international financial position between, its evolution between 1970 and 2023, where on the x-axis I have time, and on the y-axis share of GDP, where assets as a share of GDP, liabilities as a share of GDP, and net foreign assets as a share of GDP are plotted. So you can see here that the US has been a net debtor since the 1980s, but that net debt position is the outcome of a gross position which has expanded over time. So it started off much smaller in the 1970s, and since 2000 has really expanded. Second set of motivating facts, I'm just going to frame this by looking at the US international balance sheet in 2023. So we have assets as a share of GDP, liabilities as a share of GDP, and the balance for different components. So I pull together equity and FDI, US dollar debt, non-US dollar debt, where you can, the US can be both on both sides of those. The US can have sort of lend to foreigners in terms of dollars, but can also, foreigners can purchase US treasuries or other US debt securities. And similarly, there may be both debt and liabilities in terms of non-US dollars. And then the other category is derivatives. So since you'll be looking at like the tariff war, right, retaliation. So I had in mind kind of US China, that's what you have modeled here. So do you have a sense of what the equity and FDI allocations are across different countries? So I haven't looked into that, so I don't know. So if you look, like, what's kind of interesting about it is that, so we are holding, it's true that we have a lot of equity and FDI, but the majority of that is Europe. So it's not necessarily true that we're holding a lot in China. We're holding a lot in the Cayman Islands, right? And a lot of that could be Shell, stuff from China. I think like majority of companies would say that, but like, I would say kind of like have like a net position with China when it comes to our claims and their liability holdings, and then whatever is positive that we have is really with respect to Europe. Okay, so it is definitely something interesting to think about. This paper, we're just going to think about a two-country world. So I'm going to be dividing into the US and the rest of the world, but I agree that thinking about multiple countries would be interesting. But I have nothing to say about that.
We're going to be, what asset we're going to be denominating what currency or whatever we're going to be denominating, or what good we're going to be denominating the assets and liabilities in, and whether you're holding like Chinese equity or European equity actually matters for the adjustment of the real exchange rate.
No, I agree that it could matter, but so far it's two countries. I don't have anything to say about that. Okay, so here, first fact, the gross position is bigger than the net position. So you can see, assets are 120% of GDP, liabilities are 196% of GDP in 2023. That is true for advanced economies, somewhat less so for emerging markets, that the gross positions are somewhat smaller relative to the net position. The second fact here, equity and FDI account for the majority of the gross position. That's true for the US, that's true for the world as a whole. For some countries, that is less true. And then the third fact, debt may be issued in the lender's currency. So here on the US balance sheet, you can see that because US has dollar-denominated debt assets. So this 26% of GDP, those are liabilities of the rest of the world in terms of dollars. Okay, so that's going to be something that is potentially going to be important. Okay, so that's it as regards motivation. Now I'm going to jump straight into the model. Okay, so I'm going to show you the simplest possible environment to develop the results. We have a bunch of different extensions and generalizations in the paper, but I think it's more useful to get the intuition in the simplest possible case rather than loading things up with bells and whistles to start. So there are going to be two countries. So it's two countries, home and foreign, foreign indexed by a star, which are going to be endowed with two goods, good A and good B. And we're going to assume imperfect specialization. So each country has an endowment of each good. And we're going to normalize by saying that home is relatively abundant in A. So A is the comparative advantage good of home, B is the comparative advantage good of foreign. So that's just a labeling thing, nothing interesting there. Again, to keep things simple, we're going to assume that there are no trade costs. So, our resource constraints are going to look like this here. In the paper we develop, or in the appendix, we develop the case of trade costs, and things go through. We're going to make the assumption of identical homothetic preferences. That's going to make it straightforward to sort of illustrate and do proofs. Some of this can be relaxed, but what goes on with preferences is important for certain properties of what we show, and I'll try to remember to flag that where it shows up. So identical homothetic preferences, the ratio of marginal utilities evaluated at the ratio of consumption of the two goods is going to pin down relative prices within each country. And if I give each country the same ratio of consumption of the two goods, I'm going to get back the same relative prices. The level of overall level of consumption doesn't matter. That's the homotheticity. Okay, so far, so straightforward. Now, things, although we try to keep it as simple as possible, start to become something that may take a little bit of time to get your head around. So we're going to have these countries coming in to the single period with ex ante claims on each other. And there are going to be 4 types of assets in this world. So little AA is going to be a home asset denominated in A, indexed to foreign prices. So if little AA is positive, that means that home has a claim to some units of good A indexed to prices in the foreign country. Similarly, little AB is a home asset denominated in B, indexed to foreign prices. So it's a claim to units of good B, which is tied to prices in the foreign country. The starred assets, the A star A and the A star B, are going to be claims to units of good A and units of good B, but indexed to prices in the home country. And all of these assets could be either positive or negative. So if little AA is positive, that's a claim for to units of A on the part of the home country indexed to foreign prices. But if that's negative, it means that the home country owes units of good A indexed to foreign prices. And given these 4 different assets, we can, map them into more familiar types of assets. So, for example, foreign equity or FDI, so a claim gamma to a share of the foreign output is equivalent to setting little AA equal to gamma Y star A and little AB equal to gamma Y star B.
Foreign asset means it's paid in the foreign country, or what does foreign asset mean?
So if little A star A is positive, then it's an asset of the foreign country. And if it's negative, it's a liability of the foreign country. Yes, so it's what are the prices that it's going to pay off in. It may be clearer when I write down the budget constraints, but think about the following. So you're a country, you have an A tree and a B tree. I'm a country and I have an A tree and a B tree. And my payment to you is that index. I owe you a certain amount of good A. Is that in terms of, there's a P going to have to be multiplying the quantity. Is that a price in your country or is that a price in my country? Because once we introduce tariffs, those prices are not going to be the same. Okay. So that's for the equity. A home bond. Let's say that the consumption basket in home has weight delta on the A good and weight 1 minus delta on the B good, then A star units of a home bond would be given by little A star A is equal to delta A star and little A star B is equal to 1 minus delta A star. Okay, so these assets map into assets that are more familiar to us, but it's just going to be, I think, easier to see things and get you intuition in terms of these more simple assets. Now, in terms of the talk, I'm going to make it even simpler. and focus on what we're going to refer to as simple claims. So claims on comparative advantage goods. So I'm going to say, so these are going to be claims to units of good A or claims to units of good B. So these are, they're going to, sorry? Sorry, I don't understand.
A star without the subscript, that was the boss.
Oh, sorry, that's just the unit of the bond. So A star amount of this bond. Suppose if a bond pays off 1 unit of the consumption basket, then A star would be equal to 1. So 1 unit of the bond would be, yeah. Sorry. So we're going to focus on these simple claims. A is the home comparative advantage good, B is the foreign comparative advantage good. So we're going to just restrict, we're going to set little a equal to 0 and little a star b equal to 0. So AB is a claim to a unit of good B indexed to prices in the foreign country, and a little a star A is a claim to units of good A indexed to prices in the home country. So these are the assets that are going to be the components of the portfolio of these countries coming into the period. Okay, so that's kind of the environment. Now I'm going to talk about the free trade equilibrium and then get to talk about what happens with tariffs. So with a whole bunch of different goods floating around, it's just going to be convenient to make dollars the numeraire. So I'm going to write all prices in terms of dollars and then sometimes use some relative prices. But, you know, when they're just the P's are going to be in dollar terms, I'm going to have rows for relative prices. So what's the equilibrium in this environment with free trade? It's going to be a vector of consumption of each of the 2 goods in each of the 2 countries and a vector of prices in terms of dollars, such that households optimize subject to their budget constraints, prices satisfy goods market arbitrage, and the aggregate resource constraints are satisfied. So here, kind of the only interesting thing in some sense about this is, you know, how these budget constraints are written down. So let's focus on the home budget constraint. So we've got the price times consumption of good A. That's the home price times consumption of good A. The home price of good B times consumption of good B. That has to be less than or equal to the value of the endowment evaluated at home's prices. And then home owes A star A to foreign. That's an asset of foreign and a liability of home, if this is positive. Index pays off in home prices, okay? And then this PB star AB, that's home has this claim to a good B indexed to prices in the foreign country. So the thing to note here is that these foreign prices are going to be showing up in the home budget constraint, and the home prices are going to be showing up in the foreign budget constraint, which, you know, when we have prices satisfying goods market arbitrage and we can write everything in terms of a free trade relative price, which would be equal to the ratio of marginal utilities of the agent which consumes the world endowment, given that we have identical homothetic preferences, we can rewrite like this, and we don't have any funny stuff showing up in these budget constraints. But just keep that in mind that when we have tariffs, we're going to have to carry those different prices around with us. So here we can rewrite these 2 budget constraints in terms of the free trade relative prices, and think about this as, you know, this is the financial position of home in terms of good A and the financial position of home in terms of good B. Those are given by this YA minus little a star and YB plus AB, and conversely for the foreign country, okay? So the equilibrium is that households optimizing subject to the budget constraints, where the budget constraints, what shows up in the budget constraint is the financial position and not the endowment. Prices are going to satisfy goods market arbitrage, and then these resource constraints are satisfied. So we're going to make one substantive assumption about the free trade equilibrium. The first is, in some sense, a normalization. We're going to assume that there's a net debtor and a net creditor, and we're going to make home be the net debtor. So the value of home's consumption evaluated at free trade relative prices is going to be less than the value of its endowment. So it comes in, it's a debtor, it has to repay its debt. So the value of its consumption is going to be less than the value of its endowment, or, you know, making use of the budget constraints, the value of its assets in country B is less than the value of the foreign's claims to good A in the home country. Okay. The substantive part of this assumption is that there is two-way trade in this free trade equilibrium, so that the home country is not so indebted that it ends up exporting both goods. Okay, so home is going to be exporting its comparative advantage good and importing its comparative disadvantage good. So some people like the Edgeworth box, some people don't like the Edgeworth box. This paper has a lot of Edgeworth boxes. So on the origin here, we have, this is from the perspective of home. In the top right corner, we have from the perspective of foreign. This is going to be good A on the x-axis and good B on the y-axis, where the distance between here and here is the sum of home's endowment and foreign's endowment of good A. Because we have identical homothetic preferences, the contract curve lies on the diagonal. This is the endowment point. I've drawn here free trade relative prices passing through the endowment point. Because preferences are homothetic, the free trade budget line for home it doesn't pass through Y because it's a net debtor, but it has the same slope because preferences are homothetic, and it passes through the home's financial position. But, you know, key thing to point out here, and this is really what the paper is all about, is that, you know, this free trade budget line, which then gives rise to our free trade equilibrium consumption point, you know, there are many different financial positions, many different underlying portfolios, which can give rise to the same net debt under free trade relative prices. So this is home's net debt. This horizontal difference here is home's net foreign debt in terms of good A. If I were to extend these lines down to intersect with this axis here, I could get home's net foreign debt in terms of good B. But, you know, again, there are many different financial positions which can give rise to this same net debt under free trade relative prices. It turns out that what is the outcome under a tariff war is going to depend on whether that financial position is something that looks like this, whether it's something that looks like this, or whether it's something that looks like this. So what is the gross portfolio that gives rise to this net debt?
Yeah, I just want to clarify. So why did you choose the model with no home bias? Like without tariffs, yield exchange rate is always one. So the only reason for yield exchange rate to move is the tariff, right?
Yes. So that's just for simplicity. So I think so, yes. We did the case with trade costs. So
yeah, trade costs is like the
yeah,
really
yeah. So we have some results, more general results with weaker restrictions on preferences. It's going to be the uniqueness of equilibrium is the thing where pinning down what the preferences look like is important, but I think that the home bias is not going to be a problem there.
Can you explain like the degree of freedom here with respect to the portfolio? So in general, if you have like exact spanning here, so with A, with B, like two payout vectors. So there should be a unique portfolio that pins down the so there should be a unique decentralizing portfolio.
So here there's no uncertainty. We come into a period. We have endowments of A, we have endowments of B, those are fixed. What's happening is these guys are coming in with some portfolio. What generates that portfolio is not what we're not getting into. This is in some sense the second stage. Given a portfolio, what is the impact of tariffs? That's the question that we're asking. And so, you know, this portfolio here, this financial position here is one where home has sold some portion of its A tree to foreigners and has purchased some portion of the B tree from foreigners. That's one way. It's, you know, in some sense sold more ex ante than it owes more at free trade relative prices than it owns of the foreigners. But, you know, equally it could have come in and have, you know, a different financial position, giving rise to the same net debt, where it had it has sold some portion, the foreigners own some portion of the A tree, but it doesn't own anything of the B tree. Or you could have this case here, where a home has sold some of the A tree, but also owes in terms of the B tree. It has this AB, A star, AB is negative. So it could have a liability in terms of good B indexed to the foreign prices.
Where risk is exactly zero. Otherwise, like normally you would find one.
Well, so the way, I mean, we're not saying anything about the optimality of these portfolios. In order to solve what would be the optimal portfolio, you'd need to solve this second stage, which is what we're doing. So we're looking at the second stage, conditional on a given portfolio, what is a tariff war going to do? We're not looking at how does that determine ex ante how I would choose my portfolio. You come into the world, you inherit a portfolio. There are different portfolios you could have. What do the equilibria look like in a tariff war? That's what we're doing.
Relative wealth, you're saying different configurations of assets that normally would be loading on the A and B shocks can decentralize this relative wealth. And now the only shock that you're allowing is this tariff shock.
Yes, yes, that's what we're doing.
Well, normally there'd be a huge cost if I decided I'm only going to hold my own equity. Right? That would come from stochastics of the model.
That's an example, the one per in the world, right?
Yeah.
Then there are many portfolios that do the same well.
Agreed.
That's all we're saying.
Okay. Okay, so that's what the free trade equilibrium looks like. Now let's talk about what happens when we introduce tariffs. So we're going to suppose that there are potentially non-negative tariffs on imports. So we're going to impose that non-negativity on these tariffs. So tau is a tariff that the home country can charge on imports of either good A or good B. And tau star is the tariff that the foreign country charges on imports of either good A or good B. And in any tariff equilibrium, household optimality implies that the relative prices, here this PB relative to PA, and this P star B relative to P star A, are given by the ratios ratios of margin utility of consumption of goods B to A in each of those two different countries. Goods market arbitrage is going to imply that the price of good A in the home country relative to the price of good A in the foreign country is going to be different depending on what the equilibrium pattern of trade is. So if home is consuming greater than its endowment of good A, so it is importing good A, then this relative price is going to be given by 1 plus tau. If foreign, on the other hand, is importing good A and home is exporting good A, then this relative price is going to be given by 1 over the gross tariff in the foreign country. And if these countries are consuming their endowments, then the relative price has to lie in the interval between these two 1 plus tau and 1 over 1 plus tau star. And then similarly for the relative price for good B in this case. Okay, the other things that have to be satisfied in an equilibrium with tariffs. First of all, we have household budget constraints where, you know, these budget constraints are the same as the first budget constraint that I wrote down under free trade, except that now we have this tariff revenue showing up. And now it's important that I specified that we had this PA and PB star, where the prices, the home price and the foreign price showing up in this budget constraint, because those two prices are not going to be the same. The government budget constraints, they're just going to be rebating whatever tariff revenue they get, and then resource constraints are going to be the same as under free trade. Okay, so yes.
Trying to understand what's going on here. I actually worked out the model with two goods, but the Armington assumption, which it was just like a natural starting point for me, which may be worthwhile to sort of lay out quickly so that people understand where things are coming from. But then when I was thinking through that model and what you have here, and maybe I'm wrong here, but don't you, this model would predict that you have a good specific optimal tariff, isn't that right?
So we're not thinking about optimal tariffs, we're just.
No, I understand, but it would, no, in which case I'm just wondering, why are you going through the complexity of the two goods in the way that you have done it, but then you have a tariff that's the same for everybody?
Okay,
When
so
that would not be the tariff that the planner would pick.
okay, so here, let me just say that, you know, this Y here and the Armington, that would be the corner of the box. Okay, so one thing that was helpful to us about thinking about when we're not in the corner of the box, it's sort of, we realized that yes, there's this entire space down here, which you still have access to for potential financial positions in an Armington world, but maybe you're not inclined to think outside the box. So this helped us to think outside the box. Basically what this, having these two goods, we're going to have prices are going to be well defined in autarky in a way that's going to mean that there's going to be a unique equilibrium for high enough tariffs. So that's sort of key. We'd have to make some other assumptions in order to, on preferences, in order to generate that without that. But sort of, in some sense, the main thrust is going to go through with an Armington world. Okay, so now we get to the sort of the heart of the paper, which is the three potential cases for ex-ante portfolios and what happens then. So remember, home is a net debtor under free trade. So under free trade relative prices, this value of home's claims on foreign less the value of foreign's claims on home is less than zero. So home is a net debtor. Now, what happens to net debt in a tariff war where, you know, now we have, this is the value of foreign's claims, home's claims to foreign and foreign's claims to home. You know, you can see that these PB star and this PA are showing up here in terms of this net debt. So the key thing is going to be what happens to this key sort of shadow terms of trade or key relative price in a tariff war. What that does to potentially revalue my claims to you versus your claims to me is going to be key to what happens to net debt. And there we're going to identify three different cases.
So should I be involved with concerns? Maybe substitution for past.
No, so here the competitive equilibrium within each country is Pareto efficient. There's no second best arguments. It's just a really simple endowment world, no heterogeneity, nothing. So there's the only reason to have tariffs, and again, we don't get into this, we're not going to be doing optimal policy, is potential terms of trade effects. But you know, we're not getting into that, but everything is optimal here. Everything in the competitive equilibrium without the tariffs or in autarky is optimal. if I were to summarize the spirit of the exercise, is so this is just an endowment world. There's one representative consumer in home. They've got some endowments. There's no problems to be solved in autarky. It's just the guy so we do have some extensions to certain restricted production economies in the appendix. Those are all going to be, again, efficient there's not going to be any inefficiencies in autarky.
We're very conscious of not assuming that we're comfortable with the we just wanted to do the comparative static, that given these growth positions, what happens if you were to try to limit the amount of trade that takes place in the world? Yeah. That's kind of our question. It's not what should have been enough. Because in this, the global efficient outcome is free trade. I don't know if you're going to do the welfare.
I'm gonna say something about welfare. Yeah.
We can see what the trade-offs are if you wanted to think up. You're just doing stuff.
Mark, oh, sorry, go ahead. So what you just said, and I appreciate that, and I imagine you have in mind Liberation Day here, correct? Is that what you're
Liberation Day.
trying to model Liberation Day? Is that what you're trying to model? But
we weren't actually modeling it per se.
no, but there is a big difference in how you treat the tariffs. So I think of Liberation Day as something that was very temporary, kind of happened. Given that you guys are looking at, long-term allocations, like, let's take that off the table, because that's just not the relevant, that's not the relevant set of tariffs that we're looking at. And really, the tariffs that are floating around are tariffs that are sector-specific, that are very particularly designed to target sectors where we have certain comparative advantages versus not, for geopolitical reasons, et cetera. And then this assumption of the uniform tariff doesn't apply anymore. So even if you don't want to think about what tariffs are optimal, it's not necessarily true that the same Tau is going to be everywhere.
let me just-
that relative Taus are going to change your bands a lot.
Let me just say that kind of, zooming out, what's motivating us is how to think about tariffs in a world where trade may be unbalanced, which means that you need to think about a country's asset position, net asset position. And what we're showing is that, no, you don't just need to think about its net asset position. You need to think about its gross asset position. And these are going to be three different potential cases for what might happen. Now, you might then want to zoom in again and get into some more detail about sector-specific stuff, but it is still going to be true that those three cases, you're going to have different impacts based on whether your portfolio looks like case 1, case 2, or case 3. And it is useful to characterize how, the set of outcomes that can occur looks different, which is something that I think is sort of the new part.
And some of us are saying, but going back to what Mark said, still you're going to have this, appreciationary force coming from terms of trade, right? That's because in autarky you have all that, and then you do tariffs, but then immediately the other country also put tariffs. So I am always under a trade war scenario. So both countries always put tariffs. So
well, we're going to show for what sets of tariffs, you can end up in this zeroing out the net debt position. So what kind of trade war would be necessary in order to zero out the net foreign asset position, and whether it is possible, and then what that implies for the appreciation versus depreciation.
And then the second step, okay,
then we'll show you what happens to the terms of trade. What has to happen to the terms of trade for the zeroing out. Okay, so we identify three cases. First of all, case of strictly positive claims, again, we're restricting to these assets denominated in terms of comparative advantage goods, which means that, I have a claim to some units of good B in foreign, and foreigners have a claim to units of good A in my home country. And that is the direction of claims. Those claims are positive. There's no liabilities in terms of a foreigner's comparative advantage good. In this case, we find that for high enough tariffs, autarky is the unique equilibrium of this model. And how does that happen? That happens because for this configuration of the portfolio, valuation effects for high enough tariffs can eliminate net debt. I'll tell you precisely what is the terms of trade that is required in order for that to happen. Second possibility for portfolios, given that we have these simple claims in comparative advantage goods. I'm a net debtor. I'm the home country. I'm a net debtor. Foreigners have a claim to good A in my country, but I don't have any claim to good B in the foreign country. In that case, we show that autarky is not an equilibrium. The home country, who is the net debtor, has to repay. Valuation effects cannot eliminate that debt. Okay, so it matters what the portfolio is. You could have the same initial at free trade prices net foreign asset position, net debt position, but if that's as a result of these positive claims, valuation effects can eliminate net debt. If they have this net only positive position, they can't. And then the third case is a case of negative claims, where you owe the net debtor owes in terms of the comparative advantage good of the foreign country. In that case, we show that foreign tariffs can potentially immiserize the home country, so the net debtor country. And in fact, going further, there's a potential for multiple equilibria if both sides of this are negative. So it really does matter what the portfolio looks like. I'll show you. Okay, so let me just, in terms of the Edgeworth box, show you what these regions look like. So we assumed that there was two-way trade in the free trade equilibrium, which means we're going to have to lie between this line and then the home was a net debtor, so we're lying to the left of this line. So to the right of this line and to the left of this line. So in this region here, region 1, which is above the heavy dotted line, that's the region of positive claims on both sides. Region 2, which is this sort of knife edge case of where foreigners have a claim to my comparative advantage good and I have no claim to their comparative advantage good. That's the net only claims. And then region 3, at least one of the countries has negative claims. If we have negative claims on both sides, we're going to be somewhere to the right of this vertical line here, as well as being below this horizontal line here. Okay. So those are the three different regions that we identify. So the first case, the case of strictly positive claims, what do we have here? We have a proposition which says that assuming that we had two-way trade in the free trade equilibrium and home was normalized to be the net debtor, and we have these strictly positive claims, there exist finite levels of tariffs such that for tau greater than tau lower bar for the home country and tau star greater than or equal to tau lower bar star for the foreign country, the autarky allocation is the unique equilibrium. And in this equilibrium, the terms of trade for the debtor country are worse than under free trade and are given by this ratio of the foreign claims to good A in the home country to home claims to good B in the foreign country. And the sort of the content of this proposition is that valuation effects in a tariff war can wipe out ex ante net debt when we had this sort of positive claims case. And the fact that the terms of trade looks like this requires the terms of trade to move against the net debtor. It requires a depreciation of the terms of trade. It's like, I own some of your tree, you own some of my tree. I need that the value of my claim to your tree goes up and the value of your claim to my tree goes down. That's a movement of the terms of trade against me. That is necessary in order to wipe out the ex ante net debt. So I'm just going to talk a little bit about the proof of the existence of this equilibrium, just because I think it gets some intuition, and then skip over the rest in order to talk about the other cases. Yes.
It's a stronger result that you're wiping out net debt. You're wiping out even the purchasing power of gross positions, right? Nobody can use their assets to buy anything. Water key is the only thing that's left. Fully purchasing power on.
So what we're saying is that for high enough tariffs, then so autarky is the only equilibrium. The net debt is wiped out. Yes. I mean, in some sense, I still have a claim to you and you still have a claim to me. It's just that the relative price of those claims moves to zero out the net claim.
This is then like, I'm saying it's like an embargo, a tariff, like.
No, this is, no, it's. No, both sides put tariffs. Yes, yes. Yes. Okay. Let me skip over the proof and get to the graphical illustration. Let me just talk here about what happens to international relative prices. Remember that home is a net debtor at the free trade relative price. I can rearrange this to get that to show that the sorry, this I skipped over the part where I show, maybe it's, I go back and do this. Okay, good. So let's do that. Okay, suppose that we're going to construct this equilibrium. Okay, so we're going to assume first of all that tariffs are such that we're in autarky. Okay, and then we're going to verify that those tariffs are consistent with goods market arbitrage. Okay, so that's how we're going to start. So we're going to suppose that tau and tau star are such that we're in autarky. If we're in autarky, then consumption is equal to endowment for each country and each good, and the tariff revenues are equal to zero. Okay, and then the autarky relative prices in the foreign are given by the ratio of marginal utility of consumption evaluated at the endowment, and similarly for the autarky prices in the home country. So now let's take a look at the home budget constraint. Remember, we don't have this tariff revenue showing up because there's no imports. We can rearrange by dividing across by PA. We can use the fact that the consumption is equal to the endowment point to zero out some terms. And rearranging that, we arrive at this here, and we can divide across and show that PB star divided by PA is equal to the ratio of the foreigner's claims to good A in home to the home claims to good B in foreign. We're going to call that rho hat. This is the key international relative price that zeroes out the net debt position. Okay, so there is only one, and we know that it's positive because these two, we've assumed that we're in this case where we have these positive claims. So this is a valid international relative price. Do these tariffs exist? To do that, we need to check goods market arbitrage. So we need to know, since these guys are not trading, that these relative prices lie in these lie within these region. We can rearrange here to get these relative price as a function of the autarky prices and this sort of shadow terms of trade, which is given by this ratio of the positions. And since this is a number and this is a number, by making tau star and tau big enough, we know that we can always find intervals such that these guys lie inside of the intervals. So for sufficiently high tariffs, we're going to satisfy goods market arbitrage. So the autarky equilibrium exists. Okay, so, okay. Right, exactly. Okay, so this gets to sort of, what the international relative price is this rho hat, which is given by this. And then because home is a net debtor, we know that this international relative price the price of good B relative to good A is higher than it is under free trade, which means that for zero debt, we need the value of home liabilities to fall relative to the value of the foreign liabilities. We need a home shattered terms of trade depreciation, and this is going to require foreign tariffs. So you need the foreigners to tariff you in order to zero out this net debt with these positive positions. It's not enough for you to put tariffs on them, they need to put tariffs on you.
This is the way I should have asked the question. Does there exist debtors which are smaller than the ones in proposition 1, where you wipe out net position so that trade is balanced, but still there is trade? Because I guess the interesting case is, I mean, if you go to autarky, there is no trade at all, right? But the interesting question is, can you wipe out the net?
Yes,
position so that-
under a certain condition. Okay.
And it's different from proposition 1. It's like
Is different from proposition 1. Okay, so let me just skip to that. Let's skip over the uniqueness, which there's not so much.
Same, you know, proposition 1, it's a different tariff that will give you trade with.
It depends on the portfolio relative to the autarky prices in home and the autarky prices in foreign. So let me just tell you about welfare, and then I will have a figure on that. So in this autarky here, you know, who gains, who loses when we move from free trade to autarky in this extreme tariff war? Well, we know that the autarky point was always within the budget set of foreign. So the fact that it didn't choose it means that it must be made worse off by this trade war. Whether the home country is made worse off or not depends on how indebted it originally was. So for a financial position that looks like this, you can see that the indifference curve that passes through the free trade point is above the endowment point, so it's made worse off. But if it were very indebted initially, then the reverse would be true. So it really does depend on how indebted the home country is, whether it gains or loses. But the creditor always loses from this tariff war. Then this case of whether we can have balanced trade with positive trade, in this simple model, it depends on whether the terms of trade that zeroes out the net foreign asset position lies between the autarky prices of the foreign country and the autarky prices of the home. If that's true, then yes, there's kind of a locus of tariffs, tau and tau star. So that kind of, in some sense, it's always knife edge, but you can get balanced trade with zeroing out with actual trade. Okay. So since I'm running out of time, let me move through the other cases quickly. So in the case of net only positive claims, we have this lemma. The content is that autarky is not an equilibrium when we're on this kind of horizontal line. Valuation effects don't reduce net debt. I think you get the intuition. We had this kind of, we don't have this valid relative price because one of those terms is a zero. And in this case, the debtor is always going to be worse off than in free trade. The equilibrium, looks like this here. And as you can see, since this point is a point that was achievable by the home country at free trade relative prices, and it didn't choose it, that it must be made worse off by this equilibrium. So this is for high enough home tariffs, this is the unique equilibrium. In the case of negative claims, so here, maybe let me just try to give you the intuition. It's like you owe the foreigners in terms of their comparative advantage good. They place a tariff on that good. That, in some sense, increases your repayment is indexed to prices in their country, and they are driving up those prices. So that means that you potentially need to pay sort of ship more and more of your comparative advantage good to them in order to repay what you owe them. Maybe I'll just sort of leave it at that for this case. But within the Edgeworth box that involves the financial position jumping in a way that will take a little bit too long to explain. And if we have bilateral negative claims, so that if I owe you in terms of your comparative advantage good and you owe me in terms of my comparative advantage good, we could have an equilibrium where I end up exporting, you put tariffs on me, I place tariffs on you, but for certain ranges of those tariffs, I end up exporting both goods to you, or you end up exporting both goods to me. Those are two potential equilibrium for a set of potential tariffs. Okay, I did everything within the Edgeworth box. What happens beyond the Edgeworth box? So we claim that these results broadly generalize. We have in the appendix the case of claims on comparative disadvantaged goods, so not restricting to these simple assets. We have the case of trade costs. We do this in a two-country Eaton-Quarter model with production. We do this for a case of an arbitrary number of goods. So there's kind of a range of different extensions. In the last minutes, let me just talk about the quantitative implementation, where we actually do an Armington setup, where we have a dynamic stochastic Armington model with trade costs and roundabout production. We assume that asset markets are complete and frictionless with respect to productivity shocks. And then we're going to calibrate to the two countries, the US and the rest of the world. And we're going to match 2023 US net foreign assets and net exports, okay? But then think about what happens not just in the sort of observed portfolio, the observed growth portfolio, but in alternative potential portfolios that could give rise to the same US net foreign asset position in 2023 at free trade relative prices. So we perform a trade war counterfactual where the idea is that this trade war is unexpected. There's just kind of some guy comes in and mashes a button and puts some tariffs in home. Yeah. Well, but there's a guy at home that's mashing a button and putting some tariffs on foreign, and there's a guy in foreign that's mashing a button and putting some tariffs on home. Contingent assets are going to pay off based on the productivity state, but they're not contingent on tariffs. And we look at four potential ex-ante portfolios. So the actual portfolio, which is mapped into data on the US position that I showed at the very beginning in terms of bond and equity. We have what we call a contract curve portfolio, which is the portfolio that would exactly deliver the consumption allocation in the free trade equilibrium. We have a no growth positions portfolio, which is net only in the US good. So the US owes foreigners because they own a chunk of the US good, or a net only position for the US where it owes in terms of the foreigners good. So kind of a debt trap situation. And this is what we find when we put, so this is the free trade equilibrium here, the 0.000 tariffs. And then we look at the case of symmetric 25% tariffs of the US on the rest of the world and the rest of the world on the US. So, here, these are the initial portfolios under free trade here. This is the sort of actual portfolio, which is the same numbers that I showed you at the very beginning. A net only portfolio that's only in the US good versus a net only portfolio that's in terms of the foreign good. And the key thing that I want you to sort of notice here is that on this actual portfolio, there are valuation effects that are relatively modest, okay? The valuation effects tend to reduce a lot more the US net debt when the portfolio had this positive claims property, but is much bigger. We have an insensitivity of net debt to the trade war when we have this net only claims index to the US good and to the foreign good. But the welfare ranking of all of these trade wars are bad for everybody, but the welfare ranking is very different in sort of these initial ex-ante portfolios. So the US loses a lot more from this trade war when it has this owes the foreigners in terms of their good, has this net only portfolio in terms of its own good than it does in this ex-ante contract curve portfolio. So the gross portfolio really matters. The sort of the valuation effects in our calibration are relatively modest at the actual portfolio, but there is an impact on the net debt. So to conclude, the impact of a trade war on net foreign assets and welfare depends on ex-ante gross portfolios. There are three potential cases to consider. This positive claims maybe is most relevant for advanced economy portfolios. The case of negative claims, you know, we know that emerging markets borrowing in they are more likely to borrow in US dollars than advanced foreign economies are, and so that this negative claims is possibly more relevant for emerging markets than it is for countries like the US.
You were able to generate an appreciation in some cases, no? A dollar appreciation.
So in this case, these are all depreciations.
But don't you have situations like parameters where you can generate an appreciation?
Well, so here, these are symmetric. I'm just feeding in
Yeah.
a symmetric trade war.
Mhm.
And in that case, it's giving you a US depreciation, so
you're
the
not able
valuation.
to get the appreciation.
Yeah, we should break for 15 minutes. All right. Ready?
Yes, sir.
All right, so Patrick will be next, public discussion.
People like to now. Let's get it. Right, but then you can also. Ready? Ready?
Yeah,
All right. Oh, I need a thingy. Ready? All right, this is joint with Rafael, a grad student. He's on the market next year. He's a good guy. Eugenia, TSC, and Ellen is right here. Fiscal and monetary unions. Did we change? Did we change?
No, it's changed. Again? There we go.
It's a laggy. Okay, so how should policy choices be delegated between central authorities and local authorities? That question has been around for a long time, but there's still no settled answer. A couple thousand years ago, this guy was asking Aristotle, we should know over which matters you should have local tribunals versus centralization. So it's a classic question. Sargent has a nice paper where he says the US started decentralized, small number of colonies. Eventually, they get more and more centralized, and the fiscal authority goes not to the colonies, but to the federal level. Argentina supposedly screwed up a lot of what they did, from having decentralized provinces doing goofy things with their debts, and it fed back to the center, and that caused a lot of inflation. Even in the case of the EU today, Tablini argues, what tasks should the EU have and which one should be left to the member states is one of the most pressing questions. So with that backdrop, we wanted to think about it. In the literature, there's two opposing views. There's this classic view that macro people like me knew much about, Oates. He has this Oates decentralization theorem, where he assumes that local governments know more about local taste and can better tailor fiscal policies. So local authorities are always better unless there's huge externalities. Centralization instead leads more to a one-size-fits-all. And what macro people like Mark and Chari and I worked on was monetary authority is such that the local people ignore the cost of inflation that by printing too much debt encourages, and therefore it is the fiscal externality. And that leads to endogenous fiscal externality, centralization, internalize it, and since there's no information, they always win. So there's these two polar views, always decentralized, always centralized. So we can investigate them in the monetary model without commitment, and we're gonna have an information benefit of decentralization and an externality benefit of centralization. We're gonna extend Mark and company's model. We're gonna have one central authority who has noisy information. They didn't have that. And under decentralization, there's a finite number of local authorities, and that's different, that have perfect information. And that's gonna set up a tension. Now, our whole view is in what I call the new view of EU after the failures of this pact. When Chari and I worked on it, and Mark earlier did, there was this view that a decentralized regime with limits on debt and deficits can credibly eliminate externalities. And that's in the Maastricht Treaty and Stability and Growth. They put in these hard limits. If you violate it, you get huge penalties. Not a single person got penalties. But France and Germany, the leaders blew right through them right away. And that sort of blew the whole idea. And then after that, Greece, Portugal, and Spain all blew through them. So the view is this is useless, it'll never work, give up on it, we're just not looking at anything like that. We're looking at a way more extreme view. We don't trust you, we're taking over. It's gonna be like taking over the state's debt. So the money, we're saying the money, we're saying what it's spent on. Explicitly centralizing, this is some decision is beneficial, we're gonna apply it. Draghi has a more recent report where he hints at this, he doesn't go as far as this, we're going to the extreme. The paper in a nutshell, we're gonna set it up so that both central and local fiscal authorities want to reduce their debt to lower inflation. And the trade-off is going to be the centralized authority is going to reduce it faster, but in the spirit of Oates, but at the cost of not tailoring the individual policies as well. And that's going to be a nagging cost whenever you centralize something. We're going to build a tractable dynamic model, by which I mean you can solve it in closed form, that characterize how debt and inflation dynamics vary across these regimes to assess how the optimal delegation changes as you change the number of countries. Because we're thinking as in Draghi's, it was sort of as the EU expands eastward and you go from a small cozy set of big countries to more and more countries, should you rethink how you're doing fiscal policy? Sargent alludes to this in his paper, Europe Then and Now, and he says maybe Europe should learn some of the lessons the US learned when they went to get bigger from small number of big colonies to a bunch of states. The main result is going to be centralization is going to be preferred if and only if the number of countries are sufficiently large. And the policy implications is that if the EU expands eastward, they should think more and more about centralization, as some of the recent work is arguing. And the desirability depends on characteristics of the new country or countries you add, their debt position, their population, and their dish utility, which are all going to influence the nature of fiscal externalities inside the regime. In terms of the literature, this is my literature slide. The classic Oates paper and the literature that followed had information in the background and commitment, and decentralization always won. In Mark et al.'s paper, and in the turn I did, it was externalities only, centralization always won. We want to do this box where there's a finite number of countries, so you're big in the union. And it's going to answer, and there's no commitment. It's going to depend on size. So that's what it's about. Now, the technical issue is almost all the machinery developed for these kind of things is for a continuum of country cases like Mark et al. Had. And we're going to debate. It's important that each country is going to see themselves as big within the union, which you never do in continuous time. We did not really solve any brand new math. We set it up so we sidestep it. So we have just enough strategic interaction to get our answer done without it blowing up. And I'll spend a little bit more time on techie stuff, especially in this audience, which will be the most teched up audience I ever give this talk to in terms of international. Otherwise, I have to spend 20 minutes on the world. Okay, so we have this. Yeah.
Can I ask you a question?
Is it anticipatory?
No, it's
Okay.
it's a question of what is the trade-off? I understand that.
You'll see.
No, I know what it is in the model. I want to see exactly what you said before. But what does it mean that they know better the preferences? Information travels fast.
Okay.
I'll make a phone call.
I'm going to talk about that. I'm going to talk about that in detail.
Okay.
I made a phone call to my lovely bride here about, I'm going to buy you a very expensive dress for Christmas, and that's going to be the main present, and I was out shopping. Not a freaking chance. Okay, that's my answer, but you'll see. It's been empirically documented. Okay, so here's the technology preferences and information. Production is simple. 1 unit of labor makes 1 unit output. Agents have preferences in each country over 2 kinds of goods. I'm going to call them private and public, but it's not particularly public. It could be apples and oranges, but I'll call it private and public. It's concave, a linear dish utility from working. That's going to make everything simple. This one assumption, and then this is what Mark et al. Did. We have linear costs of inflation. These thetas are IED shocks. we're gonna do the general case, we're gonna have gamma tilting you towards private goods. And this type is gonna switch high, low. Are you hungry for private goods? Not hungry, hungry, not hungry. And I'll get back to that later. The local fiscal authority perfectly observes theta. Central fiscal authority, once in a while, gets it gets a Poisson arrival, in which case they know exactly what it is. And in between messages, they're Bayesian update according to this prior. And this is for you. The friction in our model is on what can be transmitted, not on what's willing to disclose. And we have some hallowed people that we're following. Hayek, there was this debate about why centralization under like socialism, but it was really why is centralization never going to be as good? And he argues its inability to communicate economic information. That prevents, and they were all thinking in the background about socialism. Hurwitz wrote a whole bunch of papers before he did incentive-based ones, where agents can communicate in good faith, but the message spaces can't carry enough info. Mountain Rider, there's a whole literature in the 60s. Now, here's what I'll call strong empirical evidence. By Waldfogel, a colleague of mine, he estimates that holiday gift giving destroys 10% of the value of the gift when you give it to a partner, like a husband and wife or a long-term partner. And it's from an aunt, it's more like 1/3 of the value gets. In cash, they get ticked off. I mean, that's a different, anyway. So
Can you go back for a second, Patrick? Because there's two types of information friction in the literature. One is that, do I want consumption goods or public goods? The other, do I want goods now or do I want?
this, okay. Now, that's a very good point. In the baby model, which I'll spend most of my time in, it's going to be, do I want oranges or apples? Static. Then we extend it, and it's going to be, do I want to eat now or later? The extension makes everything much harder, but we get the same result. I'm going to do that in the last 15 minutes if I watch my time. Okay?
If it's apples and oranges, you can still impose a balanced budget rule.
Yeah. That's right. So the other one is the full power one. That's right. So countries, let me go to the model. In the last 15 minutes, I'll do the fancier one. See, this one I can all argue intuitively. The last one is sort of a bit heavier. Countries can borrow from foreigners, and they issue some non-defaultable debt. And I'm going to choose these bounds carefully in a minute. Risk-neutral foreign lenders buy their debt. This is exactly like Marx will work. And the real cost of fund is their discount factor rho. Here's a budget constraint of individual country. Here's your debt. It depends on how much you eat versus your income. This is like the primary deficit if these were government stuff. And this is the real interest rate payments on your debt, nominal minus this. And the C is a mixture of X and G. In equilibrium, the real rate is the opportunity cost, so the Fisher equation holds. Off equilibrium, there's going to be a timing consistency problem. Okay, like I said, I'm going to do this simple case where there's a separation between debt dynamics and taste. You can literally solve the debt dynamics and add on some taste stuff. Then I'll do this general one where you can't. And it's more tricky. CRA and that. So here's why the simple one is so simple. In both regimes, utility is separable between total spending and the taste. The margin utility doesn't depend on it. So you can solve a deterministic problem versus a stochastic one. Under decentralization, we're going to work with the indirect utility over total spending in each period, and I'll just call that consumption. So if I gave you C units of good, and you had this static problem, you would allocate it optimally, and your indirect utility would depend on C and the shop. In the log case, you get that this value is log of C plus this, and there's no theta in it. So it's as if I can solve this problem and then this problem. So the preference is once you substitute it, have two terms, what we call the fiscal value and the info value. Now this fiscal value is identical to what they did and to what Marketall did. We're going to make this general concave, even though it won't split like this, but it'll allude to what's happening in the general case.
So just going back to Mark's point,
Yeah.
it's tractable, but it also makes Stark. So under the log assumption, there is no conflict between Oates and Chariquijo because the central authority just has to specify aggregate spending, and then the domestic guys will correctly pick the split because there's no interaction
Yeah, I know
between.
that.
So I'm saying,
But there is a conflict because I'm taking the, okay, this is maybe unfair. I'm taking the extreme form. I don't trust you guys to do anything, even brush your own teeth. I'm taking over.
but they'll do it
and
correctly
it's all-
here.
What's
There's
that?
no, but they'll do it correctly here. There's no.
It's true. And so should the Maastricht Treaty work. I mean, we're taking an extreme view, which is, and then we'll do to the other view where you can't in a minute. That's just more complicated. When I flick to the other one, this margin utility will depend on theta. You'll get exactly the same results we get, except funkier equations, fancier theorems, lots of stochastic, Poincaré-Miranda, stuff I barely understand math-wise and stuff. And that we're gonna get to that. But this is, baby, you could teach this brand new first years. I'll come back, I promise you I'll come back to that. But it just, yeah. Everything I do is gonna come from, just so you know that, it's gonna come from that assumption, not from the thetas. It's gonna make, that's gonna make the debt dynamics simple, the linearity. Okay, so you can do it, you can solve these two. And there's two values that I'm gonna suppress this for a large part of time, deal with this. We're gonna do a U version of this, and it's gonna be two values, which is these information values. This integral is f of theta given phi. And if you have full information, this is gonna be better than if you have, full information is gonna be better than if you have some noisy signal that arrives at theta. So from here for next 20 minutes or so, I'm gonna, what time do I go to? 3:45? Yeah. Okay, good. Okay, for the next 35 minutes, I'm gonna be doing that case. So let me just set it up. And the interesting part here is, as opposed to what almost everyone else does, that we've done before too, is you can have big guys in a dynamic problem or interacting. So it's not gonna be a mean field game. Actually, in mean field games, there's no game. It's just sort of like monopolistic competition. And here there is.
In this version of the model, would it be optimal then to decentralize everything? The monetary authority and the fiscal authority to be local?
No, you would always, okay, that's a different question. Here, the all presumption is you're in a union.
So we're in a
Okay,
union. So that's
we
what we're
have,
saying.
I don't want to say optimal, so I should be careful. There's lots of stories and reasons why a monetary union where we all have the same currency is better than having Luxembourg doing its own thing, Spain doing its own thing, et cetera. We do not model any of those. So we take all those other benefits of being in union, acknowledge we're not modeling it, and we're holding that fix and asking one and only one question: should you decentralize or centralize? And in the background, we're assuming that those other effects are orthogonal. But we're not, certainly not, you do not want to use this to say, should you let the people enter? This is, if they enter, what fiscal regime should you choose? That's more like what yeah.
And I guess it's a related thing. Wouldn't you wanna compare the cost of information with the benefit of more efficient public good provision when you grow bigger? Like, isn't that?
That's why I shouldn't call it public good. It's just tailoring. That was not Oates' argument. It was just, so don't think of it as public good. Think of it as doing what you want to do with your money. We're not going to utilize the public good aspect of the G. It's going to be a country specific good. So it's like apples and oranges. It is not going to be number of tanks that Luxembourg contributes to fighting the Soviet Union and stuff.
But it just seems like the question of the optimal size of the union.
Yeah.
Is inherent.
I'm not doing the optimal size. I am not doing the optimal size.
Well,
one more time, I'm doing a very small question, and it's at the limit of my technical abilities. The very small question is, given a size, and given all the benefits, and maybe these benefits and others, for why you chose that side, holding that fix, do you want to do decentralized or centralized? Okay.
Benefits fixed, but the the single currency and all that shouldn't be part of the centralization scheme at all, but it just ignore that.
I'm presuming, one more time, sorry. I'm presuming, and it's, Mark, help me on this. I'm presuming you were in a union. There's no issues about going along, Greece, doing your own thing, changing your own budget. No issue. You're in a union. There's one price set by a common authority. No choices of ever rethinking it. That's another paper. That's another paper. You guys might have some papers. No, there's not. It's not. That's why I went back. Aristotle did not ask what would happen if Greece broke apart. It asked, we have Greece. We have these guys. We have some guys at the center doing stuff. We have guys in the local villages doing stuff. How do we want to set up the power? That's it. It's a narrow question. We saw to do. We saw to do. You look at how much counties spend, states can spend, and you look at that compared to the national, it's, what do I say? Drops of water in a bucket. So that's in the background. And we're also in the background that as US expanded, the US expanded, it went more centralized. And there's a whole bunch of reasons it expanded. You know, Jefferson wanted what the French had and stuff. That's got little to do with our question. And Napoleon sort of lost. He was losing. He sold off cheaply. We don't have any of that kind of stuff going on. No Napoleon or anything. All right. So under decentralization, the fiscal authority chooses its own rules, given the fiscal rules of others, and take it as given the monetary authority who's hanging over everybody. And it's the whole reason that there's any externality at all. If you broke it in this mechanical model, just like theirs, if you broke it into a bunch of small countries that all do as well as better than if in a union. But they wouldn't have to unmodel other things. Under centralization, the central authority chooses the rules for everybody. So here is the decentralized problem. There's this pi of b. This is the whole vector of b's, 1 to I. So the local fiscal authority chooses what they're doing. They take account that the monetary authority is going to use this rule. It's going to be Markov. They're going to get to choose what they want to do. And they're also going to take as given what everyone else in the union wants to do. Not because they directly care. They don't give a poop about all these other guys. It's that this B enters this B and affects the inflation that they face. So it's indirectly connected through inflation. And it's just like theirs too. It's just, we got big guys and they had small guys. And then the average welfare in the union, I'm always going to use equally weighted, population weighted. There's I countries, so they'll have size 1 over I. The centralized authority is going to choose this to maximize the union utility, taken as given the same pi function, and they're going to internalize everyone's budget. So they're connected in these models. The country's connected through one and one thing, this pi. The reason Spain impacts Germany or Greece impacts Germany is Greece overspends, Spain overspends, dumps a bunch of debt on the union, and it changes their incentives to inflate. That, by the way, is exactly the story in Argentina. You had all these provinces, and in Brazil, you had all these provinces who dumped their debt on the center, and the center ended up inflating up more of it away. And that's one of the stories for the high inflation episode.
Patrick,
others.
So one question I had was,
Yeah.
I mean, we chatted briefly about this, is what are you interpreting the central authority to be? Because you imagine in principle, they should have access to transfers between these individual constituent countries, which they don't here.
No, that's not quite true. We abstract from transfers, but as you'll see in a bit, I think I wrote, as you'll see in a bit, transfer is irrelevant to our.
No, because you have causal linearity, right? I'm saying in our model, since we don't want to get into that, we abstracted from it. That's important because one thing you do is you basically introduce another time inconsistency problem because of bailout issues and so on.
Yeah, you have some nice papers on that. Charlie and I worked on something like that in context.
I worked on that.
I said, you worked on that.
Oh, no.
He worked on that. He worked on that. None of these guys, he worked on that.
You got put out, didn't you?
Everyone who took Chari, et cetera, worked on that. But we ain't working on that in this paper. We're doing one thing, decentralization, centralization. What do you do about centralization of this data?
No, centralization.
Players.
This is it, no, no, wait, I'm gonna come, that's anticipatory. Here you get a straight maximization problem, so it's gonna be, that one's tricky, and I'll tell you what we do. So here's what the local, now I'm gonna jump right to dynamic programming.
Often, like, the political science, because there are cases where you raise resources centrally, and then you allocate them, based on some report or
Yeah,
the information that was sought, they're typically the one that exceed all the budget costs. Because you don't have, you raise taxes.
that's good. You should answer, Rishabh and someone else, because here, you don't get to raise, what? No, here, yeah, it's worse than that. I'm some central authority guy, I wear blue shirt. He's a local Spanish guy, he wears red. He's a local Belgian guy, he wears green. The blue shirts come into your country, and that's it. Stay at home, we're collecting all the taxes, we are collecting the taxes, we're spending all the money. We're not the red shirts guy. What color did Spain? Oh, Spain wore red. The red shirts guy, or et cetera. It's just, there's one authority, they come in, they raise all the taxes, they spend all the money. Ain't nobody getting involved. And it's an extreme version of the Maastricht. Every time you try to tell those guys, make an agreement, et cetera, et cetera. The decentralized decision-making in the EU can't even build head error. I mean, but it's in a fiscal externality.
You say the Maastricht, besides the way to have local guy making decision and having external support, because I would not mix it in. We agree. And then you say centralized, that's one guy, and one decentralized with no rules. But I understand. But then you try to say Maastricht as a way to go towards centralization.
No, I didn't say that. That was a boo-boo. I was saying, there was this view in the Maastricht Treaty that it would solve the fiscal externality. That's, if I said more than that, I repop. And it clearly did not. That's it. Okay, let me keep going. So there it is. These are two centralized and decentralized authorities. So it's your own utility, and this is how debt evolves for everybody, debt evolves for you, and debt evolves for everyone else. The monetary authority takes its given as debt, and they take the rules that a fiscal authority is given, and they maximize this utility. And there's a pie here and a pie here. So if you look at it, this is quasi-linear. This is like Marx too. It's linear and pi here, linear and pi here. So it's always going to be bang, bang, either do zero or do the whole thing. What's the tension? Since the monetary authority lacks commitment, the temptation to inflate reduces the real value of the debt. Cost of inflating is a direct utility. Both the cost and temptation are linear, so you go bang, bang. Now, we're just going to do first order conditions, but in the paper, whenever you have one of these things being non-differentiable, you can't do, it's not even defined what the problem is, and they do this thing called viscosity solutions. They just handle theirs one way, ours is different, we have to handle it another way. That took a lot of time, but it's, every solution I'll say is viscosity, but I'm just taking first order conditions, and that's in the appendix.
Can you just go back to the individual fiscal authorities?
Yeah.
I see. So the difference with ours is that they internalize their effect on pi.
When they take this derivative, it's this derivative, and their pi's. You'll see it. I'm going to go into this in more detail. You'll see all the derivatives in a minute. There's the monetary authority. There's HAB. Okay. Now I got behind. There's 345, right?
Yes.
Okay. One cute thing that confused the daylights out of me when I read your paper, because I worked with chart for years, and for us, commitment was always timing. Some private guys go first and the government goes second. And the private guys make a decision, then it's like, then the government implicitly screws them ex post because it's a state variable. And when you had commitment, no commitment, and it was in a continuous time, everyone's moving instantly. There's no time difference between when I move and what you do.
And all I'll say briefly, for me to understand this, and I'm sort of slow-witted, I read your thing. If you go to a discrete time model and you literally put the timing in, fiscal authority issues these short period bonds of length delta, and it's delta, 2 delta, 3 delta, and they have this real payoff, nominal payoff. And at time t plus delta, delta units later, the monetary authority sets the p by choosing this pi. Then you have this standard time and consistency problem, Charlie and I know in discrete time, is that in equilibrium, you have the Fisher equation holding, because you can't fool the people in equilibrium. But when the monetary authority moves, this has already been set, so they can jack up. This, they set it on this, sorry. You can jack this up, and you think you can devalue the debt. But in equilibrium, you're frustrated. And what confused us was, that sounds good. The monetary authority, but only needs to commit delta units. When delta is 0, you don't need to commit at all. You'll move in simultaneously. So that, I was confused about that for ages. And then, if you take the limit, you'll get the right answer. If you try to do it in continuous time to start with, you can say gibberish. Okay, that's all. Now, I'm going to do this in pieces. It turns out you can do it this way. You characterize its zero inflation set when no one wants to inflate. And you're going to build the Markov equilibrium out from that set. It's like the anchoring set that everyone wants to hit. And you turn everyone else's problem into like, it's not stopping time, it's like a stopping surface, because you want to go from high inflation to the edge in a no inflation set. And then I'll do that. But I'll do this first.
Mark means only your vector piece matters.
Yes.
Usually that's enough. Non-Markov things.
I'm not doing that. I'm telling you how I'm solving for the Markov type equilibrium we're looking at. I'm just, watch, you'll see. I'm not doing anything special. There's a vector of B's. You can do stuff based on that vector of B's, and we have Tayshock's later, you can do it based on that. So it's current payoff relevant East stuff. Okay, I'm gonna do it in words. Just suppose for a second, there's no inflation. You know there's no inflation. What are you gonna do? We have a model where curve utility in C, and there's interest rate equals a discount rate. So in discrete time, it's beta times 1 plus R equals 1 type analog. You sit still. You want to just sit still. So in here, you sit still. Your debt doesn't go up or down. You have to pay off the current interest on your debt. So you work. This is the statically optimal amount to eat. So what you do is you set the marginal utility of consumption versus leisure, or UL over UC, to the marginal rate of transformation, which is 1. So you set U prime of C star to be 1, and that's that. So you eat the statically optimal C, and you just work just enough to pay off your debt in the C. And that's where it's defined. And the value functions, then you know what they are. You're going to sit there forever. So it's just the discounted value of this divided by rho minus your debt. And it's always going to have this term, which is always just because you got to pay off your debt. All right. But now, I'm going to skip that. JHJB at the monetary authority does that. They take this value, and the A in general, if you take the derivatives, you're valuing the shadow value of decrease in debt from the inflation, because of this term times this term over the whole sum, versus the cost to everybody. And you get this, how costly. What is the value of decreasing debt a little bit? This is negative, more debt's bad. This is shadow value of increasing countryized debt a little bit times how much debt, that's the total value. But if you're in the zero inflation set, we know it's linear in B. So this is just 1 over I. So it's just 1. Where do I say it? Here, you just plug it in. You plug in that this is just, because it's linear, just 1, and then you get that's it. If mean debt in the union is less than the cost, you stop. If mean debt is lower than the cost, you stop. If mean debt is higher than the cost, you keep inflating till it hits the edge. And so because of that, you can do this. In the zero inflation region, which in this thing is a line, it's just in this case, B1 plus B2 over 2 is less than this cost of inflation psi. It's just a line. Anywhere in this set, you can have zero inflation, people are just sticking where they are. Anywhere outside this set, that's what the interesting part is. I'm going to go through what happens. What happens if they start out here? If they start out here, they want to go to the edge and stick there. For example, like there. So they're in high inflation, debt's too high, monetary authority is inflating. Unless they do something, they're going to put up with that bad inflation forever. If they get to the edge, the monetary authorities' incentives will be, it ain't worth it for me to try to inflate away the debt. The debt isn't big enough, so the cost I'm inflicting on you isn't worth the debt reduction benefit I'm giving you, and they stop. This is like theirs too, except this is just like theirs too. They just didn't have the big guys for this deterministic part. But ours is a bit different in this. So when they do so, we're going to reduce, we have this fancy HDB-ish looking problem, but we're going to reduce it down by using simple logic to a real simple problem in the high inflation. We're going to reduce it down to you choose one number, C, I, for each country I. That's a constant. And you're going to do that CI from here to here on the decentralization. You're going to do a bunch of C's under centralization, but we reduce the whole thing down to that. In the fancier case, you can't, you got to do a bunch of junk. Okay, now, you want to fight, we call it fighting inflation, but it's really austerity. They're always going to set L to the max. They do a constant C less than the static one. We call that austerity, because you're suffering by eating less to run down your debt. Fiscal austerity program. And the key difference with what we're spending most of the time on, you do greater austerity under centralization than decentralization because of the fiscal externalities. And we're going to make enough assumptions so that comes out cleanly. So, yo. If you obvious that you go to zero, like
Not zero, not zero.
Sorry, didn't say. If the free rent problem is very large, why?
If what?
If there's a lot of countries, why?
We're gonna make an assumption. And the assumption is you're big enough. And you'll see. I'll go over how we prove it.
Then if I'm alone.
We're gonna make an assumption, but that is slightly anticipatory, is that you're big enough so that we know you want to do it. And I'll show you that. Whatever.
I mean, continue in case you don't do it.
That's what I mean. Yeah.
That was an argument.
In our country, under our assumption, there's a big enough number of countries, we call it I bar. If you're above that, none of this stuff works. Because you don't know they can't do it. In fact, we spent months, actually I talked to you and Manuel about it, we spent months trying to figure out some general, you wander outside, you wander into pure computer junk. There's no way you can solve that. We're going to make assumptions that each country is large so that they have enough internalization such that you'll see, and it'll come in one assumption in a sec. Here's the first assumption, that this is the highest debt you can ever have. This is you doing the statically optimal thing, and you're working as hard as you can. So it's the lazy thing, so to speak. You're lazing around doing your statically optimal. You're not suffering to get out of high inflation. You're working as hard as you can, but you got linear utility, and you're paying off your debt. You're just doing that. If you do that, the assumption is if you do that, then your debt will go down. So the lazy strategy might make your debt go down. So even at the stack runs down to debt. This is the one we're going to use in a minute. This is your big enough. So this is a strong assumption. Everyone else in the union is a bunch of losers who are doing B up a bar. They're inflating away, doing their own thing, and that's the worst your co-inhabitants of the union can be doing. Even if they're doing that, if you take the mean debt in the union, if you personally get down to the lowest level, then you will drag those losers across the finish line and make inflation stop. That's what that means. But you have to be big enough. Obviously, it won't work. Right? You have to be big enough. And so that means I can't be too big. Or else you would be peanuts, you couldn't do anything. Now, let me prove why. Let me do a simple thing. 323. Oh, oof.
I'll do this quick and then I'll do, it's kind of obvious. Take the lazy policy, I'll call it. Do the statically optimal thing, no suffering. Work L bar, oh no, first to this one. You're sitting there not running it down. That's what you're doing. That's it, stay still. Here's the one. You do the hypo bar until you reach the edge. That's how you know it's the time. Then you just do whatever you have to do to satisfy the budget. So you ran down the debt. So one guy front loaded the debt. I'll show you the picture. So just one more.
Point worth noticing here, which is if you look at assumption 2 and you think about what happens when I goes to infinity.
No, doesn't make sense.
No, because you have an assumption that says something like B upper bar has to be greater than psi for me to want to inflate, right?
Yes.
And this, you can see as you send to I to infinity, this is B lower bar smaller than psi. So they're in complete contradiction. So
yeah.
it's not some it's just
We put-
inconsistent with assumption 2, and this kind of goes back to. No. But if I goes to infinity, assumption 2 and.
We spent 6 months trying to do I equals infinity case. You wander into what we call the no man's land of figuring out, you can't figure out, I'll tell you about it later. We tried hard to solve that general case. Can't come close. We called up a bunch of math guys. They didn't know how to do it, so we didn't do it. We're doing this.
So we think don't even know what happens. You're like upset about this.
No, you don't know. I don't know. We don't know. You can do some computer stuff. I don't want to talk about that. We do not know what happens. We tried hard. Fernando didn't know what happens. He's sort of a genius. We tried the computer. We tried other stuff. You can get some computer stuff. That's not what we're doing. Give me one more second. I'll do it. Let me just do this point, and then I gotta jump some stuff, I guess. Okay, so I'm doing something baby. Under this assumption, which is strong, that you're big. So we not only we can't have you small, we can't have you too small. You go away from this. See, they did a beautiful case, but there you have 0 power. 0. We did big. The intermediate case is the mess. The 0 power is simple. It doesn't matter a damn what you do, because you're atomless mass in mass in the debt. That's one case. You can do that case. They did a beautiful job. There's the big guys, big enough so you can run it down. That's what we're doing. It's a little messier, but it's kind of cute how you solve it. There's an intermediate case, no man's land. You guys might have more power. Take a crack. We couldn't do it. Okay? That is the super hard case. Anyway, let me go through it. So here it is. Do you want to do it? No, you don't want to do it, because if you were staying still, you do this L, the debt is stay here, and you put up with inflation forever. Or you could do the lazy way of getting rid of inflation, which could be really slow. Under that assumption, you do the statically optimal C, but you run debt down and you front load until it hits the edge. If it hits the edge, the inflation stops. But here and here, by the present value budget constraint, have to have the same present value of labor for the C, and therefore that's when strictly wins. So you always want to run it down. And if you don't know that, okay, then once you know you're going to run it down, this is the logic. That's just what I said. Once you know you're going to run it down, then you say, what kind of C do you use to run it down? You can vary your C running it down, but for any present value of C, you get to the same amount of debt you burned up. But if you jiggle the C around, it's concavity, you'd never do that. So in those 2 steps, you reduced it. I know you're going to do the maximal labor until you hit the edge. Then you take it easy and just work whatever day you have. Along the path, you always do one number, because if you jiggled it, it would be dominated by a constant. So now you reduced it. So now after all this stuff, you reduced it to this problem. And you can figure out, if everyone's doing that, how long it takes to hit the edge. So you get a high inflation region, and then after you hit the edge, you're in this beautiful no inflation region where there's no inflation. And the whole point is now, how do you choose your C? You can solve for how long it is based on your C. And you can then, and the whole point is going to be, in decentralization, you compare your suffering to your benefits. The centralized authority compares your suffering to the union-wide benefits, because when you make it a little bit earlier, when you make it 6 months earlier by your effort, Chari not only helps Chari, but Chari helps everyone else. And the central guys cares about that. So he asks Chari to, well, no, he tells Chari, no, he makes Chari go faster.
What are the expectations about or the behavior of other countries show up in those contribution levels?
Why did it here?
Yeah, in the contribution study, there's nothing about what other countries are doing.
It's through here.
The only way you care about other countries is how quickly we get to zero.
Yeah. You're only connected, okay, there's this lingering high inflation.
Yeah, but through that, were you making more assumptions about what others were doing?
I did. I said, even if these jerks are doing the worst possible beat, it's feasible for you to do this.
No, I think Guido's asking a different point, which is
What?
in the decentralized case,
Yeah.
you make sort of an assumption that you're considering Markovian outcomes where everyone's doing like a constant thing and this is the best response to that. But in principle, you can have other equilibria as well. There's an implicit equilibrium selection argument in the decentralized case. You guys chat about it in the paper, I think.
Okay,
I think that's what Guido's asking about.
okay. So what we do is, we do this, and it'll be more explicit later. What we do is we say, we know what decentralized is. There's no ifs, ands, or buts, there's no making up any assumptions. We look for the states, the same type states, the representation of the states in the decentralized that is in the centralized. And then with that, you can show there's unique symmetric decentralized that has the same states as the centralized. I'm going to prove a fancier version of that for the stochastic case. That jumps up to math 2 levels, which, how long? Now I gotta go. Sorry, no questions for a while. I can't, I'm like 1/3 of the way through.
Yeah, that's a new rule, I guess.
All right. So, what we do is we solve that problem. We solve that problem and you take account of what happened and you can write down the rules in closed form. And the thing you see is that the rules under decentralization have an I in them and in centralization they don't. And that is because your consumption is lower. So I'll show you this picture. When there's decentralized guys fight like crazy, they suffer. They're all suffering fast. And they get there really fast, so to speak, this green line. As you add 2 countries, they suffer less. As you add 10 countries, they suffer less. They barely do it. If you go, well, we can't make I too big, but if you could, you'd go up to that line. And that's what like the continuum case is. Now we're going to add back the info values. There's 2 info values. High info, that's like it arrives every second, every instant. So you get a lot of value of getting the info. Here you have very little. It's that those other terms in utility. And what you see is that the decentralized gets worse because of the fiscal externality. The centralized goes straight across. So there's a cutoff rule. Now, let me do some comparistatics. If you have a union with higher debt, everyone, in these I'm going to have the debt symmetric because when you start adding guys, I want you to add twins, not add in this first part. So if you have higher debt, the externality is worse and the cutoff shifts in. So if you had a high debt union, the externality is worse, so you'd centralize much quicker. Obviously, if you have a better info union, then there's less cost of doing it, you centralize quicker.
Realizing here that the reason you have this is because the costs don't scale with I, right?
That's right. We talked about that.
And that's somewhat of a strong assumption.
Yeah, but then we talk about it. If they go one way,
No,
it gets
maybe
even-
they want to know about it.
That's fair.
I think that's kind of important.
That's fair. Let me do this. All right. So what happens if you could add 1 country? Do you want to add it, but if you did add it, would you centralize? I'm going to make a normalization that, okay, so here you start with, say, I not countries. I'm going to assume if you had 1 more guy and they're the same size, you would have now switched to centralized. So if you would be here, and if you had 1 guy, you'd be here. Then we're going to say, suppose you had a really teeny person. Well, they wouldn't fight at all. they'd be doing almost nothing. In fact, up here, they'd be doing C star. They wouldn't suffer at all. And then as they get bigger, they're willing to suffer. If they get bigger than you are, bigger than the average guys, they suffer more because they internalize better. So their C goes free riding like maniacs to being tied. And then they get bigger, you free ride off the big guy because he's taking the power. And so you get this non-monotonicity that small guys don't do anything. Big guys, you want big guys because you can free ride off them. So you get a non-monotone thing for the size. Yeah, Montenegro is 0.5, Ukraine's 40, European average is 17, Ukraine sort of more out here. Montenegro is here. Now we're going to do another one, which is supposed to add a certain body of countries, a certain total population you're going to add. 10, okay. Yeah, a total population you're going to add. You could add a bunch of small guys who add up to 40 million. You could have one guy at 40 million. Do you care which one you add? You can guess already. If you add a bunch of small guys, these are a large number of new countries of the same size. They free ride like crazy. If you had a big guy or a small number of big guys, you get no free riding. So everything else equal, the more you add those small Eastern Europeans, you want to centralize. If you had some big people, the externality would be smaller. So we had this list. Here's these 4 countries with total population 10. You can add a bunch of small guys, they'll not internalize. Now you have 10 minutes, good. And this is what we've been working on for like 2 months straight. And this is the fancier case. So now you have these CRA preferences, symmetric in here and here, but this weight is bigger than 1. Everything else is the same. Poisson rate of arrival, Poisson rate of switching, and it's symmetric. Now, it doesn't break into that now. It no longer breaks into this, but you have these results. 0 inflation rates, inflation sets the same. You always want to run down the debt that comes from linear and labor. You still have a fiscal externality. You have a cutoff. You have all these results, but it's a trickier. Start with the same thing for the static level. What do you want to do statically? What's obvious that how much you eat depends on the shock. So you are going to have what Alessandro deals with all the time, which is if you get a high shock, you want to eat more, a low shock, you want to eat less. And okay, so we're going to have that. It's not going to, so blah, blah, blah. It's not additively separable. And we do a second case. Well, oh yeah, when you do centralization, you can do the same thing. It's as if you have a case that depends on the prior. And the prior is going to always be moving. Okay. So here's the decentralized problem. You get these normal terms, these debt terms, but now in the decentralized problem, you got to think through those other guys are switching. So this means what we started with. This means that guy and only that guy switch from whatever he was to the other one. If he was high, switch to low. If he's low, switch high. Then you sum over all those guys switching. Since it's Poisson in any interval, only one can happen, so you sum it up. That's the state switching term. You get the same first order conditions. Okay, that's it for those guys. In the centralized, this is kind of, yeah. Every time information arrives, the prior goes to either your high for sure, a 1, or your low for sure, a 0. In between, it's just you decay towards the mean. Hal's not here. Hal's paper with Down English had that long time ago in the trade. So the prior goes down like that, goes towards the mean. And here's the law according to which it drifts. This just is Bayesian updating for a continuous time switching process. So then you get another term in the centralized. You get each guy arrives and they switch, except now they switch the prior. The prior switches to either 1 or 0 for one of the guys every time you get an arrival. But in between, the beliefs just all drift towards the mean. And these guys depend on B, That's why before, this was just a big thing, they had all this moving, but it didn't depend on B. Now it's sort of a mess. Oh, harder. Blah, same first order conditions. So we do the monetary authority too. Okay, this is what I was confused about for a minute. In the zero inflation region, you get hungry sometimes or not hungry, not hungry, and you switch around. What I was confused about, what we were all confused about, we were thinking maybe the debt moves in that region. And then you might even want cross. You might do goofy stuff, sort of like Tim gambling for redemption. You might want to go into that one. And the answer is no. And it's sort of obvious. What happens is you always, all you do is, where did I write it? Yeah, every time you're hungry, you just work a little harder, exactly to offset it and keep your debt the same. So you don't do that. You stay still. Every time you get hungry for 5 more units, you work 5 more hours. It's all quasi-linearity that does that. In fact, the whole thing depends on it. We saw some non-quasi-linear on the computer. Sort of, okay. So the decentralized value, by the way, always looks like this piece. Yeah. And then this solves a two-dimensional coupled equation with this, which is all that I'm saying, is that what you do depends on how your tastes move. This is your taste in one state, it flips to the other state, you flip back, and you only care about yourself, so this is just you, and your consumption moves around, but your debt doesn't. Your labor just offsets that. Centralized value has the same form, a weighted average, and so I call this state reduction. You can show the state reduction is down to just the priors evenly, and then this solves some differential equation that has the priors moving, has the flipping, etc. So in the high inflation region, the value function that 2 pieces. One piece that only depends on mean debt and information, and another one that's additively separable. That it has this linear bit at the end is all because of the linear labor, as you guys pointed out. You take the infinite horizon budget constraint, you impose it and solve for labor. So now you save in for the present value labor. You go back to the decentralized problem, you plug it in, and you get rid of L, and you just get this discount. When you have this discount value of L, you have discount value of C and B. So that's why you always get a B. Just because you always got to pay off your initial debt, you will always pay off that initial debt by working harder, not by eating less. You always will do that if it's going to be feasible. So then you get this reduction, and you only need to record the mean debt as opposed to the vector. And then you get austerity, you can prove that, and you get these functions they solve. And we do this again. We have to make a selection about what kind of Markov equilibrium, and we use Markov equilibrium that look like the look like decentralized. You get austerity, you get these boundary conditions, and the thing, the cute thing, and I should ask people if they do this, the way we did it is we defined the best response operator. We plug in whatever those guys are doing. What is my best response to everyone else doing that? And then it's the properties of this operator that tell you everything that's going to happen. We never did anything like that, I don't think. It's that direct, well, indirectly you do. Indirectly you do, right. And so then we've just been doing that, and this is the stuff I barely understand. You can get existence of a fixed point and uniqueness of the fixed point by properties of that map. We check the properties, and these 2 theorems, Poincaré, Miranda, and Gale-Nakaido, show you get a unique, symmetric Markov equilibrium in the class of Markov equilibrium that has the same state space as the decentralized. Cool. Took a long time, but I don't know if anyone will care about that part. So here's the general symmetric case. As opposed to these straight lines, your C is jiggling, your C is jiggling with the types, so it's going up and down in, along the path. Under centralized, you suffer more, and welfare, you get all the same results. You can prove one of them, the other, some of those are simulation. So, this is the first model we know to capture both fiscal externalities and information advantages, even just fiscal externalities, in a finite country, and it's this word, finite country monetary union. It's not a meaningful game. As I said, none of these things are games, so I don't even know what to use that word. It's a new set of principles. It's not simply always centralized, like we used to say, or always decentralized. It's optimal if and only if the union's large. Threshold depends on the characteristics of the members, debt, population, quality, and it's also how these affect the incentive to free ride. What are the implications? As you expand eastward, all else equal, you should be more centralized. Adding high debt countries, more destabilizing for these, you shouldn't be adding the Greases. And then adding a large number of small countries, all else equal, makes you want to decentralize. So anyway, this is supposed to be a little framework paper with a few little ideas that has some, it helped us think through one aspect of what fiscal authority should be. And it's certainly not the end all, but it was kind of fun doing it. Thank you.
Okay, so you're reached the last paper of the day. So the Salvador is going to talk about accounting for credibility, and the discussion leader is Luisa.
All right. Thank you very much for including the paper in the program. This is always like, I don't know, the best workshop of the year, I would say. This is joined with Luigi, that is not here, Gaston, and Rishab. So the motivation for the paper is that starting in the 80s and the 90s, a large chunk of emerging market economies and also advanced and emerging market economies, they started to delegate their monetary policy, the conduct of monetary policy, to independent central bank with a type of inflation targeting mandate. Okay, and the stated goal for this delegation was to insulate the conduct of monetary policy from fiscal policy consideration. Okay, however, we can write down on a piece of paper, central bank just do an inflation targeting of 2%, but that's not necessarily that credible if you just rewrite it on a piece of paper, because government, they always have the option to either passing a law, there may be some supermajority consideration, but they can always take the dependence away. Okay, so the effectiveness of these measures and this delegation critically depends on the credibility of this delegation, whether is the government, when push comes to shove, going to take the independence away or not. Okay, so the questions we want to try to answer in this paper is whether, under which condition, delegation to an independent central bank is more likely to be effective, okay, and to influence the conduct of monetary policy. And second, and most importantly, what was the role played by this delegation, by this new institution, to account for the dynamics of inflation and debt in emerging market economies in particular. Okay, the idea is that if the disinflation that we observe in the 90s in advanced and emerging market economies simply driven by lack or fundamentals, or these institutional shift as some important role. Okay. Now, to answer this question, what we do, we try to go back to basic. Okay. So we're going to write an economy in the tradition of Sargent and Wallace, when there is some interaction between fiscal and monetary policy. Now, the economy is going to be driven by two types of shocks. Okay. One, what we call the fundamental shock. That's, as Pat was saying, I always put some data that moves the marginal utility of the guy so that if they're very hungry, they want to eat more. Now, this data here will be our fundamental, which will be a catch-all term for different things, and capture the marginal utility of government expenditure. And then we have some other shock. We call it, institution of reputational losses, which will capture some cost of undermining the central bank independence. Okay. Well, this will be thought to be the novel feature here. Now, we're going to show that in this environment, the economy is endogenously fluctuating between two regimes. Here we are borrowing some language from other literature. So there's like a monetary dominant regime, which is one word in which the fiscal authority is letting the monetary authority satisfy its inflation target. Okay, or a fiscal dominant regime in which the fiscal authority is sort of meddling with monetary policy and asking the central bank to do certain things, and the inflation target is not going to be satisfied. Okay. Now we're going to show that these two regimes, they have very distinct predictions for the joint dynamics of debt and inflation. In particular, what's very informative is the dynamic in disinflations. Okay. Now disinflation can happen for two reasons, either because of fundamentals. So the government is not that hungry, fiscal fundamentals are good. So now inflation is going to go down, even if you are in the fiscal dominant regime, simply because there's low fiscal needs and the government doesn't have to reduce the value of its nominal liabilities. But since I'm not that hungry, that is going to be declining for standard tax smoothing reason. Okay. So then we have like a dynamic of low inflation or declining inflation and a declining path for the debt. Now, low inflation or disinflation can also happen because it's not that the government likes spending less, but simply because now institutional costs of deviating from the inflation target now are much larger. Okay, so and leading to a switch to a monetary dominant regime. So this revocation cost goes up. Now we're going to show, and I'll want to convince you for this, it'll take me a little bit, but that low inflation, low and declining inflation will be associated with a rising debt. Okay, so we can look at the dynamic of debt, if it's going up or going down, to sort of disentangle these forces. Okay, and another result we're going to show is that a world in which we have high debt and low inflation, credible monetary dominant regime is actually necessary to have that. Okay, and then we're going to use these identification logic to go using the model to understand the dynamic for different countries. Okay, today we're going to show you the example of US during the Great Inflation and Colombia. So like we have a Latin America calibration and the US one, and we have sort of compare the role and the measure of credibility that our model is generating with sort of the jure measure. Okay, we're going to show, for example, for the case of Colombia, that our model will say Colombia only start to have a credible central bank mandate in 98, while if you look at the jure measure, the reform was done in 91. Okay, and also during the Volcker disinflation, there's some slightly smaller, like slightly not sudden increase. Okay, so that's a plan I'm going to do today. Let me skip the related literature here. Okay, so the plan, I'm going to present the economy. Okay, this is sort of an example when I argue that several economies sort of fit in our framework. Then I'm going to describe how our policy is determined, describe the two types of disinflation, and then do the quantification. Okay, as I said before, with two examples. Okay, in the paper we have more, and we are working on more. Okay, so the economy is going to be relatively simple. So it's like a closed economy with some generic state ST. We have a standing household that cares about consumption. They don't like to work. They like real money balances. Okay, with Svensson-Nicolini timing. So this is the money they bring from yesterday, and they like public good. Okay. Now we're going to assume this essentially quasi-linear utility in consumption. So in a sense, we can think of this as being an open economy that they borrow at some rate beta. They will be essentially identical. There's some disutility for working, as I said. So we have all the separability, and this is our taste shock theta that affects the value that the government is getting, or the standing household is getting from getting public consumption good. Okay. And the state of the economy is moving theta. This will be our fundamental shock. And so the resource constraint, output in the economy, it's needed to finance, or is used for private consumption and public consumption. Okay, the government potentially can be more impatient than the standing household, like in some work that Mark has with Manuel and Gita in a series of papers. And the government finance G with distortion and labor income taxes. They can issue real debt, and they can issue money. Okay, so those are the three instruments that the government has at its disposal. Okay, so the equilibrium is relatively standard. So the household is maximizing. They have labor income taxes. We are also allowing for lump sum transfer. So the lump sum transfer can be positive. So the government cannot get resources from the household, but they can sort of give them back. So think of this as being, so this is the economy of like Ayagari, Marcet, Sargent, and Sepala. We're adding Calvo. Okay, so we have also the money part. Okay, so we have a way to give back resources to the households, and there's a government budget constraint, firm optimality, and market clearing. Okay. So now this economy, so we are interested in monetary and fiscal outcomes. Okay, so we're going to write a representation of this economy in which it's as if the government is choosing directly primary surpluses, delta, okay, the value of real balances phi. So think of this as being, the price of money in terms of the consumption good. Is sort of since we have money in the utility function, we need to sort of pay homage to Wallace a little bit so it doesn't hate us too much. So we follow his notation, and real debt B. Okay, and the government has an indirect utility function over primary surpluses, and clearly they care about the value of real balances. And the two constraints that we have is the government budget constraint, and there's like a money demand. Okay, so the Euler equation for money holders. Okay, so in a sense, this is similar to the Sargent and Wallace, in which you have the government budget constraint and a money demand here. Now, for the indirect utility function, and several economists will sort of map into this frame. Okay, clearly, if we don't have a quasi-linearity, the government can sort of use issuing that to manipulate the real interest rate. Okay, but if it's a small open economy, they will go through with no problem. Okay, so to derive the indirect utility function here, this is like some paper by Charlie taught me by Ayagari that did this. So from the first of the condition from the household for labor. So this is the marginal, the private marginal value of working, and the marginal disutility of working. Multiply everything by L. We get taxes, tax revenue today equal to this expression here that is related to the labor wage. Then we can define the surplus as being delta, as being tax revenues minus G. So this is the indirect utility function. So a problem that a static government that is tasked to raise at least a primary surplus of delta, they have to solve. Okay, so the larger the primary surplus, the bigger will have to be the labor wage. Okay, so this indirect utility function here captures all the cost of distortionary taxation. Okay, now this function here we can show that is decreasing, taking almost strictly decreasing, other than when delta is very negative, so that you can finance the efficient amount of government spending simply with the primary surplus, and is concave in delta. And the important thing here is that if I'm very hungry, so if theta is high, the marginal cost of taxation are going to be larger. Okay, so this part here with the negative, so that we have to flip it. Okay, so this is what we have from the indirect utility function. Yes.
So you have tau L in the top, right?
Yeah.
Call that total tax revenue.
Yes.
What is this delta?
Delta is primary surplus. Yes, yes, exactly. It's tau L minus G. Primary, right? Yes, tau L minus G. Do you agree with me?
Okay,
yes.
So that's like money, and then you have G in the utility function. Touch the G up there. That G in the utility.
This is G. Yes.
So that is only the money side, and then
No. This is actually the money side is away. This is a purely real part, right?
What you spend it on G.
Yes.
In the state, you get delta and S.
Correct. Because G I can choose it. G is a choice. I'm maxing out G, right? G is a choice. If I had no restriction here, right? I'll do, in our financial repression paper, we do the same thing with G exogenous. And so this term here is out. Right? So but here, I know that, I have to provide a primary surplus of delta because, I don't know, because of some reason, okay? And then I'm choosing, okay, how much taxes do I want to raise? How much G do I want to spend? Okay? If this constraint were out, right? The implementability, yes, G I'm picking it, yes.
You want to do less
Exactly.
taxes,
More,
taxes, spend more. It's the gap you need.
with the gap and how much you want. Yeah, that's all.
The useful change of value.
Yeah.
Yes, it's a user change of variable, right? Exactly. Because yeah.
I got it.
We're not thinking of maybe a big business cycle model of what generates the cost of it. At some level, we can specify this directly, okay? Like Barrow did.
Don't do it.
We do this.
Yeah.
We do this, okay? Now, second bit. Now, for the dynamic stuff, so for the dynamic implementability condition, we have the money demand equation. So this is because of quasi-linear utility. This is the cost of bringing 1 unit of money tomorrow. That gives me some marginal utility because I can buy the consumption good, and this is the value for the real money balances, okay? And this is real debt, so the price is simply.
That looks like Canadian money.
Yes, yes, yes. Now, we're going to normalize things by just a notation issue by the amount of money we bring from yesterday. So this is what I'm going to define my, well, lowercase variables are simply normalized by the amount of money. Phi, you can think of it as being both the real money balances or, you know, the inverse of the normalized price level. Please.
Depends on the state because there are shocks.
Correct. And it depends on the state because this G over here, right? How much do I value? There's a preference shock to government spending. Yes, and that's the thing that is moving around. Okay, so in a sense, yes, that's our fundamental bit. Okay. Now, given this normalization, then I know that okay, a fiscal and monetary outcome is a primary surplus delta, some real debt, the real balances, right? Yes, and the mu, okay, those are implementable as an equilibrium if the government budget constraint holds in every period. So this is the real value of that, so the real debt B plus the value of nominal liabilities, okay? They're gonna be equal to the primary surplus plus new debt I issue and new money I issue, okay? Yeah, mu is the growth rate of money, sorry, yes. I hope I did. Yes, I didn't say it, but yes. Yes. All right. All right. Then we have our money demand equation, okay, which all our normalization. This expression over here can be expressed as this, okay? And I'm going to call the marginal value of money tomorrow. So the part, you know, I can buy consumption and this bit here as H, okay? And, you know, for this to be feasible, it gotta be that, you know, the primary surplus cannot be below the top of the static Laffer curve, okay? Because, you know, I can, question?
Phi is M over P.
Phi is M over, yes. Phi is both M over P and 1 over little p, right? Because.
So the left side is real debt. The second side is growth rate of.
So this is.
That's seniorage?
No, seniorage. Give me a, do I erase it? Give me a second. I don't have the dynamic. No, seniorage is slightly different, right? Oof, I don't have it here.
You can just tell me. So that's
Yeah.
real debt on the left.
Yes,
Yeah.
that's real debt on the left.
I see the primary surplus.
Yes, this is the primary surplus, real debt I issue, and this is the amount of money I issue, okay? Seniorage is the net present. Yeah. Is the seniorage would be the present. Oh, fee is the money I bring into tomorrow. Yeah. Mu, this is the money growth rate. Yes. Yeah, exactly. Here I'm putting, this is MT plus 1. This is BT plus 1 times, you know, times the price, and this is the money. Okay. Yeah. No, but seniorage is the extra bit I'm getting, right? So seniorage would be this V prime here, right? Which is the, I don't know, now we call it the convenience yield you get on issuing money. Uh-huh. Well,
That is in fact your list one.
there's this one, yes. Yeah. Yeah, okay. That's in. Okay, then it's in.
That's old fashioned guy,
No.
but MT minus minus 1. Over P.
Oh, and PT, that would be, this guy, take this on this side, I'm not quite sure about that. I say the seniorage is, but okay. So once we know this, we care about inflation, so inflation is this object here, simply pt minus 1 over, that's 1 over pt minus 1 over pt over here, and this is the value for the government. It's sort of in recursive notation, okay? So that's our economy. Now, as a warm-up, let's consider first the Ramsey outcome, okay? So why, at some level, maybe, not nice, whatever. It may be, let me use nice, for lack of a better word, to delegate monetary policy to a central bank with an inflation targeting mandate. Well, in this economy, if we have isoelastic money utility function for money, okay, let's assume the elasticity here is less than 1, so that everything is nice and concave. The Friedman rule is optimal in this economy. Okay, so I never want to get an inflation tax. In particular, if there's like a maximal, if there's an upper bound, if I don't want to go to phi to infinity, there's an upper bound phi star here. Then I'm going to hit this phi star from period 1 onwards. Okay, and inflation is simply pinned down by this expression here. Okay, so in a sense, in the Ramsey outcome, under this condition, it's optimal to have delegation to a monetary authority that keep a constant inflation targeting. Yes. Correct.
And then you think delegating fee to an authority?
Yeah, there will be a way to implement the Ramsey outcome.
Model, then you represent in a particular way with variables. And you gave us these names, and now I'm the monetary policy, but they're combinations of the stuff in the underlying model that don't resemble one institution at all.
Wait, okay.
Why do you call that?
P is the amount of money, so I have. Yes.
These are combinations. You start with a model with that real structural stuff like I's, interest rates, and debt.
Mm-hmm.
These are combinations of those things that came from the implementation of it. It doesn't. That's not. These are not institutions today. They're not. But central banks today don't give money and give it to households.
Well, okay, fair. No, okay. So, I mean, there's like a money demand equation. So rather than choosing M, we can always choose I, and there's no issue here, Greg. No, of course. But okay, there's a couple. Okay. Again. This is the set of equilibrium outcome, okay, that I can generate, okay? And out of this, there's some interest rate, okay? Then I'm saying Ramsey problem is that among this class of, among this set of equilibrium, I'm picking the best one, okay? All right, and I'm telling you that the best one has this property for inflation is constant, okay? And you follow the Friedman rule, okay? Now, then, second bit, I'm gonna say, okay, the interpretation is that given that this is the Ramsey outcome, one way to implement the Ramsey outcome is to say, I write down in the Constitution, there's an object called monetary authority, okay? That their goal is to, no matter what, deliver this number pi r, okay? Fiscal authority, given this number pi r, this number here is generating some transfer from the monetary authority to the fiscal authority, depending on, if technically, if this phi star is infinity, the transfer goes the other way around, okay? Because I need to give resources to the monetary authority to sort of implement the Friedman rule. But the fiscal authority then is just, solving the standard tax smoothing problem, knowing that they're gonna get some transfer from the monetary authority that are predetermined, okay? So there will be a way to implement, okay, with the sort of, like in an institutional sense, okay, the Ramsey outcome, okay? All right, now, so there would be one, it may be attractive, okay, and the Ramsey outcome, the monetary authority tasked with implementing these inflation rate, clearly, doing money or doing nominal interest rate, that's sort of equivalent, okay, right? Now, but I agree that here requires commitment, okay, and the point I want to make is that, Ramsey outcome is not time inconsistent. That's all we want to do. Okay. All right. Now, Because why? Well, ex post, the government want to reduce the value of real balances. Okay, and then we hit a wall because, okay, as Chari and Pat, among others, show, well, there's like a continuum of subgame perfect equilibrium for this game. Okay, now you can solve for the best, you can solve for the Markov, that is typically the worst, but everything in between, in particular, if you want to confront the model with the data, right? It's not obvious that the best sustainable equilibrium is, the relevant outcome. I mean, it's clearly not obvious that the Markov is also the relevant outcome. Okay. Now, but it's true also that governments is try to manipulate expectations somehow. Okay, so we need to take a little bit of a stand. Now, what we're doing here, we're doing the following. Okay, so and this is where the cost of revoking the mandate enters in. Okay. So we're going to say, suppose that in each period, the government is trying to pre-commit to what is going to be inflation next period. Okay, so they state an inflation target, call it pi star. Okay, that for us, given the structure of our economy, we'll see it in a second, is equivalent to promising some value of real balances tomorrow. Okay, now you promise the inflation target, you tell your central bank, just do that, or you tell them to do that. Then tomorrow comes about. This fiscal authority, and by fiscal authority, when I say government and fiscal authority, to me, they're sort of the same. Okay, because the government always has the option to, take the independence away, change the mandate. They can do that, but if they do that, they're going to pay a cost psi. Okay, that depends on the state of the world. So our state, our exogenous shock will be theta and psi. Now, what this psi stands for? A lot of things. Now, it can stand for reputational losses or coordination on the worst equilibrium. So think about, in a sustainable plans type of logic, it can be, if you deviate from what you promise, you can go to the worst equilibrium, you can go to the worst equilibrium plus epsilon in terms of value, okay? This psi here, and we have, at least in a deterministic economy, a partial equivalence, it determines how harshly you're punished upon deviation, okay? Or it can be even, more literally, a constitutional court, does the Supreme Court let the government just go freely, when they intervene? Or maybe, when you change the mandate of the central bank, you need some supermajority. You're party one, you need party two to also come along with you, and maybe you have to do more spending in something that party two likes more than party one, okay, to convince them, okay? Yes. Yes.
Depends somehow exactly which one of those things are happening.
Yes and no. Yes. But I want to do the following. So my goal here is do the flip. Okay, it's saying, okay, what I want to do here. Okay, that's why we have the word accounting in the title. Okay, so all right. Now I want to understand. The goal here is to understand. We have accounting and wedge. Okay, so now. So we want to understand how equilibrium outcomes are shaped by movement in psi. Okay? Then I want to use this relationship to, this restriction that the model imposes, okay? Or, the super, this restriction here to go to the data and infer psi. Then I can try to use that to try to understand, there's several deeper model of movement, of how psi is determined. There can be some reputation model with hidden types, a la Maillard, or different like deeper model of movement in this cost. They will have different implication for this psi and the cover and the. Yeah. Here we're not. Yeah. Here we're not. But to promising an inflation target. Okay, because I'm sitting here. I promise phi prime. I know the amount of mu and phi today, so they're equivalent. Okay. Now there can be two regimes. One in which I'm not. I'm satisfying the target. The value function will be VMD. One in which I'm deviating. Okay, VFT. The value is going to be this. Okay, ex ante, maybe before the choices. Okay, So I'm choosing either to satisfy the target or to deviate. Okay, if I deviate, phi is not in my state anymore because I can choose whatever I want. Okay, and eta will be an indicator whether the target is satisfied or not. Now, yeah, I'm gonna show you here. The one in which respect the target, MD, or deviate. Now, if I respect the target, phi is in the state, I gotta deliver it. Okay, so my central banker, they're committed to do that unless they're pulled away, unless they're forced not. Okay, so I can still choose the primary balance, the primary surplus, new debt tomorrow, money growth rate, and the new inflation target. Okay, to maximize these, my objective function subject to government budget constraint and a recursive version of the money demand equation. Okay, where this is money, the marginal cost of bringing money, and this is the marginal benefit tomorrow. Okay, this will be an equilibrium object. Okay, I'm not going to show you. Now, if we are in the fiscal dominance, so I'm paying this cost xi to deviate. Now I get to choose phi because phi is not in my state anymore. I get to choose phi. Okay, I get to print a little bit more money. That will reduce the value of real balances, but I get to do it. I have to pay a cost fee. Okay, now the cost is fixed here. Okay, so it's not going to be a quadratic cost. Now this is the same problem.
Just a lump cost.
It's a lump cost. Yes, that's what I mean. These two are the same. This value here is going to be lower because here, I'm inheriting fee. I got to deliver. Here, I got to choose fee. Okay, so clearly this value is going to be high. Okay, and here, if we just take first the condition, there's like a tight relationship between fiscal needs and the amount of real balances, because clearly I'm statically equating the marginal cost of taxation, the marginal cost of raising a primary surplus to the value of real balances. Okay, so this will be what happens in a Markov equilibrium, in a Markov perfect equilibrium. Okay, now.
You think about this like in the context of trigger strategy, it's a bit weird because the continuation value is.
That's correct. That's correct.
Going back to the original equilibrium.
That's correct.
And it's not clear how.
That's correct. That's why I said I agree with you. That's why I said the equivalence hold in a world with no shock. Where yes, here yes, I agree with you.
I interpret this like Mr. Barrett. It's utility losses.
There's a utility loss. Yes. Now it will be true. If I'm allowed to have like some this is I don't know, the analogy is a model of default. You can have incomplete market and you can have arrow securities. Okay, if you have arrow securities, the default cost only you just touch it. Okay, you just issue that until you're indifferent between defaulting or not. There will be a world in which this fee here, the value of real balances, can be state contingent, so it can depend on S prime over here. Okay, now they will. Pretty much everything I'm doing here will also carry through that environment. It will not have the interpretation of the two regime, right? Because I always satisfy my promise, okay? Just that if the external cost of breaking the promise is very low, the equilibrium outcome will look like very much like the Markov equilibrium, okay? So that in that sense, that is the same. Okay, I want to stress here. Now, clearly, this model here, given like a process for Xi, I have 25 minutes. Yeah, please, of course.
I didn't quite get your answer. So, say it again. You're trying to tell me that equivalence.
Yeah.
Do a simple version of that.
Yeah. Give me a second. Yeah.
In the normal equilibrium, when you take around the whole continuation chain, it has a value. All you really need to know is the value to solve what you do now.
Yeah.
And you're saying.
So what Mark said.
Get the value would be the same when you took off this period loss, and you said. Then you gave a wrong answer. I lost.
Okay. So what Mark said. Let me rephrase it. Okay. So what Mark said is that in sustainable equilibrium, right, the value of a deviation only happened off equilibrium path.
Yeah.
Okay. Now that clearly they change my behavior today, right? But I'm never gonna go there.
Yeah.
All right. Perfect. Yeah, I don't want to, yeah, okay. Now, here is not, because here there's potentially, because it's as if, I'm promising one level of inflation uncontingent of the state of the world tomorrow. So it's possible that tomorrow I'm going to break my promise. In the actual equilibrium, here in the actual equilibrium. In this equilibrium I'm considering here. Okay, so the deeper equivalence between this and the set of sustainable equilibrium hold only in the world in which there's no, like C is like a sequence. There's no shock, there's no uncertainty. Then I'm never going to break my promise. Okay, and then I said it's the equivalence of, you have an economy with lack of commitment. If you can issue state contingent debt, you'll never default. Just that, the punishment just, why not?
This as in fact as a stable equilibrium. Now think about an equilibrium sequence where P depends on X, the entire sequence. For some reason, my payoff is such that whenever P deviates from some particular number that I promised, because I'm forced to promise a state contingent number, right?
It's a smaller set of subgame. I agree with you. Yeah, no, of course, it is. Yes, it's the other way around, right? This is clearly, yes, of course. This is subgame perfect equilibrium in the bigger set. The question is, any subgame perfect equilibrium can be recovered through this? That's what I'm saying. Absolutely. No. No, I need, no, that's not, because I mean, I can have it history dependent based on S super T, okay? But I will need the phi over here that I'm promised to depend on ST plus 1. Okay, and that's why I said if I have deterministic economy, it's as if I can.
It doesn't go the other way.
It doesn't go the other way. Yes, this is a subgame perfect equilibrium, the other way is not true. Okay, and there's also it's not the full set. I'm saying this since this is a teched up audience. Okay, this is also imposing an extra restriction that essentially we're not allowing for deviation where the government at T plus 1 can do things that you can have subgame perfect equilibrium when the government at T plus 1 doesn't take an action, doesn't take a policy that makes government at T plus 1 better off and government at T better off. Simply because if I do that, then we revert to some bad equilibrium. Here we are ruling those out. Okay, but other than that, yes. So we think this is a tasteful way to sort of summarize a larger, tasteful, I said myself, but I say myself, then you can agree or not, that's okay. That's okay. Now, but this, the Ramsey outcome is Xi, this cost is always very large. If Xi is 0, then we get the Markov equilibrium and everything in between. And then that's what I was saying to you, Shebnem, before, different processes for this Xi can sort of capture different, different both deeper model and different episodes. And then we want to try to use this to try to understand and discriminate also different models, okay? Because, if this Xi look like a step function, then, they can be like the Sargent end of 4 big inflation, okay? Where it's 0, we inflate a lot, and then boom, it goes to a very large number. Or, it can be gradual, maybe because like in a model of learning about hidden types, it takes time for the prior to increase, and then maybe more consistent with Volcker disinflation. Okay.
Alessandro, you said something about how when Xi is constant instead of time varying, then maybe you don't have on equilibrium that you switch between regimes. But I think even then you can do it, right? Because you have still the theta preference shocks for government spending.
Absolutely.
And so even if the Xi wasn't moving at all, you could still switch in between. Xi shocks are just one way, I guess, to.
I agree with that. I agree with that. Yes, I agree with that. That's precisely this slide, right? Because here we can use this expression here, to see where is the target satisfied. Okay. So clearly we know that the value of the fiscal dominant regime, where I can re-optimize about the value of money balance, if this term is absent, clearly here I'm maximizing. Okay, so clearly this is bigger than that. Okay, so then how much, what's the likelihood that I'm satisfying the target? Okay, now as you were suggesting, Ludwig, right? So a couple of things. If the target is less ambitious, right, then it's more likely that I'm satisfying the target. By less ambitious, I mean closer to the statically optimum, right? Now, if C is very large, then it's more likely that they're satisfied. That's kind of obvious. Now, as you were saying, Ludwig, right, if either my if I'm not that, my fiscal needs are low, then it's more likely to satisfy the target. And the same thing is if the amount of debt is very low, it's more likely to satisfy the target, right? So for a fixed C, it's possible, right, that I start with some low level of debt and low level of theta, then I satisfy the target, then theta goes up, and then I issue more debt, and I may not be willing to go through with the target. Yes.
You are saving time. Beautiful quantitative application.
Of course. I have 20 minutes, right? All right. So, but first I need to explain, right? So, all right. So two things I wanna. So the inflation target clearly is going to be distorted relative to the Ramsey outcome downward, okay? Because by distorting it downward, the next period government is more likely to satisfy the target, okay? That may be better than just like do what is statically optimal, okay? And clearly, good. The inflation is lower or the value downward. Good question. Yeah. So fee. So I promise lower fee is lower real balances. So
low real balance there or higher.
Correct. Yeah, higher inflation, lower. Yeah.
Okay.
Yes. Higher. Perfect. Yes. If downward, yes, I agree with that. Upward, like I put rather than doing 2% inflation, we do 5. Okay, because 2 is too much. Okay, I know that you're not gonna do it. Okay. Now, okay, this is gonna be key. Okay, for all our quantification. So, what about debt issuance? Well, the Euler equation for debt accumulation satisfies this condition here, where J is the value of real balance that I'm issuing today. Okay, so because by issuing more debt, I'm doing two things. I'm putting more stress to tomorrow's government. Okay, so tomorrow's government, if they are in the monetary dominant regime and they have higher debt, if they inherit higher debt, they're both more likely to switch to the fiscal dominant regime because I have a lot of fiscal pressure and satisfying whatever I promise is costly for me. So I may switch. And moreover, even if I switch, conditional on switching to the fiscal dominant regime, so I'm re-optimizing, if I inherit a low amount of debt, I'm not that desperate, so I'm gonna do a little bit less debt. Okay, that's this is relaxing the sustainability constraint if you want. This is conditional on me deviating. We're not gonna do big damage, okay? Because I'm controlling by passing the state to be not to have very large fiscal needs. I'm incentivizing tomorrow's government, even if they're statically maximizing, not to do something very bad. Okay. So then this incentive wedge here acts like a tax on the issuance of debt for the government. Okay, because today's government, to try to control itself tomorrow or its successor, is issuing a little bit less debt. And J is the expected marginal value of money. Is this object here? Okay, because the amount of resources I'm getting by printing money depends on the expectation of the marginal value of money tomorrow. If I issue less debt, the expected marginal value of money tomorrow is going to be higher. Okay, because either I'm satisfying the target more often, or conditional on not satisfying the target, I'm not doing such crazy policies. Therefore, people today are willing to get a lot of, buy a lot of my money. Yes. That shows up, where are you? So that shows up with the tax smoothing. My today cost of tax distortion is equal to the expected value, the derivative of value function tomorrow relative to B prime. is the DJ part here, right? I think I wrote it here. No, I didn't. Yes, I did. In the Ramsey outcome, this term is 0. Okay, and if you do the envelope condition, this is a standard Euler equation for the marginal cost of taxation. In the Ramsey outcome, remember, it's just like Ayagari, Marcet, Sepala Sartre. Okay, with that. And what I want to say is that clearly in a Markov equilibrium, this is big. In the Ramsey, is 0, and it turned out to be monotone. Okay, so that it's the larger is C, the smaller is this wedge. So the lower are my incentive to do some precautionary saving to incentivize tomorrow's government. Exactly, right? Because that's what I'm going to do here, right? But then I say, okay, so 2 types of inflation, fundamental and institutional. Fundamental, because the theta goes down, and that will go down. Institutional, inflation will go down, but that will go up, okay? So, all right, that's the key. So,
Alessandro,
yes,
quick
please.
question. So imagine you do not have your theta go down below, say, the mean or the median. Isn't it true that over time, there's some recovery too? Maybe it's much slower, but that debt over time in the fiscally dominant regime will come down. And at some point, it's so low that you feel like you can credibly promise something again. So there's some natural kind of feeling that happens.
Yes, it depends on the XC, right? That's why we are adding, it will be important in the calibration, right? That we have this beta hat here, so the discount factor of the government to be more impatient than the private agents, right? Because even in this economy, without this term, that itself, right? There's like a tendency to decumulate debt, or actually to accumulate asset, all right, in order to smooth taxes because of precautionary reason. Okay. Now here we are assuming that this beta hat, okay, practically I'm assuming to be sufficiently low so that this term is low. Okay. But now let's suppose we are Latin America in the 80s. Okay, Xi is 0. Current realization, we expect it to be very low tomorrow, so we are in the fiscal dominant regime. Okay, so the promised fee doesn't matter. Okay, because we don't care about it. Okay, so only B, the amount of real debt, is the only state variable in the economy. We are sitting at this amount of debt here that is not potentially 0 or some negative value precisely because of these extra discount. All right, and this is the amount of value for real balance that the government is generating. Okay, all right. Now, suppose now the theta goes down. Okay, so what happens? That now I need to generate. I can deliver a higher value for real balances, and because of tax smoothing reason, I'm gonna issue less debt. Okay, so now the value of real balances goes up. Debt is gonna go down. Here, debt will go to 0. And inflation will go up. It will go down. Okay? And all right. Now, that's what they said. Now, what can also happen? Okay. The other bit is that, well, I'm still in my old equilibrium. Okay? So theta remains high, but now C goes from 0 to a large number. Okay? So now 2 things happen. The state I have to change it because it's not only the value of real debt that I care. This here is my total real liabilities because now, since C is very large, then I'm going to deliver what I promised, okay? Because I don't want to pay the cost. So now what's going to happen? 2 things. 1, since C is, assuming C is persistent, the true thing that matters is that, it's a news shock about C prime tomorrow, okay? That goes up, so my promises are more credible on their own. I don't have to twist my level of debt to pass a more favorable state of the world to my successor. So the incentive wedge we had before goes down towards 0. So I can issue a little bit more debt. And I can be a little bit more ambitious for any level of real liabilities that I have to deliver. Okay. Moreover, a second thing that happened is that now, well, before my value of real liabilities was the real debt plus what I do statically. Okay? But now I'm delivering what I promised yesterday, which is going to be higher. So my value of real liability goes up. Now, for the amount of debt, it's like a double whammy. Okay? They both go up. Because the curve shift up because they have less reason to do incentive manipulation, and the amount of debt goes up. So my debt is going to go up. My inflation, so the amount of real balances I promise tomorrow that I'm going to deliver, now it's going to go up, but then a little bit down, okay, also, because now I have a little bit more debt. Okay? Now, let me skip this. So then we have this, okay, these are our impulse responses, okay? So I started to this way of high inflation and relatively low debt. Then if credibility of the institution go up, then inflation is going to go down, but debt is going to go up. Vice versa, if theta is going down, debt to GDP is decreasing, like in this blue line over here. Okay, so that's the central identification logic that we're going to try to use to confront the data. And in 10 minutes, I can do one thing. So one important thing I want to. Now, one may say, look, can it be that the causation goes the other way around? So suppose that I'm in this economy with a very tight debt limit. So I'm Colombia, I cannot borrow from the rest of the world. Now the debt limit relaxes. Now I'm borrowing from the rest of the world, primary surplus, since I'm borrowing from the rest of the world, or from my house, okay, for whatever it's worth. Then I can run a smaller primary, I can run a smaller primary surplus, maybe even a deficit. Then I have less pressure to reduce the value of my debt. Now, can that generate inflation going down? Because now I have lower fiscal need because I can borrow. And debt goes up because of the relaxation. The answer is yes at the very short term, but not in the long run. Not, because if there's no, and that's the sense in which credible institutions are necessary for having high debt and low inflation. At the beginning, as the debt limit, as the borrowing limit goes up, then inflation is tanking because now my surplus can go down, can be negative, okay? And so I don't need to generate inflation to balance my budget. But then eventually, as the debt accumulates, then eventually I have to service the debt. Once I'm servicing the debt, my surplus is going to be higher than before, okay? So at a relatively low frequency, like this model, absent a change in the institution, it's incapable to generate high debt and low inflation, okay? Now, the low free, there can be shocks that, in the short run puts debt and inflation in opposite direction, but not in the long run, okay? Now, all right, so let's go to Colombia. How do we go back here? So, all right, so what do we do with our sort of collection of models, okay? So we calibrate the model to match properties for inflation, surpluses, and debt to GDP for all the Latin American economies. We have data from the Tim Keogh and Nicolini book, and for the US, okay? And then what we're going to do, we're going to use the particle filter to, with the calibrated model, to recover these two shocks, and then run a counterfactual, okay? So which part of the movement in inflation and debt is driven by Xi versus the fundamental, okay? And then we can sort of also derive a measure of the credibility of the institutional setting, which is the probability that tomorrow we are satisfying the. No, we have two. For of observables, we're going to have inflation and debt to GDP. Yeah. So this is what we do. We have a bunch of moments here, okay, to calibrate the parameter. Yeah. Okay. Then we have inflation and debt to GDP.
Is determined by the history of time and health.
That's correct. And that's
right. It's not an independent variable. You've got two shocks.
Yes.
It looks like three series, but they're really
no two. Sorry. This is what we're using to calibrate. Okay, and there's even M over P. Okay, so there's even more actually. Okay, so this is what we're using to calibrate. Then what we are doing, I'll come back to this. The two series we are looking at is inflation and debt to GDP. And we are backing out the Xi and the theta that capture this. Okay, we have more variables for the calibration of the model. Okay, now this is Colombia. So a couple of institutional details. So Colombia, they enshrine in the constitution in 91 that the central bank is independent and they should not monetize the debt. Okay, and the full inflation targeting was in either 2000 or 2001. I forgot. Okay. But even in study from 91, they sort of declare an inflation target for the following periods. Okay. Now, and you see here that starting in 91, inflation declined. Okay, from 30 something percent to about 5% in this period over here. And an important thing is that in 98, Colombia went to one of the most largest recession in their history with a big financial crisis, and central bank had to bail out a bunch of financial institutions. Okay, however, they bailed out financial institutions, but they did not print money to finance the bailout. Okay, because inflation in 98 remained, actually it dropped, if any. Okay, while debt to GDP went up a lot, precisely because the government and the central bank, they had to they choose to rescue financial institutions. Now, how does the model interpret this data? Okay, so the initial part of the reduction in inflation from 90 to, let's say, 97 is driven by, or 95, is driven by a reduction in fundamental. Okay, so despite the fact that there was this reform, the Xi here remains to zero for us. Okay, so there was not a switch to the model that interpret the data as being a switch to the monetary dominant regime. Okay, only in 98, where there's this inflation stay down and debt to GDP goes to the roof, then the model says, theta jumps up. Why? To account for the large increase in debt. Okay, and that's consistent with the narrative of Colombia, where there was like a severe crisis with very large fiscal needs for the government. To account for a reduction in inflation, Xi had to go up. Okay.
So one thing that's a little strange about the Xi plot is that it moves exactly during the crisis, right? You would have thought that maybe already in 91, Xi starts moving up, and then you benefit from it during the crisis. And I was wondering whether you even can identify exactly whether the Xi was zero or whether it was slightly positive, because if you're in the right, it's like maybe set identified. So maybe you could even have that story be there. It's just that you stick to the fiscally dominant regime during that, initial 90s period.
So small movement, I mean, it's harder because the thing that matters is the expectations, right? Not what you're doing today, right? Yeah. So then whether it's zero, I mean, the point is, there's a low credibility of the regime, precisely because we see that, theta went down. Okay, there was a debt accumulation. The model interpret this as not really as an increase in theta. Okay, now the model is very well identified when debt goes up and inflation goes down. When we have both going down, it's a little bit more. It's a little bit more tricky. And I wanna, please.
Question. Is it C that will rationalize this? But if you had even a bigger C, would we also be able to rationalize?
Not necessarily, because then this level of debt to GDP will go even higher and inflation will be a little bit lower, right? Because we are not, yes, we are pointing through the expectations.
So it's not just an inequality.
It's not an inequality constraint, right? It's not that today I meet it, okay? It's the expectation that tomorrow, actually, if the fact that I respect it today is just like a sideshow. If you have some news shock about Xi prime, that's what really matters in this model, okay? Yeah, that's fair. Yes, that's true. At that level, there's a set, but the fact that I'm not doing Ramsey tells us that I'm still a little bit below. Okay, that's the thing. Yes, but I agree with you that between 10 times lifetime utility and 15 times. Yes, I agree with that. I agree with that part. Okay, and that's interesting. Also, going back to what Seblen said, this points to deeper model, right? Because think about in a model with the reputation, When you learn about the type of the central banker, when faced with a crisis, Xi went up. So the fact that we're finding this, that this goes up only in bad time, really in bad times, not when I just make an announcement in relatively good times, that points to a certain class of model. So that's kind of, we find that interesting. And yes, almost done. So just to understand here, if Xi were 0, so how do we gauge the contribution of Xi? So suppose that Xi stays 0 all throughout, okay? Then you say two things. The inflation in 98, living data would have skyrocketed, and consistent with the incentive effect, that would have not go up as much, right? Because I'm trying to incentivize the guy, okay? So that's what we do. Now, US, just like quicker. So we see two things, and it's kind of interesting because the model is getting the great inflation as a period of a drop in, this is the actual regime, but a drop in credibility, okay? And then with the appointment of Volcker, relatively gradually, this is going up, okay? And that's why, well, because in 81, debt to GDP went up, okay? And, we have also the case, the case of Italy is too, when they give independence to the central bank, debt to GDP went up, and that's consistent with so a successful institutional force, okay? And that's just my conclusion. Slide, happy to answer questions if there's any. No? All right. Thank you then.
Wait, Mark, say something.
No, you go ahead.
We're debating what? We're debating, what? Have like a mini? We're debating, should we hang out there and then figure out if a group wants to go to dinner? That's what I was trying to get them to